Okay, so now, hello everyone, let us start talking about indifference curve from utility function. In the last class, I had already gone ahead and talked about what is a level set. हमने level set की बात कर ली थी. We talked about what is a level curve. Now let us try to understand how can we go ahead and draw a typical indifference curve. So जैसे for example, suppose I tell you utility is equal to x1 into x2. And we can keep utility constant. Because why am I keeping utility constant? So we know along an indifference curve, utility is kept constant. किसी भी एक indifference curve के along utility को constant रखा जाता है. So I can keep utility constant at some value k. At some value k. So what will I go ahead and what will I get? K is equal to x1 into x2. Right, beta? So from here, I will get x2 is equal to k divided by x1. K divided by x1. This is how you can derive any indifference curve. Okay. अब जैसे for example, suppose beta I tell you k is equal to 1. So x2 becomes 1 divided by x1. So when x1 will be 1, beta x2 क्या हो जाएगा? x2 will be 1. When x1 will be half, x2 will be 1 divided by 0.5, that means 2. When x1 will be 2, x2 will be 1 divided by 2, that means 0.5. So we can now plot this. How will we plot beta? यहाँ पे x1 ले लो. Take x2 here. x1 is 1, x2 is 1. 1, 1, this point. x1 is half. x2 is 2. 1, 2 and half. x1 is 2. x2 is half. ये वाला point. Join these points. This will be my indifference curve. Then you can change the value of k to get another indifference curve. So suppose now I take k is equal to 2. तो अब क्या आ जाएगा? x1 into x2 is equal to 2. x2 is equal to 2 divided by x1. फिर से take x1 as 1. What will be x2 beta? 2 divided by 1, which means 2. Take x1 as 2. What will be x2 beta? 2 divided by 2, which means 1. Take x1 as 4. What will be x2 beta? 2 divided by 4, that means half. So you can plot the next curve. When x1 is 1, x2 is 2. When x1 is 1, x2 is 2. Mane point. When x1 is 2, x2 is 1. So when x1 is 2, x2 is 1. That means this point. When x1 is 4, x2 is half. Mane 3, 4 with half, this point. So if I join these points, I will get next indifference curve IC2. So different values of k will give you different indifference curve. अलग-अलग k की वैल्यू से आपको अलग-अलग indifference curve मिलेंगे. Now suppose you are given that your utility function, that is x1 square, x2 square. ध्यान से देखना बेटा. It is x1 square, x2 square. So can I write this as x1 into x2 to the power 2? And you can see that this x1 into x2 is nothing but your old utility function that I had written. It is nothing but your old utility function. So isko can I write this as old utility function to the power 2. मेरा पहले utility function, what was my old utility function? x1 into x2, right? x1 into x2. So I can write it as a square of the old utility function. ठीक है बेटा, when we do this, when we reach the new utility function as a square product adding the old utility function, इसको क्या बोल देते हैं? This is called as monotonic transformation of old utility function. This is called as monotonic transformation of old utility function. Whenever monotonic transformation means what? That the new utility function can be square of old. पुराने वाले को square कर दो. You can go ahead and multiply some number to old. You can add some number to old. These are all monotonic transformations, beta. Whenever you will have any kind of monotonic transformation, then the shape of indifference curve will remain the same. The shape of indifference curve will remain the same. ठीक है, तो जो इससे हम डिराइव करेंगे इंडिफरेंस कर्व, उसका when we will plot the shape, it will come out to be exactly the same. That is the meaning of monotonic transformation. Clear है? Okay, so this is about how you can go ahead and you can derive your indifference curves. Now what we can do is we can look at some of the examples of indifference curve, and although अगर हम books में देखें then the book starts with substitute goods, but I want to take the first example as Cobb-Douglas preferences. Okay, सबसे पहले we will do Cobb-Douglas preferences. Cobb-Douglas preferences is when we write our utility function in this format: x1 to the power c, x2 to the power d. जब भी हम utility function को ऐसे लिखते हैं, x1 to the power c, x2 to the power d, then this is called as Cobb-Douglas utility function. The power c and d, it represents the importance or preference given to the two goods, right? This is giving us the importance or preference to the two goods. For example, beta, if C and D are equal to 1, suppose we take the example where C and D are equal to 1. I am giving you 1 minute. Try to plot this thing. What will happen? So you will get U is equal to x1 to the power 1, x2 to the power 1, माने x1 into x2. ये तो हमने अभी बनाया. This is what x1 into x2 was looking like. U is equal to x1 into x2. So we know that when U is equal to x1 into x2, then we were getting our indifference curves like this. ऐसा indifference curves आ रहा था. IC1, IC2, etc. This was good 1 and this is good 2. Right? Now what we can go ahead and we can do is we can try to go ahead and we can try taking different powers. तो मैं आपको दो questions दे रही हूँ. You need to quickly try this one, beta. So question number 1. So U is equal to x1 to the power half, x2 to the power half. You need to plot this. And U is equal to x1 to the power 1 by 5, x2 to the power 4 by 5. You need to plot this. How can we plot this beta? Very simple. I will take some value of u, कुछ u का value लेंगे और plot करेंगे. So if I go ahead and I take some value of u, जैसे if I hold u constant at 4. So I will get 4 is equal to the power half means root x1 into root x2. Clear? So suppose beta, from here, what will I get? If I solve for x2, x2 is equal to 4 divided by root x1 whole square. तो ये हो जाएगा 16 by x1. ये हो जाएगा 16 by x1. If you feel 4 is a bigger number, you can take a smaller number also. माने आप यहाँ पे 2 भी ले सकते हो. Right? You can take 2 also here. Whatever simplification you can do this. So from here, we get that we want this. x2 is equal to 4 by x1. Okay, beta. So what will happen? When x1 is 1, x2 will be 4 divided by 1, mane 4. When x1 will be 2, 4 divided by 2, that means 2. When x1 will be 4, 4 divided by 4, that means 1. अब इसको देखते हैं. Suppose I hold utility constant at 2. यहाँ पे भी हम 2 पे constant रखते हैं. So 2 is equal to x1 to the power 1 by 5, x2 to the power 4 by 5. x2 के लिए solve करेंगे हम. We'll solve it for the value of x2 beta. So x2 is equal to 2 divided by x1 to the power 1 by 5. ये हो गया x2 to the power 4 by 5. And this 4 by 5 power, उधर जाके it will reciprocal itself. It will reciprocate. So I will get x2 is equal to 2 upon x1 to the power 1 by 5 whole to the power 5 by 4. So this is going to be x2 is equal to 2 to the power 5 by 4 upon x1 to the power 4. Okay. Again, beta, you can take some values and try to take some value of x1, find x2. Use calculator 2 to the power 5 by 4 को find out using scientific calculator. कुछ यहाँ से values आपके पास आ जाएंगे. And here also you have got some values. So you will see that in both cases I have held utility constant at 2. मैंने दोनों ही केस में utility को 2 पे constant रखा है. But you will notice that, so suppose better, let me just solve this only for you. So let me quickly open the calculator. Give me a minute. So if I go ahead and I do 2 to the power 5 to the power 1 by 4, this is giving me 2.37. This is giving me 2.37. Okay. Divided by x1 to the power 4. So when I will take x1 को suppose मैंने यहाँ पे बेटा 1 लिया. So if x1 is 1, x2 क्या हो जाएगा? Plug 1. So you will get 2.37. Suppose बेटा x2 को मैंने x1 को 2 लिया. Right? So 2 into 2, 4 into 2, 8 into 2, 16. Denominator will be 16. So 2.37 divided by 16. This will be 0.148. So you see कि x1 का value जब यहाँ 1 था, x2 was 4. Here when x1 is 1, x2 is 2.35. Here when x1 was 2, this was 2. Here when x1 is 2, this is 0.48. Mane the shape will differ. The shape is not the same. So if I were to plot this first graph, if I take 1, 2, 3, 1, 2, 3. So 1 के साथ x1 1 के साथ x2 is 4. So 4. x1 1 के साथ x2 is 4. x1 2 के साथ x2 is 2. So x1 2 के साथ x2 is 2. x1 4 के साथ x2 is 1. So x1 4 के साथ x2 is 1. So this is my shape. This is going to be my shape in the first case, right? Now look at the second case. When x1 is 1, x2 is 2.37. When x1 is 1, x2 is 2.37. It means somewhere here. 2.3. Huh? When x1 is 2, x2 is 0.14. So when x1 is 2, x2 is a decimal, माने here. So you see कि ये वाला shape ऐसा कुछ आएगा. ये वाला है. It is becoming very steep like this. And the other one is flat. You notice? So माने as we change the powers, जैसे जैसे हम ये powers change करेंगे, the answer that we will be getting will be different. We will be getting different answers. Right? So there is some importance to these powers. ऐसे ही ये powers नहीं हैं. Right? There is some importance. एक और चीज देखो. When x1 is increased by 1 unit, I am giving 2 units of x2 यहाँ पे. So when I increase x1 by 1 unit, I am giving how many units of x2 beta? 2 units. And यहाँ पे when I increase x1 by 1 unit, how many units of x2 am I giving up beta? 2.37 minus 0.18, more than 2 units, right? 2.37 minus 0.148, so 2.22 units. मेरा ट्रेड ऑफ भी सेम नहीं है. The amount of good 2 I am giving up for an additional unit of good 1 is also different, right? So please write down this with me. The shape of ICs depend on the value of C and D. It depends on the value of C and D. एक और बात लिखो. The Cobb-Douglas preferences are called well-defined preferences as they are convex to origin with diminishing MRS. तो देखो ये convex है. The shape is convex. You remember what convexity was? हमने पढ़ा था weighted average preferred over extreme values. So these are convex to origin and therefore they can be called as the well-defined preferences. Now take beta. So write down log transformation of Cobb-Douglas preferences. तो अब हम क्या कर सकते हैं? We can do a log transformation बेटा. For log transformation, I want to teach 2 rules. Log m to the power n. अगर n power में है, then power comes down. Power नीचे आ जाता है. Second, if you are finding product log mn, तो you can rewrite this as log m plus log n. Third beta, if you have log m divided by n, so this will become log m minus log n. These are the 3 important rules of log. Okay, now let's take an example beta. Suppose your utility function is ln. Suppose आपका utility function है x1 to the power c, x2 to the power d. ठीक है, and we want to do log transformation. हमें इसका log transformation करना है. So I will take log on both sides. Log u is equal to log x1 to the power c, x2 to the power d. Beta, these are getting multiplied now. So whenever they will get multiplied, you can add. So just add this. ये क्या हो जाएगा? Log x1 to the power c plus log x2 to the power d. Then whenever you see power, power will come down. So this will become c log x1 plus d log x2. C log x1 plus d log x2. This is nothing but your log of u. Beta, this is called as monotonic transformation of the utility function. हमने अपने utility function में log लेकर utility function को transform किया है. तो when suppose someone asks you, suppose someone says in exam कि what will be, what will be the shape of plot u is equal to a log x plus b log y utility function. इस फंक्शन को प्लॉट करो a log x plus b log y, तो हमने क्या सीखा that whenever you do a monotonic transformation of a utility function, then you will get the same shape. You will get the same shape. तो ये वाला जो यूटिलिटी फंक्शन है, दिस इज ऑल्सो मोनोटोनिक ट्रांसफॉर्मेशन ओनली बेटा. In the background, the utility function is x1 to the power c, x2 to the power d. In the background, the utility function is x to the power a, y to the power b. And we have seen that this is Cobb-Douglas utility function. ये Cobb-Douglas utility function होता है. And we know that for Cobb-Douglas utility function, the indifference curve are convex ICs. ऐसे दिखते हैं ICs. So you will simply plot an indifference curve like this. कि ऐसा indifference curve लगेगा. This is how the indifference curve looks like. That is it. Right? Another way of interpreting this indifference curve can be the following. So suppose I tell you that your utility function is x1 to the power c, x2 to the power d. ठीक है. अब one way of doing monotonic transformation is by raising the power. By raising the power. So मैंने क्या किया? I have raised both sides to the power of 1 upon c plus d is equal to x1 c upon c plus d, x2 d upon c plus d. समझे? I have raised power. It is a monotonic transformation. Raising power is also allowed. वो भी कर सकते हो, वो भी monotonic transformation ही है. Now c upon c plus d, beta, that can be called as sum a. So suppose a is equal to c upon c plus d. ठीक है. तो बेटा एक बात बताओ मुझे, what can d upon c plus d be written as? क्या मैं इसको 1 minus a लिख सकती हूँ? Yes, ma'am, I can write this. 1 minus a means 1 minus c upon c plus d. माने this will be c plus d minus c upon c plus d. माने this will be d upon c plus d. So d upon c plus d को हम 1 minus a और c upon c plus d को a can be written like that. So this will become this. So this is another way of writing Cobb-Douglas utility function. This is also Cobb-Douglas utility function where the sum of power is 1. Where the sum of power is 1. ये एक तरीका है monotonic transformation लेने का such that the sum of the power becomes 1. Is this clear? So these are different forms of the same function, beta. What is this called? It is called as Cobb-Douglas utility function, and it is also called as well-defined preferences. क्यों? क्योंकि ये जो है ये एक टिपिकल इंडिफरेंस कर्व की तरह होता है. इट इज कॉन्वेक्स टू द ओरिजिन, इट हैज डिमिनिशिंग एमआरएस. ये सारा इंडिफरेंस कर्व का प्रॉपर्टीज को सेटिस्फाई करता है. सो वी हैव सीन 3 मेजर वेज. The first one जो हमने देखा, it was x1 to the power c, x2 to the power d. The second one that we saw was any of its monotonic transformation, जैसे ऐसा कुछ c log x1 plus d log x2. And the third one we saw is when the power adds up to 1. All these 3 represent Cobb-Douglas utility function. Okay, beta. Thank you. Hi, good afternoon, everyone. So now, beta, today we are going to go ahead and talk about perfect substitute codes. Okay. First of all, what are perfect substitutes? Those codes which can be consumed against one another. or which can be substituted against one another are called perfect substitutes. जैसे बेटा एग्जाम्पल ले लेते हैं, जैसे रेड पेन एंड ब्लू पेन, क्या कोई फर्क पड़ेगा हम किस कलर से लिख रहे हैं, एज लॉन्ग एज आई एम डूइंग द जॉब ऑफ अ पेन? नहीं ना. सो सपोज आई टेल यू दैट बेटा आई हैव 10 पेन्स. हाँ, तो यू विल बी ओनली कंसर्न्ड अबाउट द नंबर ऑफ पेन्स. माने it does not matter to you whether you have 4 red and 6 blue pen, या 3 red and 7 blue pen, या 5 red and 5 blue pen. इससे कोई फर्क नहीं पड़ता एज एन इंडिविजुअल. I am getting 10 pens ना, then it is fine, right? So in such cases we always want to ask about the total number. हमें इससे फर्क नहीं है कि रेड कितना और ब्लू कितना. We are not concerned with that. We are always concerned with the total number. So what I can go ahead and what I can write, beta, that my utility function, this is going to be x1 plus x2. We are concerned with the total number of pens. We are not concerned with how many pen 1 and how many pen 2. Right? Also, this utility function can have multiple representations. इस यूटिलिटी फंक्शन को हम अलग अलग तरीके से रिप्रेजेंट कर सकते हैं. We can represent it in multiple ways. First one, beta, when we will write a more generalized utility function, ax1 plus bx2, इसमें हमने इसको थोड़ा जनरल लिख दिया है ना. We have given some weightage to good one and good two. जैसे आप बोलो कि नहीं नहीं मैम, ऐसा नहीं है कि मेरे लिए रेड और ब्लू पेन सेम है. आई डोंट थिंक दैट इज द थिंग. यू नो, आई लाइक रेड पेन मोर. थोड़ा रेड पेन के लिए मेरे को इंक्लिनेशन है. आई लाइक रेड पेन मोर देन ब्लू पेन, या आई लाइक ब्लू पेन मोर देन रेड पेन. तो ठीक है, नो प्रॉब्लम, लेट अस गिव सम वेटेज टू रेड पेन एंड सम वेटेज टू ब्लू पेन. समझ रहे हो? सो वी कैन गिव सम वेटेज टू गुड वन एंड सम वेटेज टू गुड टू, and then write the utility function. उसके बाद हम utility function लिख सकते हैं. So when we go ahead and when we do this, then it is called a general utility function. So इसमें क्या हो गया? A and B, they represent the value of good. क्या represent कर रहा है बेटा ये? It is representing the value of good to consumer. तो गुड वन को हमने कुछ वेटेज दे दिया और गुड टू को हमने कुछ वेटेज दे दिया. वी हैव गिवन सम वेटेज टू गुड वन एंड सम वेटेज टू गुड टू. ठीक है, ठीक है बेटा. अब इसी में थोड़ा सा लेट अस ट्राई टू अंडरस्टैंड दिस थिंग. सो वी वांट टू डिफाइन द स्लोप ऑफ द इंडिफरेंस कर्व. The slope of indifference curve, that beta is called as marginal rate of substitution. क्या बोल देते हैं स्लोप को? Slope is called as marginal rate of substitution, and the marginal rate of substitution is represented as marginal utility from good 1 divided by marginal utility from good 2. Marginal utility from good 1 क्या होता है? When you differentiate your utility function with respect to x1. अच्छा, with a negative sign, because to increase one good you have to decrease the other good. जब आप एक गुड का कंजम्पशन बढ़ाते हो तो दूसरे गुड के कंजम्पशन को कम करते हो. To increase the consumption of one good, you decrease the consumption of the other good. ठीक है? Divided by marginal utility of good 2. How utility changes when there is change in the consumption of the second commodity. Clear? ठीक है बेटा. अब हम क्या करेंगे ना, इस केस में u of x1 x2 को we will take x1 plus x2 and we will find out marginal rate of substitution. Nikalo, differentiate it with respect to x1, differentiate it with respect to x2 and put a negative sign outside. So with respect to x1 beta, x1 का coefficient क्या है? What's the coefficient of x1? 1. With respect to x2 beta, what's the coefficient of x2? 1. That means you're getting the answer as -1. This -1, it tells us that the rate of substitution between the two goods is 1. Rate of substitution between two goods is 1. माने अगर मैं आपको बोलूं कि I have 4 red and 6 blue pencils and I tell you I am taking 1 red pencil from you, मैं आपसे एक red pencil ले रही हूं. So the rate of substitution between goods is 1. माने कितना मुझे blue pencil देना पड़ेगा? I will have to give you 1 blue pencil. So if I take 1 red pencil for you and you're left up with 3 red pencils, I should give you 1 blue pencil and you should have 7 blue pencils. Whenever this will happen, जब भी ऐसा होगा, it shows that your utility will remain unchanged. आपका जो utility है, वो unchanged रहेगा. Is this making sense? So the rate of substitution between the two goods, यहाँ पे क्या रहा है बच्चे? It is coming out as 1. Right? So ये वाला जो bundle है, 4 red and 6 blue pencils, and this bundle, 3 red and 7 blue pencils, both of these have same utility. इन दोनों में ही जो हमें utility दे रहे हैं हम, that is the same. The level of satisfaction is the same. Clear? Now let's go to the next case, beta. So now we will take this general utility function, ax1 plus bx2. So utility function is ax1 plus bx2. Beta, what will be MRS? mu1 by mu2 with a negative sign. So you will differentiate with respect to x1, differentiate with respect to x2 and put a negative sign. So जब हम इसको with respect to x1 differentiate करेंगे, what will I get, beta? I will get the answer as A. When we will differentiate with respect to x2, what will we get, beta? B. So what is going to be the MRS? Minus A by B. What will be the MRS? Minus A by B. Okay, let's take an example of this one. So for example, if I tell you utility function is 2x1 plus x2. 2x1 plus x2. क्या हो जाएगा बेटा MRS? What will be MRS? mu1 by mu2. Differentiate utility function with respect to x1, utility function with respect to x2. So with respect to x1, what will be the differentiation, beta? 2. With respect to x2, what will be differentiation, beta? 1. So MRS will be minus 2. क्या आ जाएगा MRS? MRS will be minus 2. What does this minus 2 represent? क्या मतलब है इसका minus 2 का? It means that I have to value good 1 twice as much as good 2. अच्छा, MRS को एक और तरीका लिखने का होता है dx2 by dx1. ये भी हम MRS को लिखते हैं. You remember? MRS was equal to dx2 by dx1. माने, if I make an indifference curve, this is good 1, this is good 2. So for 1 unit of good 1, अगर मेरे को 1 यूनिट गुड 1 का देना पड़ेगा, आपको मुझे 2 यूनिट गुड 2 के लाके देने पड़ेंगे. Right? The reverse. If you need 1 unit of good 1, you have to give up 2 units of good 2. So माने, if I am going from 2 red pencil to 3 red pencil, I am increasing good 1 by 1 unit. तो आपको मुझे कितना good 2 देना पड़ेगा? 2 units. So you have to, अगर यहाँ पे मेरे पास 4 blue pencils थी, So I will go to 2 blue pencils. This is what the slope of 2 is representing. तो यहाँ हम कह रहे हैं that for if I give up 1 red pencil, I will get 1 blue pencil. Ratio is 1:1. ठीक, but here we are saying कि हमें 2 blue pencils देना पड़ेगा. dx2 change in good 2 is 2 units. 2 good 2 देने पड़ेंगे अगर मुझे एक good 1 एक्स्ट्रा चाहिए. इतना ज्यादा good 1 की वैल्यू है कि मैं 2 यूनिट भी good 2 के दे सकती हूँ. गुड 1 को मैं इतना ज्यादा वैल्यू करती हूँ. गुड 1 को मेरी वैल्यू मतलब माय वैल्यूएशन फॉर गुड 1 इज वेरी हाई. समझ रहे हो? आर यू अंडरस्टैंडिंग दिस थिंग? सो वी आर सेइंग व्हाट वी आर सेइंग हियर दैट 2 यूनिट्स ऑफ गुड 2 आर रिक्वायर्ड. बेटा कंफ्यूज नहीं हो ना. एमआरएस को हम लिखते mu1/mu2 हैं, but MRS represents dx2/dx1. It represents amount of good 2 you are giving up for extra unit of good 1. Amount of good 2 you are giving up. कितना good 2 दे रहे हो एक extra good 1 के लिए. Although it is mu1/mu2. You remember the formula we derived. This is mu1/mu2, but this is the amount of good 2 you are giving up for an extra unit of good 1. एक गुड 1 लेने के लिए गुड 2 कितना दोगे वो एमआरएस है. सो दैट इज कमिंग एज -2/1. माने एक एक्स्ट्रा गुड 1 के लिए मैं 2 गुड 2 भी सैक्रिफाइस कर सकती हूँ. गुड 1 दे दो बस. गुड 1 ज्यादा इंपॉर्टेंट है, राइट? सो आई एम विलिंग टू गो टू द एक्सटेंट ऑफ सैक्रिफाइसिंग 2 यूनिट्स of good 2 for an additional unit of good 1. That is the amount of valuation I give to good 1. Good 1 is more precious to me, right? So 2 units of good 2 are required to compensate consumer for giving up 1 unit of good 1. ये रिवर्स में लिखा है मैंने कि मैं एक यूनिट तो गुड 1 का दे दूंगी, बट फिर मुझे 2 यूनिट गुड 2 के दो. ये गुड 1 बहुत प्रीशियस है, बहुत दिल से दे रही हूँ, उसके लिए 2 यूनिट इसके लगेंगे. आई हैव रिटन रिवर्स, right? So I'm willing to give up 1 unit of good 1, but I will take 2 units of good 2 from you. Is this clear? So which means good 1 is twice as valuable to me. Good 1 का ज्यादा valuation है. If you ask me to give good 1, तो good 2 ज्यादा देना पड़ेगा. You have to give up more of, you have to give me more of good 2. एक यूनिट गुड 2 देने से काम नहीं बनेगा. You have to give me 2 units of good 2 if you want 1 unit of good 1 from me, right? So the rate of substitution is 2:1 here. Try to understand this thing, right? Good 1 is more valuable in this case. Now, another thing which we want to go ahead and which we want to understand here is monotonic transformations of this function. तो मोनोटॉनिक ट्रांसफॉर्मेशन में हम क्या करते हैं कि सपोज हमारा बेटा यूटिलिटी फंक्शन इज दिस x1 plus x2. ठीक है. सपोज बेटा आई टेक स्क्वायर ऑन बोथ साइड, तो व्हाट विल आई गेट? x1 स्क्वायर प्लस x2 स्क्वायर प्लस 2x1 x2. दिस इज u स्क्वायर. u स्क्वायर मतलब कोई एक नया यूटिलिटी फंक्शन हो गया विच इज x1 स्क्वायर प्लस x2 स्क्वायर प्लस 2x1 x2. सपोज समवन आस्क्स यू, बेटा किसी ने आपको ये यूटिलिटी फंक्शन दिखा के बोला कि व्हाट इज दिस यूटिलिटी फंक्शन, तो ये तो ओरिजिनल यूटिलिटी फंक्शन को स्क्वायर करके आया है. When you squared the original utility function, you got this utility function. There is nothing new in this utility function. It is just a monotonic transformation of the earlier utility function that you are deriving by squaring on both sides. You haven't done really any magic here. So this utility function should also represent substitute goods. Should also represent substitute goods. Because you have not done anything new here. You have just taken square on both sides, right? And by taking square on both sides and deriving a utility function, there is no new process that you have undertaken. कुछ नया चीज नहीं किया है. Are you understanding this thing? So this utility function is also a substitute good utility function. At last, let us try to plot this beta. Plotting. So suppose I tell you u of x1, x2 is equal to x1 plus x2. Substitute goods. Huh? Let us hold utility constant at some level. I am holding utility constant at 10. And give different combinations of x1 and x2. x1 can be 0, x2 10. 0 plus 10, 10. x1 can be 1, x2 can be 9. x1 can be 2, x2 can be 8. x1 can be 10, x2 can be 0. This can be 5, this can be 5, this can be 9, this can be 1, and so on and so forth. Plot this beta. x1, x2. x1, when x1 is 0, x2 is 10. When x2 is 0, x1 is 10. When x1 is 1, x2 is 9. When x2 is 1, x1 is 9. Just join these points together. This will be your indifference curve. So how is the indifference curve looking in this case? We will talk about this later also. But how my ICs look? They look like linear lines. My indifference curve is a linear downward sloping line. Clear? Okay. So this is all about the perfect substitute goods. Hi, good afternoon, everyone. So, beta, today we are going to go ahead and we are going to talk about perfect complements. Beta, perfect complements are those goods which are used together with each other. जो goods एक साथ use किए जाते हैं, they are called as perfect complements. For example, left shoe plus right shoe. They are used together with each other. Left और right एक साथ ही पहनोगे, right? So in this case, we are going to go ahead and talk about the function being a perfect complement. ठीक है? कुछ और examples भी हैं complementary goods के, but वहां पर ratio 1:1 नहीं होता. तो I will give you both examples. So I am first starting with the ratio being 1:1. 1:1 means what? That for every one left shoe, अगर मेरे पास एक left shoe है, so I need exactly one right shoe. तभी तो I will have one pair ना. Only then I will have one pair of shoes. Right? So every one left shoe must be matched with every one right shoe. Acha, let us go ahead and write the utility function of this kind of goods. So the utility function for perfectly complementary goods looks like this beta. Min of x1, x2. जरा ध्यान से देखते हैं. Suppose x1 represents the number of left shoe. x2 represents the number of right shoe. तो tell me something. अगर मैं आपको ऐसा कुछ बोल दूं that you have 4 left shoe and you have 7 right shoes, तो बच्चे कितने पेयर बन पाएंगे आपके पास? How many pair of shoes you will have? 4 pairing. Remaining 3 right shoes are of no use to you. किसी काम के नहीं है बाकी के 3 right shoe, right? Similarly, beta, if I ask you that you have 3 left shoe and 2 right shoe, how many pairs you will have? 2 ही पेयर बन पाएंगे. 2 pair of shoes. 1 extra left shoe is of no use to you. If I ask you, you have 4 left and 4 right shoes, then how many pair of shoes you will have, beta? 4 pairs of shoes. है कि नहीं? So do you notice that always the number of pair of shoes are minimum? देखो, जब 4 लेफ्ट एंड 7 राइट थे तो 4 और 7 का मिनिमम क्या है? 4 इज लेस देन 7, तो सिर्फ 4 पेयर्स बन पाए. एक्स्ट्रा 3 राइट शूज वर ऑफ नो यूज. जो 3 एक्स्ट्रा राइट शूज थे वो किसी काम के नहीं थे. Similarly, when you have 3 left shoe and 2 right shoe, then the minimum of 3 and 2 is 2. तो दो ही पेयर बन पाए. Extra left shoe was of no use. And when you have 4 left and 4 right shoes, तो बेटा you have 4 pairs. अब can we try to check this through the utility function? एक बारी चेक कर लेते हैं. So utility from x1 comma x2, this is min of x1 comma x2. तो बेटा how many left shoe you have? कितना left shoe है? 4. How many right shoes you have? 7. So what will be min of 4 and 7 बच्चे? 4. तो 4 pair of shoes ही तो बना. Extra 3 shoes are of no use. Similarly बेटा, if I go ahead and I find it here, u is min of how many left you have? 3. How many right you have? 2. So min of 3 and 2 will be 2 beta. है ना? So how many pair of shoes you have? 2 pairs. यहाँ देखो बेटा, u is equal to min of 4 comma 4. That means दोनों ही same number है. So min of 4 and 4 will be 4. So 4 pair. So this utility function is very useful. ये बहुत ही useful utility function है. It is helping us understand finally we are able to make how many pair of shoes, जितना भी minimum होगा. यहाँ पर the extra 3 right shoes were of no use. Here extra 1 left shoe किसी काम का नहीं था, क्योंकि right तो दो ही है, तो left भी दो ही use हो पाएंगे. Right? Here both of them were equal, so you could use both of them together. ठीक है. But यहाँ पर the ratio that we had was 1:1. But not always the ratio will be 1:1. So for example, number 2. जैसे if I go ahead and I say you sugar and tea. Sugar and tea. So what we can do? We need 2 spoons of sugar with 1 tea. We need 2 spoon of sugar with 1 tea. तो रेशियो 1:1 नहीं है. एक चाय के साथ 2 चम्मच चीनी के चाहिए. Are you getting it? 2 teaspoons of sugar are required with 1 tea. अब ऐसे में how will we write the utility function? बहुत ध्यान से देखना. Let us say that x1 represents the number of tea and x2 represents the number of spoons of sugar. Number of spoons of sugar. ठीक है. तो अब हमें ये देखना पड़ेगा that I am using 2 spoons of sugar with 1 spoon of tea. एक चाय के साथ हम स्पून 2 चीनी के पैक यूज कर रहे हैं. वी आर यूजिंग 2 spoons of sugar with 1 tea. अब लिसन टू मी वेरी केयरफुली, फिर मैं आगे डिराइव करूंगी. अच्छा, सपोज बेटा आई टेल यू दैट आई नीड 10 टी. मुझे 10 चाय बनानी है, तो कितना शुगर लगेगा उसमें? 20 यूनिट्स ऑफ शुगर है कि नहीं? आई विल नीड 20 यूनिट्स ऑफ शुगर. तो बच्चे जरा ध्यान से देखो, व्हेन x1 is 10, जब मैं 10 टीज बना रही हूं, व्हेन आई एम मेकिंग 10 यूनिट्स ऑफ टी, आई नीड 20 शुगर स्पून्स. सो x2 will be 20. You are seeing this ना? Sugar is twice tea. 2 चम्मच चीनी के लगते हैं एक चाय में. Sugar is twice tea. Listen to me very carefully. It is very difficult to understand this thing. So when there is 10 tea, I need 20 sugar. Beta, suppose I tell you that I am making 40 tea. तो कितना sugar लगेगा? Double sugar, right? So you will need 80 units of sugar. माने if I were to write this तो आई कैन से दैट बेटा x2 is equal to 2, sorry, this is x1, huh? This is tea, this is sugar. So we can say that if I need 40 teas, अगर मुझे 40 चाय बनाना है तो I need 80 spoons of sugar. So बेटा x2 is 2 times x1 ना, isn't it? ध्यान से देखो, x2 is 2 times of x1. So when I need 10 units of tea, अगर 10 चाय बनाएंगे तो sugar 20 चाहिए होगा. If we make 20 units of tea, I need 40 sugar. If we make 30 units of tea, I need 60 sugar, and so on and so forth. I need double sugar. So x2 is 2 times x1. Right? Up. Beta, whenever we will write a utility function in terms of x1 and x2, यहां तो हमने लिख दिया min. अब एक रूल है. The rule is, please write down, whatever comes inside the min function is equated at equilibrium. ये point थोड़ा next chapter will make this point a little more clear. But at equilibrium, consumer consumes whatever by equating whatever comes inside the min. माने अगर my utility function is this, u is equal to min of left shoe and right shoe, तो equilibrium पे consumer क्या करेगा? He will equate whatever comes inside the min. So he will say left shoe is equal to right shoe. Whatever comes inside the min, जो भी min function के अंदर आएगा, consumer will equate that for consumption. Right? अब यहां पर I know I have to get x2 equal to 2x1. तो how will I write my utility function बेटा? 2x1 comma x2. 2x1 comma x2. ताकि when we solve this, तो solve कैसे होगा? Whatever comes inside the min function is equated. So we will equate x2 to 2x1. And this is exactly what we want. x2 is sugar. x1 is tea. And sugar is 2 times tea. अगर एक टी बनाना है तो 2 शुगर चाहिए, 2 टीज बनाना है तो 4 शुगर चाहिए. So sugar, which is x2 beta, right? x2 represents sugar. Sugar is twice the amount of tea. Clear? Is this clear? So my utility function will become 2x1 comma x2. Many of the students will do this wrong. बहुत बच्चे गलत करते हैं, वो कंफ्यूज हो जाते हैं कि मैम 2 शुगर 1 टी है ना, तो टी के आगे they will put coefficient 1 and शुगर के आगे they will put coefficient 2, क्योंकि शुगर is represented by x2, तो वो x2 के आगे 2 लगा देते हैं. That is incorrect. That is not correct. Try to understand what we are saying. x2 is 2 times x1 beta. x2 is twice x1. x1 is t और शुगर उसका डबल है. So therefore sugar will be x2 और यहां पर हम 2x1 लगेंगे. We'll put 2x1 here so that when we solve this, जब हम इसको solve करें, so we will equate whatever comes inside the min. जो भी min में आएगा हम उसको equal करेंगे. So we will get x2 is equal to 2x1. और यही statement है that sugar is twice the amount of tea. Sugar is twice the amount of tea. So what is the general utility function now? The general utility function is min of ax1 comma bx2. ax1 comma bx2. अच्छा देखो, मैंने क्या बोला? We equate whatever comes inside the min. तो माने we will say ax1 is equal to bx2. तो माने x1 by x2 will be b by a, so b and a ये क्या रिप्रेजेंट कर रहे हैं? They represent the proportion in which the goods are consumed. दो गुड्स किस रेशियो में कंज्यूम करने हैं, दैट प्रोपोर्शन. जैसे फॉर एग्जांपल बच्चे, समवन टेल्स यू दैट मेरा एक स्पेशल रेसिपी है एंड इन दैट रेसिपी आई लाइक एडिंग 3 sugar with 2 sachets of milk. I like adding 3 sugar with 2 sachets of milk. और आपने बोला कि ठीक है, let x1 represent sugar, let x2 represent milk. x1 को हमने रिप्रेजेंट किया शुगर से एंड x2 इज रिप्रेजेंटिंग मिल्क. तो हाउ मच शुगर बच्चे, कितना शुगर यूज कर रहे हैं हम? 3 शुगर, 3 यूनिट्स ऑफ शुगर. और कितना मिल्क यूज कर रहे हैं हम? 2. सो शुगर बाय मिल्क क्या रेशियो है? आई एम यूजिंग 3 शुगर विथ 2 मिल्क, 3 शुगर विथ 2 मिल्क. क्लियर? अच्छा, क्रॉस मल्टीप्लाई करो. सो दिस विल, अगर मैं इसको क्रॉस मल्टीप्लाई करती हूं, यहां से मुझे आएगा 2s इज इक्वल टू 3m. तो व्हाट विल बी माय यूटिलिटी फंक्शन बेटा? min ऑफ 2s, 3m. दिस विल बी माय यूटिलिटी फंक्शन. तो हिंट क्या है? व्हाट्स द हिंट? कोएफिशिएंट्स एक्सचेंज ईच अदर. अगर हम 3 शुगर यूज करते हैं, सो 3 विल कम विद मिल्क. If we are using 2 milk, so 2 will come with sugar. That is the trick to solve these questions. They are cross multiplying. क्योंकि हमें इस ratio को intact करना है. We need to keep this ratio intact. And what's the ratio? That sugar is to milk ratio is 3:2. So sugar by milk is 3/2. So if I cross multiply बच्चे, 2s is equal to 3m. और जो यहां पे आएगा ना, वॉट एवर कम्स हियर, दैट विल कम एज इट इज इनसाइड द min function. This is how you form the min function, right? This is how we can form the min function. I hope that this is absolutely clear to you as to how we can generate the min function or the complementary goods. Okay, beta. Thank you. Hi, good afternoon, everyone. So, beta, today we will learn more about quasi-linear preferences. Quasi-linear preferences. But quasi-linear preferences basically mean those preferences. So read the word. Quasi means partial. Quasi means partial. So quasi-linear preferences are those preferences which are partially linear. जिसमें एक लीनियर कंपोनेंट होगा और एक नॉन लीनियर कंपोनेंट होगा. That will be called as quasi-linear preferences. ठीक है? So for example, जैसे for example, so quasi means partly या partially, linear is linear. हाँ? जैसे for example बेटा, suppose I tell you utility function is equal to root x1 plus x2. Root x1 plus x2. तो देख लो, root x1, this is a non-linear part. This is non-linear. But beta, this x2, this is linear part. Similarly, u is equal to log x1 plus x2. non-linear part, linear part. U is equal to 1 by x1 plus x2. Non-linear part, linear part. U is equal to x1 plus root x2. Linear, non-linear part. ठीक है. सो दोज यूटिलिटी फंक्शंस जहां पे एक लीनियर पार्ट होगा और एक नॉन लीनियर पार्ट होगा, दैट इज अ क्वाजी लीनियर यूटिलिटी फंक्शन. इट इज अ क्वाजी लीनियर यूटिलिटी फंक्शन. ठीक है बेटा. फॉर एग्जाम्पल, जनरल फॉर्म ऑफ दिस यूटिलिटी फंक्शन हम लिख रहे हैं. सो जनरल फॉर्म ऑफ दिस यूटिलिटी फंक्शन can be written like this: v of x1 plus x2. कैसे लिख सकते हैं इसे हम? v of x1 plus x2. Now when we are writing it like this, v of x1 plus x2, माने it is a function of x1, non-linear function of x1. तो ये v of x1 कुछ भी हो सकता है. It can be root x1, it can be log x1, it can be 1 by x1. It can be any of these three things. कुछ भी हो सकता है इनमें से. It's a function of x1, but non-linear function. तो यहाँ आ गया, this is non-linear function of x1. Non-linear function of x1. And बेटा यहाँ देख रहे हो, this x2 is coming linearly. So ये हो गया हमारा linear part, linear portion. So x2 is coming linearly, so this is linear part, and यहाँ पर this is coming non-linearly, so non-linear part. बेटा क्या करते हैं हम usually in utility functions? We hold to plot utility functions. अगर हमें utility functions को plot करना है, we hold utility constant at some level. Suppose utility को k पे constant रख लिया. You remember when we were plotting x1 x2 is equal to 4, हमने utility को constant रखा था 4 पे. So we hold utility constant at some level. किसी level पे we need to hold the utility constant. So suppose here I am holding utility constant at k बचे. I have held the utility constant at k. So what will happen now? So I will get vx1 plus x2 is equal to k. So beta from here we will get x2 is equal to k minus vx1. x2 is equal to k minus vx1. समझे? So x2 is equal to k minus vx1. अब थोड़ा सा समझने की कोशिश करो. See, suppose I go ahead and I want to plot this thing. इसको हमें plot करना है. Naturally सोचना है कि इसको कैसे plot कर सके. So suppose let us go ahead and let us say that vx1 का value 0 है. This part is 0. तो what will be x2 बचे? x2 का value k हो जाएगा. And as x1 will increase, जैसे जैसे x1 का consumption बढ़ेगा, तो of course vx1 is a function of x1. तो vx1 will also increase. So as vx1 will increase beta, तो x2 जो है which is nothing but k minus vx1, जैसे जैसे this will increase, the value of x2 will decrease. समझे? Let me try to explain this again. दोबारा सुनो. What I am saying, suppose I want to hold utility constant at 4. Suppose मेरा utility function ऐसे है. U of x1 x2 is equal to root of x1 plus x2. And suppose I have held utility constant at 4. मैंने 4 पे utility को constant रखा है. So बच्चे, what will I get from here? कि x2 is equal to 4 minus root of x1. x2 is equal to 4 minus root of x1. अच्छा, suppose now I want to plot this. तो हम कैसे plot करते हैं इसको? How do we plot this? We take different values of x1 and x2. So if x1 is 0, अगर x1 0 होगा, तो root x1 will also be 0. So if this is 0, तो x2 का value will be what? 4 minus root 0, that means 4. Suppose x1 is 1. So root of 1 is also 1. So 4 minus 1, माने x2 will be 3. तो जैसे जैसे x1 बढ़ रहा है, as x1 is increasing, तो root of x1 भी तो बढ़ रहा है, root x1 is also increasing. So I am subtracting a bigger number from here. मैं एक बड़ा नंबर माइनस कर रही हूं. So this means that 4 minus root x1 will decrease. अगर मैं एक बड़ा नंबर 4 में से सब्ट्रैक्ट करूंगी, जैसे फॉर एग्जाम्पल इफ आई टेक x1 as 4 बेटा, so root of 4 is 2, so 4 minus 2 will be 2. अगर मैं यहाँ पे x1 की जगह पे 4 लगाऊं, root of 4 is 2, right? So I will get 4 minus 2 which is 2. So as x1 is increasing, जैसे जैसे x1 बढ़ रहा है, as x1 is increasing, the root of x1 is also increasing. That means ये वाला value is increasing. So I am subtracting a bigger number. In this case, यहाँ पे x1 0 था, so root x1 0 था, I subtracted 0. x1 was 1, root x1 was 1, I subtracted 1. x1 is 4, root x1 is 2, I subtracted 2. So as x1 is increasing, root x1 भी बढ़ रहा है. As root x1 is increasing, 4 minus root x1 is decreasing. 4 minus root x1 means what beta? x2. x2 ही तो है 4 minus root x1. So x2 is decreasing. So as x1 is increasing, x2 is decreasing. x2 is decreasing. समझ रहे हो बात को? This is what I have written generally here. कि x2 is k minus v of x1. k minus v of x1. तो अगर x1 ये वाला पार्ट 0 हो गया, if this is 0, so x2 will be k. जैसे यहां पर when this was 0, so x2 was 4. x2 was 4. और जैसे जैसे ये बढ़ता गया, x2 का वैल्यू डिक्लाइन होता गया. So as this keeps increasing, so I am subtracting more amount from k, तो x2 is decreasing. समझ रहे हो बात? ठीक है. Now try to understand something more. So now what I can go ahead and I can do is, I can try to plot beta. So I will take x1 here and x2 here. When x1 is 0, x2 is 4. जब x1 0 है, so x2 is 4. When x1 is 1, x2 is 3. 1. 3. When x1 is 2, so जब हमने 4, जब हमने x1 को 4 लिया, x2 is 2, so x1 is 4. 2. This point. माने if you try plotting it, it will be somewhere like this, somehow like this, है ना? And what will be this height बेटा? ये height कितना आया यहाँ पे? x2 का maximum value कितना जा रहा है? Whatever utility you had kept, यहाँ पे utility 4 पे था. So when x1 was 0, x2 was coming out as 4. So what's the maximum value of x2? 4. So when x1 is 0, the height of this curve is coming out as 4. अच्छा, suppose I would have kept utility constant at 5. मैं 4 पे constant नहीं रखती. Suppose I would have said कि नहीं, I want to do this, that I want to plot root x1 plus x2 equal to 5. फिर क्या करते बेटा? You would have got from here x2 is equal to 5 minus root x1. I am holding utility constant at 5. 5 पे utility constant. So when x1 was 0 beta, x2 will be 5. अगर हम x1 को 1 लेंगे, so root 1 is 1, 5 minus 1 is 4. If we will take x2, x1 as 4 beta, root of 4, यहाँ पे 4 डालो, root of 4 is 2, 5 minus 4 will be 3. If I want to plot this, ये points को हमें plot करना है. So 1, x1 is 0, x2 is 5. When x1 is 0, x2 is 5. When x1 is 1, x2 is 4. When x1 is 1, x2 is 4. When x1 is 2, x1 is 4, x2 is 3. So when x1 is 4, x2 is 3. Mane, this will be a curve like this. This is representing utility of 4. ये 4 का utility represent कर रहा है. This is representing utility of 5. इसका maximum height at x2 will be 5. अगर आप यूटिलिटी को कांस्टेंट एट 6 रखते हो, इफ यू होल्ड यूटिलिटी एट 6, तो सब कुछ 1 स्टेप अप हो जाएगा. एवरीथिंग विल स्टेप अप बाय 1. You just notice it, right? Here also everything stepped up by 1. This went from 4 to 5. This went from 3 to 4. This went from 2 to 3. Everyone is going 1 step up. एक step ऊपर जा रहे हैं. So if I have utility at 6, constant at 6, this point will be 6 beta. This point will be 5 beta. This point will be 4 beta. And you will get a curve like this. Same shape curve. This will be u equal to 6. Thoda or better I can plot this. This will be utility of, this is 4, something like this. Huh? They have exactly same shape. Vertically shifted version of the same indifference curve. तो अगर अब यहां पर हम k कांस्टेंट रखते हैं, आई एम होल्डिंग यूटिलिटी कांस्टेंट एट k, आई डोंट नो व्हाट k इज, तो क्या होगा? देयर इज, सपोज दिस इज k, तो दिस विल बी जस्ट k नाउ. यहां पे k आ जाएगा. k प्लस 1 होता है तो उसके एक ऊपर, एक और ऊपर, एंड सो ऑन एंड सो फोर्थ. आर यू अंडरस्टैंडिंग दिस डायग्राम? सो ईच इंडिफरेंस कर्व is vertically shifted version of single indifference curve. माने आप एक बना दो और फिर आप उसको अपवर्ड शिफ्ट करते जाओ वर्टिकली. When are we shifting this vertically, बेटा? In the background क्या देख रहे हैं हम? That x1 was non-linear, but x2 was coming linearly. Only then this is the graph. x2 is coming linearly. x1 is coming non-linearly. तब जाके these are vertically shifted. These are vertically shifted. Homework. I want all of you to try and plot root x2 plus x1 equal to utility function. ठीक है? x2 is non-linear and x1 is linear. इसको plot करो. Right? For different values of utility. एक बार यूटिलिटी लेवल को 4 पे लो, फिर 5 पे, फिर 6 पे. For different levels of utility, try to plot this indifference. Okay. Now, what are some of the examples of quasi-linear preferences? So, quasi-linear में whatever is the non-linear good, that good is a necessary or necessity good, not affected by income, or those goods which are very small proportion of budget. Very small proportion of budget. तो कौन से goods होते हैं यहाँ पर? What are those goods which represent quasi-linear preferences? The goods, first of all, which are necessity goods. माने if I want to show that one of the good is medicine, तो बेटा medicine तो मैं लूंगी ही. चाहे मेरी इनकम 100 हो या 200, I have to spend money on medicine for sure, right? And medicine is not affected by income. So if my income increases from 100 to 1000, will I increase the consumption of medicine? No. I will not start consuming more medicines. ऐसा तो नहीं होगा. So those goods, so non-linear good माने non-linear part में किस good को दिखाएंगे? Which good will we show in the non-linear part? That good which is a necessity, right? Which will not have increase in consumption when income increases. Income के बढ़ने पे consumption increase नहीं होगी, right? The other is which have very small proportion of budget. But for example, newspaper, for example, salt. You will not increase consumption when income increases or decreases. अगर income कम हो जाए या बढ़ जाए, तो salt, newspaper, इनका consumption हम change नहीं करते हैं because they are very small proportion of budget. एक न्यूज़पेपर में 5 से 10 रुपए लगते हैं, right? A newspaper cost very small proportion of your income. So since it is costing very small proportion of income, it is not affected when your income increases or decreases. उसको income से फर्क नहीं. So those goods will be represented by a non-linear good. Is that clear, beta? So these are some of the examples of quasi-linear preferences. So with this, we have done 4 type of goods, beta. हमने Cobb-Douglas पढ़ा. We studied Cobb-Douglas. We studied substitute goods. We studied complementary goods. And we studied quasi-linear goods. In the next class, we will introduce the concept of marginal utility. And I will also take you to an example. जिसे बोला जाएगा utility for commuting. We will also see an example of it. Okay? ठीक है बेटा. Hi, good afternoon, everyone. So, beta, today we are going to go ahead and talk about marginal utility. अब marginal utility क्या होती है, उसे कैसे derive करते हैं, we will try to understand all of that. So, very simply, marginal utility is basically nothing, but the marginal always means additional. Marginal means beta additional. So marginal utility is the additional utility that a consumer gets when he changes his consumption. ठीक है, कैसे डिफाइन कर सकते हैं मार्जिनल यूटिलिटी? सो सपोज आई वांट टू फाइंड मार्जिनल यूटिलिटी फ्रॉम गुड वन से मार्जिनल यूटिलिटी कितना? सो दिस विल बी एक्स्ट्रा यूटिलिटी, चेंज इन यूटिलिटी ड्यू टू चेंज इन कंजम्पशन ऑफ गुड वन. चेंज इन यूटिलिटी ड्यू टू चेंज इन कंजम्पशन ऑफ गुड वन. अब बेटा व्हेन इज यूटिलिटी चेंजिंग? यूटिलिटी कब बदलेगी? व्हेन there will be change in consumption. अब यहां देखो, आई एम फाइंडिंग मार्जिनल यूटिलिटी फ्रॉम गुड वन, माने कितना एक्स्ट्रा यूटिलिटी वी आर गेटिंग, हाउ मच एक्स्ट्रा यूटिलिटी यू आर गेटिंग व्हेन यू आर इंक्रीजिंग द कंजम्पशन ऑफ गुड वन. तो वी विल होल्ड good to constant. We will hold good to constant. अच्छा, कितना एक्स्ट्रा गुड वन का हम कंज्यूम कर रहे हैं? हाउ मच एक्स्ट्रा यूनिट्स ऑफ गुड वन वी आर कंज्यूमिंग? इतना. change in x1, इतने extra good one हम use consume कर रहे हैं. So how can I rewrite this thing, beta? How can we rewrite this thing? We can rewrite this thing as utility. When x good one का consumption is increased by these many units, comma good two का consumption is x2 minus utility of x1 comma x2 upon change in x1 upon change in x1. एक और तरीका है, let's try to understand this a bit more. तो for example, बच्चे if I tell you कि good one जो है अभी 4 units है and good two I have 5 units and good one को मैं increase कर रही हूं to 7 units. Now I am consuming 7 units of good one. तो how can I write marginal utility of good one? Utility from 7 units of good 1, comma 5 units of good 2 minus utility from 4 units of good 1, comma 5 units of good 2. ओरिजिनल बंडल आपका जो है, योर ओरिजिनल बंडल, हाँ बच्चे, दैट इज 4,5 एंड योर न्यू बंडल दैट इज 7,5. समझ रहे हो? So utility from new bundle minus utility from old bundle divided by change in consumption of good one. Good one कितने units से change हो रहा है? It is increasing by 3 units. This is marginal utility of good one. अच्छा, can I write this 7? क्या मैं इस 7 को ऐसे लिख सकती हूँ? 4 plus 3, comma 5 minus utility of 4 comma 5 upon 3. I can write it like this also, बच्चे. अच्छा, just think about this. I am saying 4 plus 3 माने 4 क्या है? Original consumption. And 3 क्या है? How much extra, कितना मैंने good one को change किया? How much extra good one I am consuming? So I can write this now that this is initial consumption plus extra units of good one, comma x2 minus initial x1, comma x2, and I am changing good one by 3 units. So change in x1. यही तो marginal utility of good one है. This is what marginal utility of good one is. Is this okay? Acha. So now, bitche, we defined marginal utility of good as change in utility when good one changes. So can I write that change in utility will be marginal utility into change in x1? I can take this here. इसको मैं यहाँ लेके जा सकती हूँ. So how much extra utility we will get जब एक good का consumption बढ़ता है? When we increase the consumption of a good, what is the extra utility we will get? Extra utility we will get? It will be nothing but change in consumption of that good multiplied with the additional utility you are getting. Multiplied with the additional utility you are getting. Mane, clear this thing? Acha, can you tell me on similar basis, what will be marginal utility of good 2? What will be marginal utility of good 2? Quickly solve it yourself. I'm giving you 1 minute. Marginal utility of good 2 will be what, beta? Utility x1 को constant रखेंगे. x2 का consumption is increasing by change in x2 units minus utility x1 comma x2 upon change in consumption of good 2. Clear? तो मतलब marginal utility of good 2 is nothing but change in utility due to change in consumption of good 2. And I can take this here, bache. So marginal utility into change in consumption can be change in utility. Can be change in utility. समझे? तो utility जो है हमारा, our utility it can change due to two reasons. दो reasons से utility change हो रहा है. It can change when good one consumption changes. It can change when good two consumption changes. Either say change in utility will be mu1 change in x1. And from here it will be mu2 change in x2. Clear? mu1 change in x1, mu2 change in x2. Okay. So now once we have understood this thing, we have understood how utility is changing. अब बच्चे एक बात हम थोड़ा समझने का कोशिश करते हैं. So try to understand this thing, huh? When we talk about MRS, when MRS का भी बाद में बात करेंगे. When we talk about indifference curve, this is point A, point B. When we talk about indifference curve and we go from one point to another, तो indifference curve का क्या property है? That along, what's the property of indifference curve? Along an indifference curve, utility is constant. Along an indifference curve, utility is constant. माने when I will go from point A to point B, utility should remain constant. माने change in utility will be zero. Utility will not change. When I go from one point to another, utility will not change. ये बात clear है? अच्छा. Now, beta, just try to understand this thing that when I am going from point A to B, तो X2 good 2 consumption, it is changing. Good 2 का consumption is changing. Suppose by change in X2. Good 1 का consumption भी is changing. Suppose by change in X1. ये change can be negative or positive, does not matter. हाँ, जैसे point A पे good 2 होगा, suppose 10 units. यहाँ पे good 2 है 4 units. तो 4 minus 10 माने minus 6. यहाँ पे good 1 है 7 units. यहाँ पे good 1 है suppose 15 units. तो 15 minus 7 minus माने plus 8 units. Does not matter. It can be positive or negative. But there is some change in good 2 ना, and some change in good 1. दोनों में ही कुछ change आ रहा है. There is some change coming. अच्छा, now tell me, if I ask you how can we measure change in utility, so we have seen change in utility will be because good 1 changes and because good 2 changes. तो हमें इन दोनों को add करना पड़ेगा. That will be total change in utility. So it will be mu1 change in x1 plus mu2 change in x2. But along an indifference curve, अगर मैं एक ही indifference curve पे हूं, along an indifference curve, utility does not change. Utility does not change. So along same indifference curve, change in utility will be 0. So this will become beta 0 is equal to mu1 change in x1 plus mu2 change in x2. Okay. Now let's talk about the slope of indifference curve beta. Slope किसी भी चीज का slope जो होता है वो perpendicular by base. Slope is always perpendicular by base. So what is perpendicular बच्चे? Change in x2. What is base? Change in x1. So what will be slope beta? Slope will be, ma'am, perpendicular by base. Change in x2 by change in x1. So slope can be written as change in x2 by change in x1. Can you find this value from here? Nikalo. Take this on the other side. So 0 is equal to mu1 change in x1 plus mu2 change in x2. Take this on the other side. Minus mu2 change in x2 is equal to mu1 change in x1. Beta, take this here and this here. Change in x2 by change in x1 will be minus mu1 by mu2. Minus mu1 by mu2. The slope of indifference curve is called as MRS. एक इंडिफरेंस कर्व के स्लोप को MRS बोलते हैं. It's called as MRS. MRS is marginal rate of substitution. What is MRS, beta? Marginal rate of substitution. MRS क्या बताता है? What MRS is telling us? Change in x2 by change in x1. माने अगर good 1 को increase करना है, if I want to increase the consumption of good 1, how much good 2 am I willing to give up to hold utility constant? A और B पे utility तो same है. But what am I doing? I am increasing good 1 and I am decreasing good 2. Right? So what is MRS saying? MRS is telling us amount of good 2 that must be given up. Given up. देना पड़ रहा है. You're reducing good 2. That is why the negative sign. You are lowering one thing. You are reducing one thing. आप एक चीज को कम कर रहे हो दूसरे को बढ़ाने के लिए, इसीलिए नेगेटिव साइन है. जैसे यहां पर अगर मैं नंबर्स का बात करूं, so what is the number I was getting here, beta? -6. What is the number I was getting here, beta? +8. तो नेगेटिव होगा ना? It will be negative when you find the ratio. This is what exactly I am saying. So amount of good 2 that must be given up. अब दे रहे हो good 2. So amount of good 2 that must be given up for an additional, not an additional, for extra units of good 1 is also fine. Unit of good 1. But same indifference curve का बात है. So holding utility constant. Holding utility constant. Utility को constant रखते हुए, keeping utility constant, the amount of good 2 that must be given up for an extra unit of good 1, या for some extra units of good 1, that is called as MRS, marginal rate of substitution. किस रेट से आप सब्स्टिट्यूट करोगे एक गुड को दूसरे गुड के लिए अपनी यूटिलिटी को कांस्टेंट रखते हुए? What is the rate at which you will substitute one good for another, holding your utility constant? And how can you find this, beta? What is the slope? It is mu1 by mu2. Marginal utility of good 1 divided by marginal utility of good 2. Confuse नहीं होना है. यहां पे change in x2 by x है और यहां पे mu1 by mu2 है. Don't get confused. Here marginal utility of good 1 is in the numerator. है ना? जो भी हम x axis पे लेंगे, whatever you will take on x axis, that will come in the numerator, beta. Clear? Okay, beta. Thank you. Hi, good evening, everyone. Beta, today we are going to talk about an example of utility function, और example जो हम लेने लगे हैं, that is called as utility from commuting. ठीक है? माने in this particular example, we are going to go ahead and look at how utility functions can be used in the real life scenario. कैसे हम utility functions को real life में use करके how we can go ahead and learn something from them, right? So what we have gone ahead and we have done is, let us go ahead and let us try to link this to the transportation economics sector. और यहाँ पे let us make a utility function. So the utility function that I have, u x1 x2 till xn, beta this is equal to beta 1 x1 plus beta 2 x2 and so on till beta n xn. ठीक है, ये हमारा एक यूटिलिटी फंक्शन है. अब इस यूटिलिटी फंक्शन को थोड़ा सा समझने की कोशिश करते हैं. x1 x2 एंड सो ऑन आर डिफरेंट पैरामीटर्स. ठीक है, जैसे फॉर एग्जांपल x1 can be the amount of travel time involved. Amount of travel time involved. अब हमें पता है, we know that whenever there will be increase in the amount of travel time involved, then it should go ahead and it should lead to decrease in utility of the consumer, isn't it? अगर मुझे एक जगह ट्रैवल करने में ज्यादा टाइम लगेगा तो मेरा यूटिलिटी, मेरा जो सेटिस्फैक्शन है, दैट विल डिक्रीज. So if there will be increase in the travel time involved, then the utility should decrease. It means that beta this coefficient, we know that this should be negative. It should be negative. Negative माने ये दोनों opposite directions में हैं. These are moving in opposite directions. ठीक है. Similarly, suppose we go ahead and we say that x2 represents the waiting time for transport. जैसे अगर मैं बस से जा रही हूँ, suppose I am traveling via bus, so how much time I have to wait for that bus? How much time I have to wait for that bus? That can be my x2. ठीक है. Again बेटा, I know that if I have to wait more for a bus, अगर मुझे public transport के लिए ज्यादा wait करना पड़ेगा, then my utility should decrease. If I have to wait more for bus, then my utility should decrease. So beta, we can say that there is a negative relation between the two. Mane beta 2 should also be less than 0. Similarly, you can define different things. Just say you can define that let x3 be the pocket cost involved. कि travel करने में कितना cost लगता है. How much money is involved in traveling. तो ये भी हमें पता है that if more money is involved in traveling, then my utility will decrease. मेरा सेटिस्फैक्शन गिर जाएगा अगर ज्यादा पैसा लगेगा ट्रैवल करने में. सो इट मींस दैट द थर्ड कोएफिशिएंट बीटा 3 x3 का जो कोएफिशिएंट होगा, दैट शुड आल्सो बी नेगेटिव. देयर इज एन ऑपोजिट रिलेशन बिटवीन x3 एंड यूटिलिटी. सिमिलरली बेटा, सपोज मैं कह रही हूं दैट x4 इज कंफर्ट, अमाउंट ऑफ कंफर्ट. So when x4 increases, more comfort, beta it should mean more utility. So beta 4 should be positive. दोनों same direction में जा रहे हैं. More comfort, more utility. So beta 4 should be greater than 0. It should be positive. Right? So we are going ahead and we are labeling different things. कि x1 एक चीज हो गया, amount of travel time, x2 is the waiting time, x3 is the pocket cost, x4 is the comfort. ऐसे करके we are defining various variables, right? We are going ahead and we are defining various kind of variables. Is this clear? ठीक है. So now what we can go ahead and we can do beta, let's take some numerical example on this. इसी पे एक numerical example ले लेते हैं. So supposedly we make 3 variables. Example, suppose I tell you that utility TW, TT, C is equal to minus 0.147 TW minus 0.4104 1 TT minus 2.24 C. Suppose ऐसा utility function defined है. This is how the utility function is defined. ठीक है. And beta, I have defined these 3 things also. ठीक है. So what is TW saying? TW is the total walking time to the ट्रांसपोर्ट। माने अगर हम बस लेते हैं या कार लेते हैं या जो भी अपना ट्रांसपोर्ट लेते हैं, उस ट्रांसपोर्ट तक वॉक करने के लिए, टू वॉक टू दैट ट्रांसपोर्ट, हाउ मच टाइम इज इन्वॉल्व, दैट इज TW। ऑफ कोर्स बेटा, इफ आई हैव टू वॉक फॉर मोर टाइम आई विल गेट लेस यूटिलिटी। नेगेटिव होना चाहिए रिलेशन। सो यू सी दिस नेगेटिव साइन, इट मीन्स दैट दे आर मूविंग इन ऑपोजिट डायरेक्शन। ठीक है। अच्छा, देन बेटा TT it represents the total time of trip in minutes। अब जब कॉलेज से घर आने के लिए ज्यादा टाइम लगता है, ऑफिस से घर आने के लिए ज्यादा टाइम लगता है, व्हेन यू टेक मोर ट्रैवलिंग टाइम, यूटिलिटी डिक्रीजेस, पीपल गेट फेड अप, हाँ, दे गेट impatient, they get fed up. So of course beta, as travel time increases, your utility should decrease. There should be a negative relation. You see this negative sign? Yes. ठीक है। C represents the total cost of trip in dollars। टोटल कॉस्ट ऑफ ट्रिप। अगेन बेटा, एज कॉस्ट इंक्रीजेस, अगर ज्यादा पैसा लगेगा, जैसे फॉर एग्जाम्पल इफ मेट्रो का प्राइस इंक्रीजेस, मेट्रो टिकट इंक्रीजेस, यू आर इनकरिंग मोर कॉस्ट, योर यूटिलिटी विल डिक्रीज, दे विल मूव इन ऑपोजिट डायरेक्शन। अगेन बेटा, you see this thing, huh? So negative sign shows that when you increase their consumption, then the utility from them is decreasing। Is this clear? ठीक है। ठीक है। अब क्या है कि द कोएफिशिएंट्स, इफ वी लुक एट द कोएफिशिएंट्स, लेट अस ट्राई टू इंटरप्रेट दीज कोएफिशिएंट्स बेटा। कोएफिशिएंट्स इंटरप्रिटेशन। ठीक है। तो जैसे इफ आई जस्ट रीराइट दिस यूटिलिटी फंक्शन, एक बार यहां लिख लेते हैं, u इज इक्वल टू -0.147 t सेकेंड। Yeah. So U is equal to minus 0.147 TW and minus 0.0411 TT minus 2.24 C। तो एक बात मुझे बताओ, if I differentiate utility with respect to TW बेटा, partial derivative, तो of course बच्चे these are constants, क्योंकि हम इसके रिस्पेक्ट में डिफरेंशिएट करें with respect to TW, so I will get the answer as 0.147। Similarly बच्चे, if I differentiate my utility with respect to TT, तो I will get minus 0.0411। बेटा, if I differentiate my utility function with respect to C, तो I will get minus 2.24, isn't it? यही आएगा, this is what you will get, right? अच्छा, अब ध्यान से पहले वाले को समझो, हाँ। So this is telling me how the utility changes, change in utility when there is change in walking time, that is equal to minus 0.174। चेंज इन यूटिलिटी व्हेन देयर इज चेंज इन वॉकिंग टाइम। तो एक बात बताओ बच्चे, सपोज वी एज्यूम दैट वॉकिंग टाइम चेंजेस बाय 1 यूनिट, डिनोमिनेटर 1 है, सो यहाँ पे न्यूमरेटर इज चेंज इन यूटिलिटी, so change in utility divided by 1 will be 0.147। माने I can say that if 1 goes on this side, then change in utility बच्चे, it will become minus 0.147। change in utility will become minus 0.147। तो इसका क्या मतलब है, what does this mean? It means that देखो, walking time में हमने +1 से replace किया, change in walking time we replaced with +1। So we are saying that when walking time increases, why increases? Because this is +1, plus है, plus means increase। So when walking time increases by 1 unit, then utility decreases। Why decreases बेटा? Because change in utility negative आ रहा है, so utility decreases by 0.147 units। When walking time increases by 1 unit, utility decreases by 0.147 units. ठीक है? Is this clear? ठीक है. Let us try to go ahead and interpret the next one, beta. This one. When travel time increases by 1 unit. कैसे? Change in travel time की जगह पे I am plugging +1. So change in utility and change in travel time की जगह we are putting +1 is equal to -0.0411. है ना? तो if this goes on the other side, तो बेटा what will I get? Change in utility is equal to -0.0411. ठीक है? So when travel time increases by 1 unit, then utility decreases by 0.0411 units. ठीक है? Similarly, third one, beta. When cost increases by 1 unit, then utility decreases by 2.24 units. ठीक है? अच्छा, important thing. Another important thing here is that ये जो utility के coefficients हैं utility function में, these coefficients that we see here, these are the weights that the household is giving to different characteristics. Mane, if you look here it is 0.14. This is only 0.04. This is 2.24. It means highest weightage, absolute number में 2.24 is more than 0.14, which is more than 0.04. So I am giving more weightage to cost. I am giving more weightage to cost. उसके बाद I want to give weightage to traveling to the transport. कितना टाइम मेरे को ट्रांसपोर्ट तक जाने में लगता है? How much time I need to give to traveling up to transport? And then बेटा this is the least. Absolute value में देखना, हाँ? In absolute value this is the least. So traveling time is having the least weightage. ठीक है? Also, if you understand बच्चे, तो can I say change in utility due to change in traveling time? I can call this as marginal utility of traveling time. इसको हम MUTT बोल सकते हैं, marginal utility of traveling time. Similarly, if you look here, change in utility due to change in this is travel till transport. Transport तक जाने के लिए कितना travel करना है? I can call this as marginal utility of travel till transport or walking time. Similarly, this is how utility changes as cost changes. Utility कैसे change होगा जब cost change होगा? So I can call this as marginal utility of cost. कह सकते हैं इसे? How utility changes when something changes is marginal utility of cost. है ना? अच्छा, one more thing बेटा. Suppose I ask you question, find MRS. Find MRS, traveling time cost. MRS, traveling time cost. So you remember that whenever we were finding MRS XY, it was MUX upon MUY. So MRS TT, C will be MUTT upon MUC. MUTT बच्चे, this one. How utility changes when TT changes? इसी को तो marginal utility of TT बोलेंगे. This will be called marginal utility of TT. So this will be minus 0.0411 upon marginal utility of C beta minus 2.24. And if you divide this, you will get 0.0183. 0.0183. It means the trade-off between traveling time and cost is this. This is the rate at which the consumer is trading off between traveling time and cost. Right? Is this clear? Is this clear? This is the trade-off between traveling time and cost. इस बात को समझ लो. ये MRS है. MRS was telling us trade-off between the two commodities. Right? So this is giving us the trade-off between these two things. Right? Okay, beta. So this is just an example of the utility function. इसी तरीके से आप अलग अलग यूटिलिटी फंक्शंस को सीख सकते हो, उनको इंटरप्रेट कर सकते हो. ठीक है. नाउ आई जस्ट वांट टू आस्क वन क्वेश्चन एट द लास्ट. सो होमवर्क क्वेश्चन. एक्सप्लेन व्हाई monotonic transformation doesn't change marginal rate of substitution. Explain why monotonic transformation doesn't change marginal rate of substitution. बहुत simple है बेटा. So marginal rate of substitution is marginal utility of x upon marginal utility of y. It is ratio. It is ratio. When we do monotonic transformation, तो it changes MUX and MUY, but not the ratio. वो MUX MUY को तो change करेगा. It will change MUX MUY. So for example, after monotonic transformation, you may get twice MUX, twice MUY, but the ratio will remain unchanged. Ratio नहीं बदलेगा. For example, beta, consider a utility function xy and consider another utility function u dash, which is 2 times xy. तो क्या था monotonic transformation? What was monotonic transformation? I have already discussed in lectures. When you multiply, add, or divide, or take it to some power, है ना, or take log, these are all monotonic transformations, right? अच्छा बेटा, यहाँ पर what will be MRS of the first utility function? MRS can be written as MUX by MUY. So just try and find MUX by MUY in the first case. MUX by MUY. It means I will differentiate utility function with respect to x divided by differentiate utility function with respect to y. बेटा जब x से differentiate करते हैं तो y is assumed to be constant. So differentiation of x with respect to x is 1 and y is assumed to be constant. When you differentiate with respect to y, then you keep x constant and differentiation of y with respect to y will be 1. x constant रहेगा और y का differentiation y के साथ 1 होगा. It will be 1. So you will go ahead and you will get y by x. Now look at the second utility function, beta. Here I am finding MRX. This is MUX by MUY. Differentiate utility function with respect to x. Differentiate utility function with respect to y. तो जब हमने x से differentiate किया तो x के अलावा everything else is constant. Except x, everything else is constant. So 2 is a constant, beta. Differentiation of x with respect to x will be 1 and y is a constant. And differentiation with respect to y क्या हो जाएगा? 2 is the constant. X is a constant. Differentiation of y with respect to y will be 1. So you will get here 2y by 2x. So 2 will cancel out and you will get y by x. So in both cases, MRS is coming out to be the same. MRS एकदम same आ रहा है. So we see that MRS is coming out to be the same. Right? Because MRS is ratio. और जब तक रेशियो नहीं बदलेगा, MUX by MUY का रेशियो, as long as the ratio is unchanged, monotonic transformation will not affect MRS. Will not affect MRS. ठीक है? Just as a homework question, everyone will go ahead and find if V is monotonic transformation of U. बेटा U क्या है? U is x1 plus root x2. What is V? V is x1 square plus 2x1 root x2 plus x2. Find if V is monotonic transformation of U. माने how can you check this? Very simple. आप MRS निकालोगे first utility function का. You will find MRS of second utility function. If MRS are same, then yes, V is monotonic transformation of U. Then V is monotonic transformation of U. Is this clear, beta? Okay. Thank you. Hi, good afternoon, everyone. Beta, today let us go ahead and talk about uncertainty. Uncertainty is something which is a part of your life, isn't it? चाहे हम एक बेसिक वॉक ले रहे हो और whether we are driving a car, right? We don't know what will happen in the next moment. Do we? No, we don't. We don't know when I will put my money in the stock market, whether I will get profit or loss, right? We don't know anything about life. Will we live for one more moment or not? क्या हम एक और पल जिंदगी का जी पाएंगे या नहीं, उतना भी सर्टेन नहीं है, राइट? तो अनसर्टेनिटी इज अ फैक्ट ऑफ लाइफ. अनसर्टेनिटी हमेशा हमेशा जिंदगी में रहती ही है, हर चीज में. You are preparing for your exam. Are you certain how many marks you will get? No. You can increase the probability of getting good marks. अच्छे marks मिलने का probability बढ़ा सकते हो. Can you be certain कि मुझे इतना ही marks मिलेगा, यही rank मिलेगा? Can you be certain about it? No. You cannot be certain about it. So uncertainty एक fact है जो life में है ही है, right? Whenever there is uncertainty, there is presence of probability. कि अच्छा 50% chance है it will rain, 50% chance है it will not rain, 90% chance है कि I will reach home safely if I drive properly, 10% chance I can still meet an accident, right? So whenever there is uncertainty, जभी भी uncertainty होगी, there would be presence of probability. There will be presence of probability. Therefore, हम एक term introduce करते हैं जो statistics में पढ़ाया जाता है, which is called as probability distribution. Probability distribution. But what is probability distribution? Probability distribution means giving probability to each value of random variable. ये statistical definition, and this is the statistical definition, giving probability to each value of the random variable. For example, बच्चे, when we toss a coin, ठीक है, Let's say that X represents the number of heads. So when you toss a coin, क्या हो सकता है? Either you will get head or tail. है ना? तो the number of head can be either 0 if you get a tail. अगर tail आ गया तो number of head 0 हो जाएंगे. Or the number of head will be 1. अगर head आ गया तो number of head will be 1. What is the probability associated with it? Half probability है that you will get tail and half probability है that you will get head. Right? So we have gone ahead and we have made this table. हमने एक ये table बना दिया. Where we have said that when value of x is this, उसका probability है. When value of x is that, उसका probability है. So with each value of x, we are going ahead and we are giving the corresponding probabilities. हमने corresponding probabilities दे दिया. Right? That is a probability distribution. So let's define a probability distribution in economics. So a probability distribution is when each consumption bundle is defined with corresponding probability. Each consumption bundle is defined with corresponding probability. हमने हर consumption bundle को उसका probability के साथ हमने define किया, right? जैसे for example, let's say that there is this person, and this person, he is playing a lottery, and he has $10 with him. उसके पास $10 है. And what he can go ahead and he can do is either he can put this $10 जब वो लॉटरी में कर रहा है, either he can win. If he wins the lottery, तो यही $10 it will become $20. He can win with probability half. या फिर he can lose. And he can lose with probability half अगर वो lose करता है. If he loses, so this $10 it will become $0. वही $10 it will go ahead and become $0. So either he can go ahead and he can get $20, right? Or he can go ahead and get $0. So हमने एक consumption bundle define कर दिया. We have defined a consumption bundle that what is his payoff beta? कितना वो consume कर सकता है? Either he can consume $20 or $0. And what is the probability associated with it? Half and half. Right? When we do this, जब हम इसको ऐसे लिखते हैं, when we define it like this is called as probability distribution. ठीक है? इसको क्या बोल देते हैं? Probability distribution. Is this clear? ठीक है. Now, let us try to go ahead and let us try to understand another thing. देखो, whenever we talk about uncertainty, तो जरूरी नहीं है कि सिर्फ मनी मैटर करे, right? A lot of times it is consumption that will matter. Consumption matters. ठीक है? A lot of time it is the consumption that will matter. जैसे for example, बहुत simple है, एक example ले लेते हैं. So for example, if I go ahead and I tell you that there is, so suppose I tell you that there is this person, Mr. G, and he has a very old grandparent who is 90 years, right? And with probability 7 by 10, the grandparent will live for 1 more year. And with probability 3 by 10, he will not live 1 more year. ऐसा कुछ, ठीक है? Looking at his health, हमें लगता है कि he will live for 1 year with probability 7 by 10 and not live with probability 3 by 10. So here we are not talking about money. Here we are talking about an individual, right? So this is a possibility where we are talking about consumptions or we are talking about individuals. ऐसा हो सकता है ना? But for simplicity's sake, we only consider monetary outcomes in our chapter. हम ऐसे situations को consider नहीं कर रहे हैं. We are not considering these situations. We are only going ahead and considering situations which are involving money, जहां पे पैसा involved है, where money is involved. That's the first thing. Second thing is that it is possible. Yes, this is scenario number 1, beta. The second thing is that it is possible that there can be a lottery with many outcomes. जैसे example देती हूँ. How many of us have played Tambola? I'm not sure if you play it or not, but I know that whenever we have a Diwali Mela in our society, so Tambola तो definitely is one of the games that is played. ठीक है? So in Tambola, you can win multiple amount with multiple probabilities. अलग-अलग amount आप अलग-अलग probabilities के साथ जीत सकते हो. जैसे for example कि if you have 1 row या 1 column या 2 rows या houseful या diagonal, हर एक का अलग-अलग probability रहता है and accordingly you win different money. है ना? तो तंबोला में जैसे फॉर एग्जाम्पल समटाइम्स दे से द फर्स्ट टू गेट द सेंटर, हाँ ऐसा कुछ, द फर्स्ट टू हैव द डायगोनल लाइन कट, है ना? तो देयर आर वेरियस आउटकम्स, बहुत सारे आउटकम्स होते हैं, राइट, कॉरेस्पॉन्डिंग टू द वेरियस प्रोबेबिलिटीज. बट in our examples, in our chapter, we will restrict ourselves to simple situations. हम वही simple situations पढ़ेंगे where there are only few possible outcomes. जैसे this is a simple situation कि हाँ there are only 2 outcomes, या money double या money zero, right? It's a simple situation. I can do the same thing with multiple situations also. कोई दिक्कत नहीं है, right? But we would restrict ourselves. हम simple situations की ही बात इसमें करेंगे. That is another thing which you can go ahead and understand in this chapter. ठीक. अच्छा, one example that I want to go ahead and give it to you. So example number 1, beta. Let's say that there is an individual. And this individual, he has $35,000 with him. $35,000 के उसके पास assets हैं, right? And there is a probability that he can lose $10,000. ठीक है? कब $10,000 उसका क्या है, क्यों lose करेगा? Why will he lose it? Because he can get his car stolen. उसका car stole हो सकता है, ठीक है? या there can be an earthquake that can damage his house. तो उसका 10,000 तक का assets can be lost. There is a possibility ये ऐसा कुछ हो जाए. So that means And what is the probability that he will lose this $10,000? उसका probability है 0.01, very less probability, right? So basically what is going to happen, यहाँ पे हमारे पास एक uncertainty situation हो जाता है, and correspondingly हम एक probability distribution को prepare कर सकते हैं. We can make a probability distribution. And what are we saying? That but if he loses $10,000 out of 35, तो कितना बचेगा उसके पास? How much he will be having? He will be left up with $25,000, right? And the probability of that will be 0.01. इतना ही तो probability that he has lost the $10,000, right? And with 99% probability, he will be, there will be no car stolen, no earthquake, कुछ नहीं हो रहा, उसका asset intact है. So this will be 35,000. तो माने there is a 1% chance. परसेंट में हाउ डू वी कन्वर्ट? मल्टीप्लाई विद 100. तो अगर मैं इसको 100 से मल्टीप्लाई करूंगी, आई विल गेट 1, एंड इफ आई मल्टीप्लाई दिस विद 100, आई विल गेट 99. तो देयर इज अ 1% चांस बेटा, 1% चांस दैट हिज मनी विल बिकम 25,000. वो 10,000 खो देगा, ही विल लूज 10,000. And there is a 99% chance that he will not lose this money and his money will be intact to 35,000. उसका पैसा नहीं खोएगा and he will have these money intact. Now, whenever we have this kind of situation, जब भी ऐसा कभी भी होता है, and you would have seen this in your family also, but whenever we have this kind of situation, कि अच्छा, there can be a loss, we can lose money. So, in those kind of situations, what do individuals do? We want to cover the risk. क्या करना चाहेंगे हम? In these kind of situations, individuals want to cover risk. Individuals want to cover their risk. कैसे कवर कर सकते हैं? How can individuals cover their risk? Very simple. One way of going ahead and covering the risk can be through insurance, by taking insurance. So individuals can go ahead. Individuals can take insurance, and by taking insurance लेकर वो अपने इस risk को cover कर सकते हैं. They can go ahead and they can cover their risk. But whenever you take insurance, I am just giving you, बेटा in this lecture मैं बस एक अभी आपको numerical form में नहीं लेके जा रही हूँ. I am just going ahead and giving you some definitions. ठीक? So whenever you take any insurance, आपको पता होगा, जैसे बहुत सारा एड्स आता रहता है, LIC का एड आता है, बजाज फाइनेंस का आता है, बाकी सब आते हैं. तो वो क्या बोलते हैं कि इतने कम प्रीमियम में हम आपको इंश्योरेंस दे रहे हैं. सो प्रीमियम इज द फीस दैट यू पे टू बी पेड फॉर कवरिंग द रिस्क फॉर दिस इंश्योरेंस. माने इफ एनीथिंग रॉन्ग हैपेंस विद यू, आपके साथ कुछ भी गलत हो जाता है, देयर इज योर कार इज स्टोलन, देयर इज एन एक्सीडेंट, हाँ, देयर इज एन अर्थक्वेक, द इंश्योरेंस कंपनी विल पे यू, राइट? द इंश्योरेंस कंपनी विल पे यू, बट you have to pay premium every year to this insurance company. और ये करवाना ना कुछ कुछ जगहों पे कंपलसरी है, जैसे फॉर स्टूडेंट्स इफ यू हैव सीन, हाँ, तो जब हम whenever we have a car, है ना, या whenever we have any vehicle, तो इंश्योरेंस करवाना कंपल्शन है, राइट? if you're caught without an insurance, you will have to pay a fine. तो गेटिंग इंश्योर्ड इज नेसेसरी, जरूरी है कि आप अपने आप को इंश्योर करके रखो, राइट? सो दिस इज व्हाट इट मींस. सो प्रीमियम इज व्हाट यू आर पेइंग टू द इंश्योरेंस कंपनी. जो पैसा हम इंश्योरेंस कंपनी को देते हैं टू गेट आवरसेल्व्स इंश्योर्ड, राइट, दैट इज कॉल्ड एज इंश्योरेंस प्रीमियम, राइट? Okay, so now we will go ahead and we will look at some numerical on insurance premium in the next. Hi, good afternoon, everyone. So today we are going to go ahead and talk about insurance. Huh? We already started talking about insurance in the previous chapter, previous lecture, but we will go ahead and we will continue our discussion around insurance. Now, see, let us go ahead and let us take an example. Here, we are going ahead and we are saying that there is going to be, so whenever there is going to be a loss, whenever there will be a loss, right? This is just example beta. Whenever there will be a loss, then the person will go ahead and purchase an insurance. The person will go ahead and purchase an insurance. This insurance, for this insurance, you have to pay premium. है ना? अब ये जो प्रीमियम रहेगा, this will be paid whether loss occurs or not. माने अगर तो फायर होती है, suppose I am insuring my house against fire. So if there will be fire, then also I have to pay insurance. If there will be no fire, then also I have to pay insurance. So insurance has to be, premium. Then premium has to be paid whether or not loss occurs. Premium आपको हर situation में pay करना होता है. So write this important point that premium on insurance has to be paid whether or not the loss occurs. Premium has to be paid in both kind of situation. Loss होगा तो भी pay करना पड़ेगा नहीं होगा तो भी pay करना पड़ेगा, right? Now suppose an example of insurance contract is that person will pay $1 premium for covering every $100 amount of loss. तो इसको हमने एक एग्जाम्पल के तौर पे देखा कि जब हमें 100 रुपए तक का लॉस कवर करना है, whenever we have to cover an amount equal to $100, I will pay a premium worth $1. I have to pay a premium worth $1. अब ध्यान से देखना, listen to me very carefully. It is very tricky. I am going back to this example बेटा. हम इस example पे चलते हैं एक बार के लिए, right? In this example that we studied, there were two situations, right? 99% of the time, my money was intact and I had 35,000 intact with me. 1% of the time, I had a loss and I had only 25,000 left. सिर्फ 1% चांस है कि मुझे लॉस होता था. There is only 1% chance that the person had a loss, right? And when the person had a loss, then his amount was becoming 25,000. Is this clear? Now what we are going ahead and saying is that this person is buying this insurance contract. उसने ये contract खरीद लिया. So beta, how much loss is he incurring? कितना gap है? So the loss incurred will be 35,000 minus 25,000, which means 10,000. इतने का लॉस इसको हो रहा है. This individual is incurring a loss of 10,000 बेटा. अब देखो, ये लॉस उसको कवर करना है. He wants to cover this loss कि even ये 1% of situation में मेरे को इंश्योरेंस कंपनी ये पैसा दे दे. The company should pay me this 10,000. I want to cover this loss. So now what this person is doing is he is buying insurance. तो बेटा जब उसको 100 रुपए कवर करने थे, when he had to cover $100, How much premium he was paying? He was paying premium of $1. Now he has to cover how much loss? $10,000. So to cover $10,000, but how much premium he will pay? Nahi aata, no problem. Do unitary multiplication. Always multiply this with this, opposites multiply and divide by this. So 10,000 into 1 divided by 100, it means that beta he will pay a premium of $100. He will pay a premium of $100. तो माने when he wants to cover $10,000, अगर उसको इतना पैसा कवर करना है, he will have to pay a premium of $100. ये बात क्लियर हो? Okay. Now let us go ahead and let us rewrite this situation. इसी situation को दोबारा लिख लेते हैं. So 99% of the time he had 35,000 and 1% of the time he had 25,000. But now he has purchased insurance and he has got a coverage of entire loss. माने उसने पूरे $10,000 को कवर कर लिया है. He has covered entire $10,000 in the insurance. समझे? Now, but 35,000 is when there was no loss. But क्या बोला मैंने आपको? What did I say? He has to pay premium in all situation. कंपनी बेवकूफ थोड़ी है. कंपनी प्रीमियम तो हमेशा लेगी. So you have to go ahead and pay the premium in all situation. So whether it is loss or no loss, दोनों ही situation में premium will be paid. But so here you are left up with 34,900. But यहां पर when there is a loss beta, when there is a loss, so company will bear your loss क्योंकि आप उसको हमेशा प्रीमियम देते आए हो. So company will pay you the amount of your coverage. जितना भी आपने कवरेज लिया होगा, whatever insurance coverage you would have taken, company will go ahead and pay you that money. So company will pay you 10,000. तो अब what will be the amount here बेटा? यहाँ पे भी you will get 34,900. 34,900. So notice that by taking insurance, please write with me, after taking insurance, individual has the same wealth in all situations. Therefore, he has covered his risk. So now the individual is in the same position. Here also individual has 34,900 and here also individual has 34,900. So he has the same money in all situations. ये बात समझ में आई? ठीक है. Now what we can go ahead and we can do is we can go ahead and we can generalize this case. So please write down general case. Under general case, but let's say that the insured amount is K dollars. जैसे यहां पर insured amount was $10,000. माने whenever you will have loss, company will pay you 10,000. Now I am saying that insured amount is K dollars, right? And premium is some percentage of insured amount. जैसे this gamma can be any number बेटा. जैसे मैं कह सकती हूं कि अगर मेरा insured amount 10,000 है और गामा 1% है, तो 1% of 10,000 कितना आ जाएगा बच्चे? $100. तो premium will be 100. Example is clear? So I am saying that premium is some amount, some percentage of the insured amount, of the insured amount. ठीक है. Now, if I want to go ahead and I want to do the same case, so 99% of the time there is no loss and you have 35,000 intact, and 1% of the time you have loss and you have just 25,000 with you. आपको लॉस हो गया और आपके पास 25,000 ही बचा. Now we don't know how much money we have insured here. जैसे here in this case we knew कि अच्छा हमने पूरा मनी इंश्योर करवा लिया, जितना लॉस था we have done full insurance, we have covered fully, जितना भी लॉस हो रहा था, whatever was the loss, we were taking insurance exactly equal to the loss. Here we are not doing that. इधर हम बोल रहे हैं that we are taking insurance equal to K dollars. ठीक है. So beta, in this case, tell me something. What will be the amount left when there is no loss? 35,000. You will pay premium minus lambda K or gamma K. This is called gamma. And beta, in case of loss, 25,000. प्रीमियम तो भी देना पड़ेगा, बट कंपनी से कुछ अमाउंट वापस आ जाएगा जितना भी आपने कवर किया होगा. यू विल गेट बैक सम अमाउंट ऑफ अमाउंट बैक फ्रॉम द कंपनी. इज दिस क्लियर? नाउ हाउ मच अमाउंट यू विल इंश्योर? इट विल डिपेंड ऑन द टाइप ऑफ कंज्यूमर, कि क्या वो कंज्यूमर ज्यादा रिस्क लेना चाहता है या कम रिस्क लेना चाहता है. सो व्हाट काइंड ऑफ अमाउंट विल ही कवर द इंटायर लॉस? क्या वो अपने आप को फुल्ली कवर करेगा और विल ही ओनली कवर सम लॉस? इट विल डिपेंड ऑन द प्रेफरेंस ऑफ द कंज्यूमर, इट विल डिपेंड ऑन द टाइप ऑफ द कंज्यूमर, राइट? वेदर द कंज्यूमर इज वेरी स्केयर्ड ऑफ रिस्क, उसको बहुत डर लगता है पैसा खोने से, या वेदर द कंज्यूमर इज लविंग रिस्क, ठीक आने दो ना, 1% चांस ही तो है, और वेदर द कंज्यूमर इज इनडिफरेंट बिटवीन टेकिंग रिस्क और नॉट टेकिंग रिस्क. सो बेसिकली व्हाट हैपेंस इज दैट हाउ मच मनी द इंडिविजुअल विल इंश्योर, ये के का वैल्यू कितना आएगा, इट विल डिपेंड ऑन द प्रेफरेंस और द टाइप ऑफ द कंज्यूमर. वो इस बात पे डिपेंड करेगा कि कंज्यूमर किस तरीके का है. I hope this is clear to you. Now these different outcomes that we are getting, जैसे एक यहां पे आ गया amount, एक यहां पे आ गया amount, these different outcomes that we are getting, these are called as different state of nature. So please write down different outcomes obtained are called different state of nature. Different state of nature. There is another word that I want to define today. इसे बोल देते हैं हम contingent. Contingent. Contingent means dependent on something which is not certain. जहां पे uncertainty involved हो वो होता है contingent. So something which is not certain is called contingent. Is called contingent. And but from here only we get another term, contingent consumption plan. It means that अलग अलग सिचुएशन में हम कैसे कैसे कंज्यूम करेंगे, क्योंकि सर्टेनिटी नहीं है, अनसर्टेनिटी है. right? We don't have certainty here. We have uncertainty that, 99% this will happen, 1% this will happen. So under different state of nature, how we will be going ahead and we will be consuming, that is called as contingent consumption plan. So please write down consumption plan under different state of nature is called contingent consumption plan. It is called contingent consumption plan. ठीक है? अब जब हम इंश्योरेंस लेते हैं तो हम इस कंटिंजेंसी को थोड़ा कम करने की कोशिश करते हैं, हम इस अनसर्टेनिटी को थोड़ा सा कम करने की कोशिश करते हैं. सो व्हेन वी बाय इंश्योरेंस, we basically try to lower the amount of contingency, to lower the amount of uncertainty. So please write down. By purchasing insurance, consumer aims to lower the amount of uncertainty. ठीक है? He wants to lower the amount of uncertainty that exists. Is this clear, beta? ठीक है. Now, one last thing that I want to highlight here. So, ये जो हम contingent consumption plan की बात कर रहे हैं, all of this can be analyzed just like a usual way, like we have gone ahead and we have analyzed the budget line and indifference curve in the general concept. Similar, in the contingent consumption plan also, we can go ahead and analyze budget line and the indifference curve concept. तो जो भी चीज हमने अभी तक सीखी है, उसी चीजों को हम यहाँ पर भी अप्लाई कर सकते हैं. बस यहाँ पर हमें एक चीज का ध्यान रखना होगा कि जो भी हम बजट लाइन या इंडिफरेंस कर्व बनाएंगे, उसमें हम कंटिंजेंसी की बात करेंगे. We will be talking about uncertainty there. That's the only thing that we have to keep in mind. Hi, good afternoon, everyone. Beta, today we are going to learn how to draw budget line for contingent consumption plan. अभी के लिए जो हम क्वेश्चन लेंगे, it would be the same that we had been doing in the last class. So this was our equations for no loss case. Our expected payoff after paying the insurance premium, beta वो आया था 35,000 minus gamma k, and in case of loss हमारा जो amount आया था that was 25,000 minus gamma k plus k, right? Minus gamma k plus k. Let us try to go ahead and let us try to plot this thing. In order to plot this thing, देखो क्या कैसे करेंगे हम, इसका budget line कैसे बनाएंगे. We will go ahead and we will take CB here. ठीक है बेटा, CB means what? CB means consumption under bad outcome. Consumption under bad outcome. ठीक है, consumption under bad outcome. और हम यहाँ पे लेंगे CG. CG means what? Consumption under good outcome. ठीक है. अच्छा एक बात बताओ मुझे, when you are starting, जब आपने इंश्योरेंस नहीं खरीदा, when you are just starting, when you enter the market. Enter the market means जब आप एकदम शुरू ही करते हो, you haven't purchased any insurance at that time. जिस अमाउंट के साथ हम एंटर करते हैं मार्केट को, that is called as our endowment bundle. उसको क्या बोला जाता है? It is called as our endowment bundle. So endowment, please write the word endowment. Bundle is the bundle a consumer enters the market with. माने इस केस में जब हमने एंटर किया मार्केट, जब हमने कोई इंश्योरेंस नहीं खरीदी थी, सो हमारा गुड स्टेट में कितना पैसा था? हाउ मच मनी वी हैड अंडर गुड स्टेट बेटा? अंडर गुड स्टेट विदाउट इंश्योरेंस वी हैड 25,000 and under bad state without insurance we had 25,000. तो गुड स्टेट में 35,000 and bad state में 25,000 है कि नहीं है? दिस बंडल माने 25,000 कॉमा 35,000, this bundle is called as our endowment bundle. इस बंडल को हम endowment bundle बोलते हैं. So if I draw a budget line, अभी हमें नहीं पता what points we are talking about, but if I draw a budget line, तो इस budget line पे ये budget line एक endowment bundle से जरूर पास करेगी, because this is what you have entered the market with. This is what you have entered the market with. तो जिस बंडल के साथ हमने मार्केट को एंटर किया है, वो बंडल हमेशा बजट लाइन पर होगा ही होगा. The endowment bundle will always be on the budget line because that is the bundle which you enter the market with, जिसके साथ आप इस मार्केट में घुसे हो, right? So therefore this bundle is what beta? 25,000 and 35,000. Okay. Now beta with insurance. सो गुड स्टेट में क्या हो गया था? वंस यू हैड परचेज्ड इंश्योरेंस, आपका कंजम्पशन इतना हो गया था 35,000 माइनस गामा के. यू हैड टू पे सम प्रीमियम, आपको कुछ प्रीमियम पे करना था. सो योर कंजम्पशन वाज आफ्टर पेइंग द प्रीमियम, राइट? सो इट वाज 35,000 माइनस गामा के. माने 35,000 में से समथिंग वाज गेटिंग सब्ट्रैक्टेड, तो 35,000 से कुछ अमाउंट कम हो रहा था. 35,000 माइनस गामा के. और बैड स्टेट में क्या हो रहा था? हाँ, अंडर बैड स्टेट आई वॉज गोइंग अहेड एंड आई वॉज पेइंग प्रीमियम, बट आई वॉज ऑल्सो गेटिंग सम मनी बैक फ्रॉम द कंपनी. मुझे के अमाउंट कंपनी से वापस मिल रहा था एंड आई वॉज पेइंग अ प्रीमियम ऑफ गामा के, राइट? सो अंडर बैड स्टेट बेटा, बैड स्टेट में मेरा जो फाइनल कंजम्पशन था, इट वॉज मोर देन 25,000. देखो, इट वॉज मोर देन 25,000. ये देखो, दिस इज 25,000. मैं के कॉमन लेती हूँ, 1 माइनस गामा, एंड गामा हैज टू बी सम परसेंटेज. गामा 0 और 1 के बीच में है ना? जैसे प्रीमियम क्या था? 10%, 20%, 30%. प्रीमियम तो कुछ परसेंटेज है ना. तो दिस गामा इज अ डेसिमल. 10% हुआ तो 0.10, 20% हुआ तो 0.20. सो दिस गामा इज सम परसेंटेज. तो समझो इस बात को, दैट बिकॉज ऑफ इंश्योरेंस, your consumption in bad state exceeded 25,000. आपका जो बैड स्टेट का कंजम्पशन था वो 25,000 को एक्सीड कर रहा है, इट इज 25,000 प्लस समथिंग, 25,000 से ऊपर जा रहा है, सो दिस इज दिस अमाउंट बेटा, यहां पे मैंने मार्क कर दिया 25,000 से एक्सीड कर रहा है, सो 25,000 प्लस के 1 माइनस गामा। अब हम बात करेंगे स्लोप ऑफ बजट लाइन की। बेटा हाउ हैव आई एक्सप्लेन्ड यू द स्लोप? क्या होता है स्लोप ऑफ एनीथिंग? द स्लोप ऑफ बजट लाइन इज, या किसी भी लाइन का अगर हमें स्लोप निकालना है, द स्लोप ऑफ एनी लाइन इज गोइंग टू बी परपेंडिकुलर बाय बेस, इट विल बी परपेंडिकुलर बाय बेस। So if I come to this budget line, what is going to be my perpendicular beta? This amount, ये वाला है ना। So perpendicular is 35,000 minus 35,000 minus this, this is equal to gamma के। ये जो गैप है इन दोनों का, द गैप, दिस इज गामा के, ठीक है बेटा। व्हाट विल बी द बेस? बेस इज दिस, ये अमाउंट। So what will be base beta? 25,000 plus k 1 minus gamma minus 25,000, ये हो जाएगा k 1 minus gamma। अच्छा यहाँ पे आई हैव मेड अ लिटिल मिस्टेक बेटा, हम जब भी सब्ट्रैक्ट करते हैं ना तो वी टेक whenever we subtract, so if you are starting by taking 1 point, जैसे अगर हमने यहाँ पर 25,000 प्लस के 1 माइनस गामा में से इसको सब्ट्रैक्ट किया है ना, तो हमने पहले ये वाला पॉइंट लिया, फिर इसमें से इसको सब्ट्रैक्ट किया, माने पहले हमने पॉइंट ए लिया, ए के कोऑर्डिनेट्स लेने हैं दोनों जगह पे, और फिर पॉइंट बी लिया। देख रहे हो, फर्स्ट आई टुक दिस पॉइंट and then I subtracted this point. So I have to follow the same thing for perpendicular also. So in perpendicular, first I will take this point beta. That means I will do 35,000 minus gamma k minus 35,000. This will give me minus gamma k. ये बात समझे? Is this making sense? So here, if I am doing this point minus this point, to find the base, अगर मैंने point A का coordinate पहले लिया है, if I've taken the coordinate of point A first minus the coordinate of point B, फिर मैंने B का coordinate लिया और इसका distance निकाला, so to find perpendicular also I will take the coordinate point of A first minus coordinate point of B, है ना। मतलब coordinates should match, this is what I am saying। तो अगर हमने to find the base, if I am doing this point minus this point, तो इसके कॉरेस्पॉन्डिंग परपेंडिकुलर में ये पॉइंट है, सो टू फाइंड द लेंथ ऑफ परपेंडिकुलर यू विल डू दिस पॉइंट माइनस दिस पॉइंट। इज दिस क्लियर? सो यहां से व्हाट विल बी अवर स्लोप बेटा? स्लोप विल बी परपेंडिकुलर डिस्टेंस बाय बेस डिस्टेंस, k and k will cancel, तो स्लोप विल बी माइनस गामा अपॉन 1 माइनस गामा, ठीक है। सो व्हाट विल बी द स्लोप? माइनस, माइनस रिप्रेजेंट करता है कि इट इज नेगेटिवली स्लोप्ड बजट लाइन, है ना। जस्ट लाइक यूजुअल, जैसे हम यूजुअल बजट लाइन करते हैं तो हमारा स्लोप माइनस पी एक्स बाय पी वाई आता है ना। सो दिस नेगेटिव रिप्रेजेंट्स की डाउनवर्ड स्लोपिंग बजट लाइन है, सो दिस नेगेटिव इज रिप्रेजेंटिंग दैट दिस इज अ डाउनवर्ड स्लोपिंग बजट लाइन, एंड जो हमारा स्लोप है दैट इज एक्चुअली द स्लोप इज गामा अपॉन 1 माइनस गामा, दैट इज द स्लोप ऑफ द बजट लाइन, ठीक है। ओके, नाउ व्हाट यू कैन गो अहेड एंड डू इज बेटा, एक बारी हमें ये पता चल गया, तो अब हमें वी नीड टू गो अहेड एंड वी नीड टू आस्क कि हाउ टू फाइंड इक्विलिब्रियम। हाउ टू फाइंड इक्विलिब्रियम? So we have already found out the budget line. Okay. Acha, now we know that under usual circumstances, whenever we were finding the equilibrium, जब भी हमें equilibrium निकालना होता था, so equilibrium always used to be the tangency condition. Wherever there was tangency of indifference curve to budget line, that was our equilibrium condition. वहां से हमारा equilibrium निकलता था. Isn't it? बेटा in this case the slope of budget line हमने निकाल के देख लिया है. Slope of budget line is minus gamma upon 1 minus gamma, है ना. और हम हमेशा whenever we equate हम हमेशा absolute values लेते हैं slope का. So if I would have taken it in absolute value, माने हमारा slope would have been gamma upon 1 minus gamma. ठीक है बेटा. Slope of indifference curve is nothing but MRS. डिपेंडिंग ऑन क्या आपको इक्वेशन दिया हुआ है इंडिफरेंस कर्व का. जैसे फॉर एग्जांपल इफ आई टेल यू कि मेरा यूटिलिटी फंक्शन बिटवीन गुड स्टेट एंड बैड स्टेट इज गुड स्टेट इनटू बैड स्टेट, यही मेरा यूटिलिटी फंक्शन. ठीक है. और अगर मैं आपको बोल दूं कि प्रीमियम जो है वो 10% है, गामा इज 10%, है ना. तो व्हाट विल यू डू बेटा? वेरी सिंपल मैम, हम क्या करेंगे ना, वी विल गो अहेड एंड वी विल फाइंड एमआरएस. MRS will be MUX by MUY. इस केस में on the X axis we have bad state, on the Y axis we have good state. So if I will differentiate this with respect to B, CB, तो मुझे मिल जाएगा CG. CB की तरफ से करेंगे तो this is a constant और इसका differentiation will be 1. And if I will differentiate with respect to CG बेटा, if I will differentiate with respect to CG, तो इसका डिफरेंशिएशन हो जाएगा 1 एंड दिस इज अ कांस्टेंट, तो इट विल बी CB, है ना. तो MRS इन दिस केस, MRS विल कम आउट एज CG by CB. तो MRS विल बी CG by CB इक्वल टू द स्लोप ऑफ बजट लाइन. बजट लाइन का स्लोप क्या है? गामा अपॉन 1 माइनस गामा. सो गामा upon 1 minus gamma. That means CG by CB will be 0.10 divided by 0.90. तो CG by CB will be 1 by 9. तो ये हमारा टेंजेंसी कंडीशन आ गया. This is our tangency condition. ठीक है. So in order to understand what our equilibrium is, अगर हमें ये जानना है कि equilibrium क्या है, if I want to understand the equilibrium condition, I should be finding the tangency between indifference curve and budget line. और tangency किस पे डिपेंड करेगा कि what equation is given to me for the indifference curve. इंडिफरेंस कर्व का क्या इक्वेशन मुझे दिया हुआ है उस पर डिपेंड करेगा द tangency condition. इज दिस क्लियर? ओके बेटा, थैंक यू. Hi, good evening, everyone. Beta, in today's class, we are going to take one example, and this is going to be about the catastrophe bonds. Okay. Now, when we talk about insurance, किसी भी transaction में there are two sides to a transaction. One side is the person who is buying and the other side is the person who is selling. In insurance market also we have two sides. एक तो हो गया the person who is buying insurance and the second is the person who is selling insurance. है ना? Today we want to focus in this lecture on the part of the person who is selling insurance. The person who is सेलिंग इंश्योरेंस। अब ये सेलिंग साइड इंश्योरेंस का, दिस सेलिंग साइड इज डिवाइडेड इन मल्टीपल पार्ट्स. The first part is called as the retail component. It's called as the retail component. बेटा रिटेल कंपोनेंट माने जब कोई कंपनी डायरेक्टली एंड यूजर को सेल करे. मतलब आई वांट टू बाय इंश्योरेंस फॉर माई सेल्फ एंड आई एम परचेजिंग इट फ्रॉम अ कंपनी. when you are directly dealing with end users, directly dealing with end users, when you are directly dealing with end users, so that is called as retail component. The other component that we have, but that is called as wholesale component. उसको बोल देते हैं wholesale component. Wholesale component is one where one party is selling to another party. ठीक है, एक पार्टी ने दूसरी पार्टी को बेचा, but this party is not the end user. This party can sell to third party, right? So wholesale component is where insurer, मतलब इसने पहले अपने आप को इंश्योर करवाया, is selling the risk to other party और उसने फिर आगे किसी और को sell off किया, right? This wholesale component is called as reinsurance market. It's called as reinsurance market. So it is not always the case that you are selling to end user. अगर आप end user को नहीं sell कर रहे हो, then you are part of reinsurance market. ठीक है, reinsurance market में, within the reinsurance market, it is dependent on large investors. The reinsurance market is dependent on large investors, like, for example, pension funds, right? Which provide financial backing for risk. माने वो क्या कर रहे हैं, जैसे for example, इस केस में एक reinsurance market के केस में क्या होगा, there will be a financial intermediary, like reinsurance company या investment bank. Okay. And this, so it will be the case that suppose there is an insurance company, यहाँ पे एक insurance company है, इस कंपनी ने लोगों को नहीं इंश्योरेंस बेची, बट एक बहुत बड़ी फर्म को, जिसे हम बोल रहे हैं री इंश्योरेंस कंपनी, एक बहुत बड़ी फर्म को उसने क्या किया, उसने बेच दिया कि ठीक है, ये लो, ये छोटे छोटे इंश्योरेंस के वो हैं, आप अलग अलग लोगों को बेच सकते हो, हमने आपके साथ ओवरऑल इतने बड़े अमाउंट का एक ट्रांजैक्शन कर लिया कि आपने हमसे खरीद ली. मतलब नाउ दिस इंश्योरेंस कंपनी इज नॉट हैविंग द हेडेक टू सेल टू द फाइनल कंज्यूमर. इट हैज गॉट द रीइंबर्समेंट, उसको पैसा यहां से ही मिल गया, ही इट हैज गॉट मनी फ्रॉम द री इंश्योरेंस कंपनी. Now this reinsurance company is involved with the final consumers and selling to them. ये इसका काम है कि वो final consumers को बेचे, right? So this is how this is working, right? Now within this, तो बेसिकली ये जो reinsurance company है, it's a big investor. इसने एक साथ इस insurance company से खरीद लिया. जितने में उसने खरीदा वो उससे ज्यादा प्रीमियम पे आगे सेल करेगा एंड इट विल मेक प्रॉफिट इन दिस सिचुएशन. Now, reinsurance companies have brought a new product. They are experimenting with the product and उस product को कहा जाता है catastrophe bonds or catastrophic bonds. Different people call it by different pronunciation. ठीक है. और ये जो catastrophe bonds हैं, these are more flexible ways, better ways, more flexible way to provide reinsurance. ठीक है. अब क्या करना है हमने, अब देखो. सो फॉर एग्जाम्पल, देर इज अ कंपनी XYZ. ठीक है. ये कंपनी को अपना इंश्योरेंस सेल करना है, राइट. What this company will go ahead and do is it will sell this insurance to a reinsurance company. Now, in this reinsurance company, there will be large investors, बड़े बड़े बहुत पैसे वाले इन्वेस्टर्स होंगे. There will be large investors or large institutions, right? Now, suppose let's say that I am selling insurance, और क्योंकि इंश्योरेंस इज लिंक्ड टू नेचुरल डिजास्टर, माने मुझे कब किसी किसी को कब जरूरत पड़ेगी इंश्योरेंस की, अगर कभी उसका कुछ घर में इशू हो गया, गाड़ी में इशू हो गया, ड्यू टू सम, इट कैन बी ड्यू टू अर्थक्वेक ऑल्सो, हरिकेन ऑल्सो, कुछ भी हो सकता है, राइट. सो दीज लार्ज इंस्टीट्यूशंस, दे हैव बीन टाइड टू नेचुरल डिजास्टर्स. इनको हमने नेचुरल डिजास्टर से लिंक किया हुआ है. They are linked to natural disasters, right? Like earthquake, like hurricanes, etc. ठीक है. तो अब क्या होगा, एक एग्जाम्पल के तौर पे देखो जरा, ट्राई टू अंडरस्टैंड दिस थिंग. नाउ व्हाट विल हैपन, सपोज सपोज हमने एक बॉन्ड इशू किया जिसको हमने बोला कैटास्ट्रॉफ बॉन्ड. वी इशू दिस बॉन्ड और हमने बोला कि ये जो बॉन्ड है ना, ये एक इवेंट से लिंक्ड है. दिस बॉन्ड इज लिंक्ड टू एन इवेंट. ठीक है. और ये इवेंट को हमने बना दिया कि दिस इज एन अर्थक्वेक इवेंट. क्या इवेंट है, अर्थक्वेक. ठीक है. एंड नाउ वी आर सेइंग दैट दिस बॉन्ड इज एसोसिएटेड विद एन इंश्योरेंस क्लेम. और इंश्योरेंस क्लेम का अमाउंट है $500 million. ठीक है. इफ देयर इज नो अर्थक्वेक, अगर कोई भी दिक्कत नहीं आती है, राइट, इफ देयर इज नो अर्थक्वेक, देन इन दैट केस जिस भी इन्वेस्टर ने मुझसे ये बॉन्ड खरीदा होगा उसको मैं बहुत हैवी इंटरेस्ट दूंगी, क्योंकि उसने ये रिस्क लिया ये वाला बॉन्ड खरीदने का. सो इंटरेस्ट विल बी पेड टू दैट इन्वेस्टर. हैवी इंटरेस्ट, हाँ, बहुत अच्छा इंटरेस्ट मिल जाएगा उसको अपने पैसों पर. बट इफ देयर इज अर्थक्वेक, अगर अर्थक्वेक आता है तो हम देखेंगे कि कितने लोगों को असली में नुकसान हो. ये तो टोटल वैल्यू है कि टोटल इंश्योरेंस अमाउंट इतना हमने रखा था, इतने लोगों का हमने टोटल इंश्योरेंस किया था, दिस इज द अमाउंट टू बी इंश्योर्ड. बट जरूरी नहीं है ना दैट एवरीवन विल एक्चुअली हैव इश्यूज, राइट. सो वी विल सी दैट हाउ मेनी क्लेम्स केम. ठीक है. एंड इफ जो लोगों ने जो क्लेम किया है वो ज्यादा है देन द अमाउंट ऑफ बॉन्ड, इससे भी ज्यादा अमाउंट से, 500 से, राइट, देन जिस इन्वेस्टर ने खरीदा होगा, whoever investor has purchased it, they will have to sacrifice, let go of their principal amount also and their interest also. समझे, माने इट इज अ रिस्की सिचुएशन. कि मैंने एक ऐसा बॉन्ड खरीदा है, आई हैव परचेज्ड सच अ बॉन्ड विच इज एसोसिएटेड टू एन इवेंट। अगर वो इवेंट नहीं हुआ, किसी का भी नुकसान नहीं हुआ, तो मेरे को पैसा मिलेगा। क्योंकि जब आपने लोगों को इंश्योरेंस की, जब लोगों की इंश्योरेंस करी आपने, तो वहां पे आपने लोगों से प्रीमियम तो इकट्ठा किया ही है। उस प्रीमियम से आपसे जो भी आगे बॉन्ड खरीद रहा है, अर्थक्वेक से रिलेटेड बॉन्ड, आप उसको वो रिटर्न दे सकते हो, आप उसको इंटरेस्ट पे कर सकते हो, है ना। बट अगर अगर अर्थक्वेक आता है, तो जिसने आपसे बॉन्ड खरीदा है वो लॉस में हो जाएगा। सो इट इज लाइक अ रिस्की सिचुएशन। ये कैटास्ट्रॉफ बॉन्ड्स रिटर्न बहुत हाई देते हैं, है ना। क्योंकि एक तरीके से इसमें जितनी बारी भी किसी के साथ चोरी नहीं हुई, अर्थक्वेक नहीं आया, कुछ नहीं हुआ, उतनी बारी जिसने ये बॉन्ड खरीदा उसको रिटर्न आएगा। बट ये रिस्की भी है कि अगर अर्थक्वेक आ गया, अगर कोई हरिकेन हो गया, इफ समथिंग हैपेंस, then you are in a situation which is where you have to let go of your principal and you have to let go of your interest rate. So catastrophe bonds, they are having some very interesting features. The first interesting feature is that the first and very important interesting feature is that they help spread risk evenly, right? And can be subdivided infinitely, where each investor has small part of the risk. तो एक बारी थोड़ा और लेट्स ट्राई टू अंडरस्टैंड दिस थिंग। देखो, दीज आर द पीपल बेटा जिनको इंश्योरेंस चाहिए था अर्थक्वेक के अगेंस्ट। These people, they want insurance against earthquake, want insurance. Okay. The total money that they have got insured, कि अगर earthquake आता है तो कितना पैसा उन्हें लौटाना पड़ेगा, that is $500. They have purchased insurance from some company. In return, the company has gone ahead and has spread this risk. ये $500 जो हैं, जो कंपनी को इनको देने पड़ सकते हैं, कंपनी ने क्या किया कि इतने अमाउंट के बॉन्ड्स इशू कर दिए मार्केट में। एंड दीज बॉन्ड्स कैन बी ऑफ वेरी वेरी स्मॉल वैल्यू। ये बॉन्ड बहुत ही छोटी छोटी वैल्यू के हो सकते हैं। माने आई कैन इशू 500 बॉन्ड्स ऑफ $1 ईच। एक एक डॉलर के 500 बॉन्ड्स हमने इशू कर दिए। सो आई कैन सब डिवाइड इट, इस वैल्यू को जितना मेरा मन करे मैं उतना सब डिवाइड कर सकती हूँ, उतना छोटे छोटे पार्ट्स में आई कैन जस्ट मेक इट। नाउ देयर इज दिस पर्सन, ही गोज अहेड एंड ही बाइज वन बॉन्ड। उसने एक बॉन्ड खरीदा। सपोज इन दिस ईयर, ईयर 1, देयर इज नो अर्थक्वेक। तो ये कंपनी को, इनको कुछ नहीं देना, द कंपनी हैज टू नॉट पे एनीथिंग टू देम, बट द कंपनी विल गेट प्रीमियम इन रिटर्न। क्योंकि कंपनी ने आगे ये स्प्रेड किया था रिस्क को इन लोगों के अंडर, कंपनी ने ये रिस्क नहीं लिया है लोगों को इंश्योरेंस बेच के, कंपनी हैज स्प्रेड द रिस्क, सो कंपनी हैज टू पे रिटर्न। तो ये जो दिस पर्सन जिसका $1 का बॉन्ड था, he will get back $1 and he will get suppose $0.3 as interest, तो he will get back $1.03, वो उसको वापस मिल जाए। In this way, this company will act as an intermediary. Intermediary between what? Between people who don't want to take risk and between people who want to take risk. और इसके बीच में कुछ प्रॉफिट कंपनी विल कीप फॉर इटसेल्फ। ये जो बॉन्ड्स हैं, these bonds are called as catastrophe bonds. Now suppose year 2, there is earthquake. Now the company has to pay these people money. ठीक है, प्रीमियम तो इन लोगों से हर साल आ रहा है, बट रिटर्न में कुछ पैसा जा भी रहा है। Suppose the money that company has to pay is more than what the company has, तो कंपनी इनको ये वापस नहीं दे पाएगी. It will not be able to pay them back. So year 2 में this person who has purchased $1 of bond, he will get no return. उसका ये $1 भी he will lose. But he is not losing $500. उसको छोटा लॉस ही हो रहा है. The risk that anyone is taking is just small. Right? Is this clear? And whatever money the company is insuring, it is already backed up. उतना पैसा वो इकट्ठा कर चुकी है. So the company will never default. Company हमेशा जब भी आपको कोई नुकसान होगा यहाँ पे इन लोगों को हमेशा पे करेगी. Company will never default. So there is no default risk from the side of company because that money has already been collected by selling bonds. No default risk from the side of companies. From an economist point of view, there is something which is called as cat bonds. एक चीज है जिसे बोलते हैं cat bonds. Cat bonds are a form of state contingent security. State contingent security. ठीक है. State contingent security word read out करो बेटा. State means किस state की बात हो रही है. Earthquake, no earthquake, what form of state है ना. So event. State means event. Contingent security, it means linked to a particular event. So those securities which pay only if a particular event occurs. जैसे अगर earthquake नहीं हुआ तो इनको पैसा वापस मिला, earthquake हुआ तो इनको पैसा नहीं वापस मिला. So those securities means what? Bonds means what? कुछ भी रिटर्न है ना. सो इफ यू आर फ्रॉम अ कॉमर्स बैकग्राउंड यू विल नो एनीथिंग दैट इज फेचिंग यू अ रिटर्न, इट इज अ लायबिलिटी ऑफ द कंपनी, जो कंपनी को पे बैक करना होता है आपको. सो दीज सिक्योरिटीज दे आर कॉल्ड कैट बॉन्ड्स एंड दीज आर स्टेट कंटिंजेंट सिक्योरिटी. माने दीज सिक्योरिटीज दे पे ऑफ if and only if a particular event occurs or does not occur. ठीक है. एक event linked return है. And this concept was first launched by Kenneth J. Arrow. It was published in 1952 in his paper. And he thought when he published it, he thought कि ये सिर्फ एक theoretical concept है. He considered it as a theoretical concept. Right? But later, people actually started using this in the Wall Street and in the exchange market, in the derivative market. So it actually became a practical concept. है ना. असली में हर जगह पे ये यूज होना शुरू हो गया. Right? So this is all about the state contingent securities. Okay, beta. Thank you. हाय गुड आफ्टरनून एवरीवन. बेटा आज हम बात करेंगे अबाउट हाउ यूटिलिटी फंक्शंस कैन बी रिलेटेड टू प्रोबेबिलिटीज. In other words, we are going to talk about something which is called as an expected utility function, right? So we know, अभी तक हमें एक बात समझ में आ गई है that whenever we talk about uncertainty, uncertainty happens because there are events which occur with some probability. There are events which occur with some probability. Okay. But these events, they are mutually exhaustive events. Mutually exhaustive events plus mutually exclusive events. What are mutually exhaustive events? Exhaustive माने जो पूरा sample space खत्म करते हैं, मतलब कुछ बचे ना. हाँ, जैसे if I toss a coin, then either you will get head or tail. तो इन दोनों को मिलाकर कोई तीसरा चीज तो नहीं है. There is no third thing that can happen. It will be either head or tail. So they are exhausting the sample space. They are exhausting the sample space. So we can say that they exhaust sample space. मतलब सब कुछ खत्म करते हैं. Head और tail मिलाकर there is nothing left. That is why they are called mutually exhaustive events. Then you have mutually exclusive events. Exclusive means nothing in common. Like if it is head, then it cannot be tail. There is nothing common. Like if it will rain and not rain, these are two exclusive events. इनमें कुछ भी common नहीं है. या तो बारिश होगी या नहीं होगी. ऐसा नहीं हो सकता कि बारिश है भी और नहीं, right? So they don't have anything in common, right? Then they are exclusive events. Only one of them can happen. इनमें से सिर्फ एक ही चीज हो सकती है. Both cannot happen, right? Now let's say that there are two states better defined. States means like rain and no rain are two separate states, two separate events. So we are saying that there are two states defined. एक state हो गया जब बारिश हो रही है और एक state हो गया जब बारिश नहीं हो रही है. दो अलग चीजें हैं. हाँ? So there are two states defined, state 1 and state 2. And state 1 occurs with probability pi 1 and state 2 occurs with probability pi 2. माने if I do it in terms of rain, no rain, so state 1 supposes rain and state 2 is no rain. हाँ? और rain का probability suppose है 1/4 and no rain का probability है 3/4. So each state has a probability कि कितना % chance है. What's the chance that they will happen? And sum of probability is always 1 beta. So pi 1 plus pi 2 is simply 1. हाँ, या एक है या दूसरा है और दोनों मिलाकर sum of probabilities has to be 1. So sum of the probabilities is 1. In this case, 1/4 plus 3/4 will be 1, right? But a consumption in state 1 is C1 and consumption in state 2 is C2. ये कंजम्पशन है कि अच्छा अगर बारिश हुई तो शायद मुझे थोड़ा नुकसान हो जाएगा. उस दिन मेरी शॉप पे कम लोग आएंगे तो मैं कम पैसा अर्न कर पाऊंगी तो कम कंज्यूम करूंगी. और अगर बारिश नहीं हुई, if there is no rain, then I will be in a benefit. More people will come to my shop. I will have more consumption. So consumption can be related to states बेटा कि क्या event है. हाँ, what event take place? Correspondingly, there is some consumption. And different states can have different consumption. मतलब जो event होगा, suppose it can be lottery also. हाँ, तो lottery में what can be the two states बेटा? State 1 can be that you win the lottery and state 2 can be that you lose the lottery. Now, if you win the lottery, आपके पास अलग पैसा बचेगा and if you lose the lottery, you will have different money. So consumption can be different in different states. अलग-अलग situations में under different situation, consumption can be different. Now we are saying that utility can be represented. Utility is represented in something which is known as expected utility terms. Utility is represented in expected utility terms. Expected utility का क्या मतलब है? What does it mean to have expected utility? Expected utility means utility is given weightage. Utility is given weightage in form of probabilities. With the help of probabilities. Example number 1. But you remember जब हमने perfect substitute goods किया था, when we did perfect substitute goods, so our utility function was AC1 plus BC2. माने हमने या AX plus BY लिखा था हमने. So we had given weightage to two goods. है ना कि किस रेट से हम एक गुड और दूसरे गुड को सब्स्टिट्यूट करेंगे. We had given weightage to the two goods and that weightage was A and B respectively. And this was called as a perfect substitute function, isn't it? Now, we are writing this perfect substitute function for case of uncertainty. So we are saying that your utility function should be a function of consumption in the two period and uska corresponding probabilities kya hai, right? And this will be pi 1 probability of event 1 occurring. और अगर वो इवेंट होता है तो उस पीरियड में कितना कंजम्पशन होगा C1 प्लस पाई 2 प्रोबेबिलिटी ऑफ इवेंट 2 अकरिंग और अगर वो इवेंट होता है तो कितना कंजम्पशन होगा C2. When we write utility function linearly like this, लीनियर है ना, सिर्फ एक प्लस का साइन है, किसी को कोई भी पावर नहीं है, देयर इज नो पावर, यहाँ पे 2 4 8 कोई पावर नहीं है, राइट? इट्स अ लीनियर फंक्शन, पावर इज 1. So when we write utility function linearly, this is a perfect substitute expected utility function. क्यों expected? Because there is presence of the probabilities, right? So here we are saying that this is, जैसे suppose this is probability of rain into consumption when rain plus probability of no rain into consumption when no rain. ठीक है. Similarly बेटा, example number 2. Suppose your utility function is this. C1 to the power pi 1, C2 to the power pi 2. तो बेटा क्या यूटिलिटी फंक्शन लग रहा है ये? हमने ऐसा यूटिलिटी फंक्शन देखा है एंड दिस यूटिलिटी फंक्शन इज Cobb-Douglas utility function. And since weightage is by probabilities, it is expected utility function. है? अच्छा, one more thing here. बेटा you remember कि इसी का we can do a monotonic transformation. कैसे? If my utility function is C1 pi 1 into C2 pi 2, then I can take log on both sides. We can take log on both sides. We have done like this. So log U is equal to log C1 pi 1, C2 pi 2. But a log U, यहाँ रूल लगेगा, log m to the power n is n log m and log m into n is log m plus log n. So if we apply these two rules together, what will we get? Pi 1 log C1 plus pi 2 log C2. Pi 1 log C1 plus pi 2 log C2. Power comes down and ये multiplication है, so this will convert into addition. Right? So this form of utility function also represents the same. ये और ये same ही है. तो ये क्या हो गया? This is probability of event 1 into log of consumption during event 1, probability of event 2 into log of consumption during event 2. During event 2. Is this clear, beta? Okay, so this is how we can write the utility function in different cases. Okay. Acha, now one more thing I have here. Question for you. Homework question. Try to think this. So, which of the following utility functions have expected utility property? Okay. A. U of C1, C2, pi 1, pi 2 is A, pi 1, C1 plus pi 2, C2. B. U of C1, C2, pi 1, pi 2 is pi 1, C1 plus pi 2, C2 square. C. U of C1, C2, pi 1, pi 2 is pi 1 ln C1 plus pi 2 ln C2 plus 70. Try to do this question yourself, then we will discuss it in the next class. Okay, thank you. Hi, good afternoon everyone. But today we are going to learn more about expected utility function, and then I will be taking this question which I had given as a homework question, right? So we will take this question in some time. Let's learn more about expected utility function. Expected utility function. Okay. Now, when we talk about expected utility function, one thing that we learned is that in case of expected utility function, we always have utility which is probabilistic, जहां पे probability का कोई role है, right? We have utility which is probabilistic, right? One particular form of expected utility function जो हमने देखा था last class में, it was this. U of consumption in 2 period, it's also a function of probability attached to the two state. इसको हमने ऐसे लिखा था, probability in period 1 into utility from period 1, probability in period 2 into utility from period 2. अब देखो यहाँ पे, when it was a perfect substitute case, if we consider utility function to be a perfect substitute case, so it will become pi 1 यूटिलिटी फ्रॉम कंजम्पशन इन पीरियड C1 इज जस्ट C1 क्योंकि सब्स्टिट्यूट तरीके से देख रहे थे, प्लस पाई टू यूटिलिटी फ्रॉम कंजम्पशन इन पीरियड 2. यहां पर व्हेन वी हैव इट लाइक दिस बेटा, हाँ, so our utility function that we had written, it was pi1 log C1 plus pi2 log C2. ऐसे लिखा था utility function. So it can be pi1 utility from consumption in period 1 plus pi2 utility from consumption in period 2. तो जो जनरल फॉर्म हो गया एक्सपेक्टेड यूटिलिटी फंक्शन का, द जनरल फॉर्म ऑफ एक्सपेक्टेड यूटिलिटी फंक्शन कैन बी लाइक दिस, pi1 utility from consumption in period 1. This utility function can be any utility function. Utility function can take different forms. यूटिलिटी फंक्शन, ये जो यूटिलिटी फंक्शन है ये अलग अलग फॉर्म ले सकता है. सो दिस यूटिलिटी फंक्शन इट कैन टेक डिफरेंट फॉर्म, राइट? सो फॉर एग्जाम्पल बेटा आई कैन से दैट योर यूटिलिटी फंक्शन इज जस्ट सी कंजम्पशन इन दैट पीरियड. यूटिलिटी फंक्शन इज जस्ट सी. तो यूटिलिटी फ्रॉम C1 कंजम्पशन हो जाएगा C1, यूटिलिटी फ्रॉम C2 कंजम्पशन हो जाएगा C2, and expected utility function will become pi1 C1 plus pi2 C2. pi1 C1 plus pi2 C2, where pi1 is probability of that event 1 into utility from consumption in period 1. Pi2 is probability of period 2 into utility from consumption in period. Now if this same utility function is LNC, suppose अब utility function आपको दिया हुआ है, you are given that the utility function is LNC. So what is your expected utility beta? pi1 utility in period 1 plus pi2 utility in period, है ना? तो period 1 का utility क्या होगा? If C will be replaced with C1, so this will be pi1 into ln C1 plus pi2 into ln C2. This will be your expected utility. So this expected utility can take different forms. इसका अलग अलग तरीका हो सकता है. It can take different forms depending on what the base utility function is. कि ये background में utility function क्या है. But this is the general form. ये एक general form है expected utility function का. ये एक पर्टिकुलर फॉर्म है क्योंकि इसमें हमने एक यूटिलिटी का पर्टिकुलर फॉर्म लिया है. सो दिस इज अ पर्टिकुलर फॉर्म. So this is a general form of expected utility function and this is a particular form of expected utility function. This expected utility function, but this is also the expected utility function this is also called as von Neumann Morgenstern utility function. Von Neumann Morgenstern utility function क्योंकि these people had developed this utility function. सबसे पहले इन्होंने ही इस utility function के बारे में बात किया था. Their history is very intriguing. अगर आप कभी जानना चाहो, if you ever want to read about von Neumann Morgenstern, you will realize that it is a very interesting way in which they derived this utility function. They were not even economist. वो इको के बैकग्राउंड से भी नहीं थे जब उन्होंने ये एक्सपेक्टेड यूटिलिटी फंक्शन डिराइव किया, राइट? बट you just have to remember that the expected utility function is also called as VNM utility function. VNM utility function, right? Now, just like we have done for the usual utility function, we can go ahead and we can talk about positive affine transformation. We can talk about positive affine transformation. पॉजिटिव अफाइन ट्रांसफॉर्मेशन क्या बोलता है कि हम यूटिलिटी फंक्शन को किसी भी नंबर से मल्टीप्लाई या ऐड कर सकते हैं एंड द न्यू यूटिलिटी फंक्शन विल हैव द सेम प्रॉपर्टीज एज द ओल्ड यूटिलिटी फंक्शन. माने सपोज आई हैव डिराइव्ड दिस यूटिलिटी फंक्शन. दिस इज माय एक्सपेक्टेड यूटिलिटी फंक्शन. एक्सपेक्टेड यूटिलिटी को कभी कभी ई ऑफ यू भी लिखते हैं. सो दिस इज माय एक्सपेक्टेड यूटिलिटी फंक्शन. Now, this expected utility function, if I multiply it with some number or I add some number to it, तो हमें जो नया utility function मिलेगा, it will have the same properties as original expected utility function. It will have the same properties as original expected utility function. This thing, when you go ahead and you do it like this, जब आप एक transformation करते हो, how can we transform? What is positive affine transformation? Positive affine transformation is when you add something or multiply something or do both. दोनों भी कर सकते हो. A should be positive. You're multiplying with a positive number. Then this is called as पॉजिटिव एफाइन ट्रांसफॉर्मेशन. ठीक है. पॉजिटिव एफाइन ट्रांसफॉर्मेशन जब तक आप कर रहे हो तब तक आपका एक्सपेक्टेड यूटिलिटी का जो प्रॉपर्टीज है दैट विल रिमेन अनचेंज्ड. योर एक्सपेक्टेड यूटिलिटी प्रॉपर्टीज विल रिमेन अनचेंज्ड. इज दिस क्लियर बेटा? क्लियर? ओके. नाउ ऑन द बेसिस ऑफ दिस कैन वी गो अहेड एंड कैन वी टेक द क्वेश्चन विच आई हैड गिवन यू द लास्ट टाइम. ठीक है. दिस इज अ क्वेश्चन फ्रॉम वेरियन बैक क्वेश्चंस, बैक एक्सरसाइज. लेट अस ट्राई टू रीड दिस क्वेश्चन. तो क्या कह रहे हैं? विच ऑफ द फॉलोइंग यूटिलिटी फंक्शन हैव एक्सपेक्टेड यूटिलिटी फंक्शन प्रॉपर्टीज? लुक एट द फर्स्ट वन बेटा. ये तो हमारा एक जनरल एक्सपेक्टेड यूटिलिटी फंक्शन है, isn't it? Because this is nothing but probability into utility from consumption in period 1. In this case, it must be the case कि हमारा जो utility function रहा होगा वो सीधा C रहा होगा. So utility in period 1 would have been C1. Utility in period 2 would have been C2. So our expected utility function would have been pi1 C1 plus pi2 C2. Probability into utility, probability into utility. Clear? Acha. Now, if I multiply it with a number, then also it is okay. It is just positive affine transformation. किसी एक नंबर से मल्टीप्लाई करके यूटिलिटी फंक्शन को कोई फर्क नहीं पड़ेगा, बट देयर शुड बी अ कंडीशन दैट आई कैन ओनली मल्टीप्लाई इट विद अ पॉजिटिव नंबर. देयर इज अ कंडीशन दैट आई कैन ओनली मल्टीप्लाई इट विद अ पॉजिटिव number. So I need that this a should be greater than 0. ये a negative नहीं हो सकता है. This a should be greater than 0. So answer will be yes. This is expected utility function only when a is greater than 0. Only when a is greater than 0. Clear? ठीक है बेटा. Come to the second question now. अब देखो, here there is a problem. Here there is a problem. What is the problem? That my utility function is not the same. ये देखो, यहाँ पे C1 है और यहाँ पे C2 square है. So what is my utility function? अगर मेरा utility function C होता, if my utility function would have been C, तो period 1 का utility आता C1 and period 2. Period means event. Event means जैसे 1 can represent that I win the lottery and 2 can represent that I lose the lottery. है ना? Then it can represent that 1 is representing rain and 2 is representing no rain. हाँ, तो period 1 means कोई एक event. By 1 I mean it is an event. ठीक है, event can be rain, event 2 can be no rain. So this is utility from event 1 and utility from event 2 हो जाता बेटा C2. So in this case my expected utility function would have been this. Or in other case, if my utility function would have been C square, suppose utility function C square hai, then utility in period 1 or event 1 would have been C1 square and utility in event 2 would have been C2 square and expected utility function would have been pi 1 C1 square plus pi 2 C2 square. So either this is possible or this is possible. But this is not possible. This is representing different things. So this is not the correct expected utility function. It is not the correct expected utility function. Clear? Clear? Okay. Okay, now look at the third one, beta. So third one, there is no issue. If you look here, if my utility function is ln c, so event 1 will have utility as ln c1, event 2 में हो जाएगा utility ln c2. So my expected utility function will be probability, utility from event 1, probability of event 2, utility from event 2. And we have studied that there is something called as positive affine transformation. Positive affine transformation, means we can multiply it to any positive number and we can add any number here, any positive number here. So in this case, if I multiply with it 1 and I add 17, so positive affine transformation will be what, beta? It will be pi 1 ln c1 plus pi 2 ln c2 plus 17. Pi 1 ln c1 plus pi 2 ln c2 plus 17. So this expected utility function has no problem to it. ये एकदम ठीक है, इसमें कोई दिक्कत नहीं है. It is just positive affine transformation of this. इसका positive affine transformation है, which is fine. We can work with that. So yes, this has properties. It has properties of expected utility function. Right? Is this clear? Okay. So with this, we complete the topic of expected utility. Now we will go ahead and continue the chapter in the next class. Thank you. Everyone. So today, let us go ahead and let us ask very important question. Why expected utility is reasonable? Why should we talk about expected utility? Right? Okay. Now just try to understand this thing. See, expected utility का मतलब क्या है? Expected utility means that we have some outcomes and these outcomes are uncertain. That means that there is presence of probability. And since there is presence of probability, so we are finding expected utility, which is occurrence of event 1 into utility from event 1, occurrence of event 2, probability of occurrence of event 2 into utility from event 2, right? So basically what is happening is that one second. So basically what is happening is that we have these events which are taking place randomly. Kabhi, it can be, suppose event 1 can represent good state. Event 2 can represent bad state. So we can be in any state. We can either be in good state और वी कैन बी इन बैड स्टेट, दोनों में से हम किसी भी एक स्टेट में हो सकते हैं, इजंट इट? अच्छा, नाउ ट्राई टू अंडरस्टैंड दिस थिंग, बट अल्टीमेटली ओनली वन ऑफ देम विल अकर। जैसे अगर मैं आपको बोल दूं दैट देयर इज अ प्रोबेबिलिटी 50% चांस दैट इट विल रेन, ठीक है, इफ इट रेन्स माई कंजम्पशन इज C1, probability 50% chance that it will not rain. If it doesn't rain, then my consumption is C2. But ultimately only one of the outcome is going to occur. या तो रेन करेगा या नहीं करेगा, दोनों चीजें तो नहीं हो सकती. So there is a 50% chance that it will rain. 50% chance है कि बारिश होगी. There is a 50% chance it will not rain. But one of these two things can happen ना. Either it will rain or not rain. दोनों तो नहीं हो जाएंगे, right? Only one of them will happen, right? So therefore what is happening is that we are saying now that only one of the two things will go ahead and happen, right? Not both of them, right? So we can say that we will write out a line, beta usko समझो पहले, only one of the contingent consumption plans will actually be realized. Only one of the contingent plans will actually be realized. कोई एक चीज ही होगी, या बारिश या no rain, either rain or no rain. One of the two contingent plans means, why is it contingent, beta? It is contingent because there is presence of uncertainty, है ना? और उनमें से कोई एक चीज ही होगी दोनों में से, only one of them will be realized. Now this has very interesting implications. इसकी बहुत अच्छी सी implications हो जाती हैं. So let us consider that example 2. Let us consider that you are considering purchasing fire insurance for your house. आपको अपने घर के लिए एक फायर इंश्योरेंस खरीदना है, ठीक है? Now there are three situations, ठीक है? Your current wealth, that wealth is C naught, ठीक है? If house burns, अगर आपका घर जल जाता है, your wealth becomes C1, and if it doesn't, अगर वो नहीं जलता, then your wealth will be C2, right? Now there is probability pi1 that the house will burn and probability pi2 that it will not burn, ठीक है? तो अब एक बात बताओ, होगी तो एक ही चीज, या तो जलेगा या नहीं जलेगा. Both things cannot happen, right? Only one of them can happen, not both of them, right? So but there is a trade-off, right? What is the trade-off? Trade-off is between the wealth now and one of the possible outcomes. इनके बीच में एक ट्रेड ऑफ है. माने मेरा वेल्थ अभी C0 है और बाद में मेरा वेल्थ या तो C1 हो सकता है या तो C2 हो सकता है विद प्रोबेबिलिटी pi1 एंड pi2. बट इनमें एक ट्रेड ऑफ है. देयर इज अ ट्रेड ऑफ बिटवीन द टू, राइट? व्हाट इज द ट्रेड ऑफ? द ट्रेड ऑफ इज हाउ मच मनी you are willing to sacrifice now to get little more money if the house burns. माने अगर मैं आपसे पूछूं एज एन इंश्योरेंस कंपनी कि अभी आप कितना पैसा देने के लिए तैयार हो, अभी आप कितनी अपनी वेल्थ कम करने के लिए तैयार हो, what is the money you are willing to give up so that if there is a fire, ठीक है, then you will get some money from the company and it will increase your consumption in that period. तो एक ट्रेड ऑफ हो गया ना, कि जब आप अभी पैसा दोगे इंश्योरेंस कंपनी को, तो फ्यूचर में अगर ये होता है, इफ देयर इज अ फायर, देन यू विल बी गेटिंग सम मनी फ्रॉम द कंपनी, राइट? इज इट क्लियर? सो नाउ दिस डिसीजन दैट यू हैव टू मेक, कि ठीक है अभी मैं कुछ पैसा दे देती हूँ, कम से कम अगर 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 आग लगी तो मेरे पास कितना पैसा और आ जाएगा कंपनी से, दिस डिसीजन शुड बी इंडिपेंडेंट ऑफ हाउ मच कंजम्पशन यू हैव इन द अदर पॉसिबल आउटकम। माने अगर आग नहीं ही लगती तो कुछ नहीं है, उस वो एक अलग चीज हो गई, इट इज इंडिपेंडेंट। बट इफ इट इज देर इज अ फायर एंड माई कंजम्पशन इज लोअर्ड, है ना, इफ देर इज फायर एंड माई कंजम्पशन इज लोअर्ड, देन आई कैन इंक्रीज दिस कंजम्पशन बाय टेकिंग इंश्योरेंस एंड पेइंग सम मनी नाउ। इज इट मेकिंग सेंस? सो प्लीज राइट इट विद मी बेटा। देर इज a trade-off between wealth now and one of the possible outcomes. इसके बीच में wealth now and possible outcome, एक possible outcome, one of the possible outcome के बीच में एक trade off है, right? That is how much money consumer is willing to sacrifice now to get a little more money if the house burns down. तो मैं कुछ पैसा अभी देना चाहूंगी to the company so that I get some money if the house burns down, right? So there is a trade-off between how much money I want to sacrifice today, कितना पैसा मैं आज देना चाहूंगी ताकि मुझे फ्यूचर में मिल पाए, right? That's the trade-off you have. How much money you are willing to give today to get more tomorrow, right? But this decision is independent, not is, right? Don't should be. Should be independent of how much consumption you will have in the other state of nature. That is how much wealth you will have if house is not destroyed. तो ये जो चीज है कि मैं आज कितना दूंगी ताकि मुझे फ्यूचर में जब घर बर्न हो कितना मिले, how much I get if the house is burned, it should be independent of this scenario when the house doesn't burn, right? It should be independent of this scenario. Is this making some sense? Right? So if it happens to burn down, okay, the extra wealth you are getting shouldn't depend on how much wealth you have if it didn't burn down. माने इससे कुछ फर्क नहीं पड़ना चाहिए मुझे, मेरा ये डिसीजन कि मैं आज कितना दे रही हूं ताकि मुझे जब आग लगे कितना मिले, it should not be affected by my wealth under this scenario. How much I get if there is no fire, it should not be affected by that scenario. Is this clear? Okay. Note, however, that this is an assumption about individuals' preferences. And this is, please write down, assumption about individuals' preferences and it may be violated. ये violate हो सकती है, right? It can be violated, right? So for example, let's try to write an example here, huh? कभी-कभी, suppose I ask you कि whether you want to have tea or coffee. Now, it should not depend on any third thing, but it does. Sometimes, whether people want to have tea or coffee, it depends on the amount of cream that the people have. क्योंकि कॉफी में ज्यादा क्रीम चाहिए होता है और चाय में कम क्रीम चाहिए होता है ना? तो अगर ज्यादा क्रीम है तब लोग कॉफी लेना चाहेंगे और अगर कम क्रीम है तब लोग टी लेना चाहेंगे, राइट? सो द अमाउंट ऑफ क्रीम दैट यू माइट गेट शुडंट, हम तो ये बोल रहे हैं एक तरीके से यहाँ पे कि क्रीम शुड नॉट अफेक्ट द डिसीजन बिटवीन कॉफी एंड टी, बट वो अफेक्ट कर रहा है ना कि आप क्या चूज कर रहे हो. Similarly, here we are saying how much wealth you are willing to give today should not affect on how much wealth you have when there is no fire. पर कभी कभी वो affect करता है. Sometimes it goes ahead and it affects. So this independent assumption that we have made, right? Sometimes this independent assumption is in fact violated. कभी कभी ये independent assumption violate हो जाती है. आई होप दिस इज मेकिंग सम इंट्यूटिव सेंस, कुछ सेंस बन रहा है. हाँ, तो हम कह रहे हैं कि सपोज जो आज के दिन में मेरे पास 100 रुपए है, अगर फायर हो जाता है आई एम लेफ्ट अप विद 10 रुपीज, अगर फायर नहीं होता है तो आई एम लेफ्ट अप विद 100 रुपीज एज इट इज. अब मैं आज कितने रुपए दूं अपने आप को प्रोटेक्ट करने के लिए फायर के अगेंस्ट, ये इस पे डिपेंड करना चाहिए कि जब फायर लगता है मेरे पास कितना वेल्थ है. ये इस पे डिपेंड नहीं करना चाहिए कि जब फायर नहीं लग रहा तो मेरे पास कितना वेल्थ है. इससे कोई फर्क नहीं पड़ना चाहिए डिसीजन पे. बट वी आर सेइंग दिस इज द इंडिपेंडेंट एजम्पशन, but we are saying that this independent assumption can sometimes be violated. Is this making some sense, beta? ठीक है, please write down the independent assumption. Independence assumption. Right? Independence assumption. So please write down the independence assumption. States that the choices that people plan to make in one state of nature should be independent from the choices that they make in another state of nature. समझे बेटा? तो what choice I am making with one state of nature, कि मैं कितना पैसा देना चाहूंगी अपने आप को फायर के अगेंस्ट प्रोटेक्ट करने के लिए, उससे इट शुड नॉट बी अफेक्टेड विद हाउ मच मनी आई हैव व्हेन देयर इज नो फायर. ठीक है, तो दिस इज वेरी इंपॉर्टेंट. सो बिकॉज ऑफ दिस assumption, what we therefore get, so because of this assumption we get a very special form of utility function. हमें एक बहुत ही अलग तरीके का utility function मिलता है, and that utility function is called as additive utility function. अब एक additive utility function का ये प्रॉपर्टी है that any two goods are not dependent on each other, they are independent of each other. ठीक है, जैसे फॉर एग्जाम्पल if I say utility from good x and y is equal to utility from x plus utility from y, माने there is no dependence. x का utility और y का utility add करो तो x और y का together utility आ गया. But x is not dependent on y and y is not dependent on x. I am just adding separate utility from x and y. So this is the independence assumption. Similarly, if I want to apply this concept here, so what kind of utility function I can get? Utility from period 1 consumption, utility from period 2 consumption, utility from period 3 consumption by, and I'm giving them some weightage. I'm giving them some weightage. जैसे यहाँ पे मैं I can give it some weightage, alpha and beta. तो I'm giving it some weightage. और ये weightage यहाँ पे क्या हो जाएगा? Probability. So this becomes nothing but your, यही तो expected utility function था. This is nothing but expected utility function. So expected utility function indeed is a utility function which satisfies independent. It satisfies independent assumption. Expected utility function, indeed it satisfies beta the independence assumption. वो इस assumption को satisfy करता है. Okay, now what we can do is, let's find out beta MRS between good 1 and 2. MRS between good 1 and 2. तो MRS क्या होता है? How utility changes when good 1 changes, है ना? Upon how utility changes when good 2 changes. So when you will differentiate with respect to C1, so C1 is only coming here, you will get pi 1 u dash C1. And when you will differentiate with respect to C2, so beta C2 is only coming here, so pi 2 u dash C2. तो यहाँ पे C3 कहीं नहीं आ रहा. Nowhere C3 is coming. So independence assumption also means that MRS between consumption of 2 period is independent of consumption of the 3rd period. तो अगर MRS of good 1 2 good 3 के कोई नंबर को यूज नहीं कर, it's not having C3 anywhere, so we can say that it is independent in nature. We can say that it is independent in nature. Is this clear, beta? Okay, so we will stop here now, beta. This is a very important assumption and you need to go ahead and you need to revise this assumption well. Okay, thank you.
Hi, good evening, everyone. So, beta, today we will be going ahead and talking about risk aversion. ठीक है? In this chapter, ये टॉपिक बहुत ही ज्यादा इम्पोर्टेंट है कि अलग अलग तरीके के कंज्यूमर्स कैसे होते हैं. What are the different kind of consumers that we have? To understand this, let's begin with a basic example. तो example एक ले लेते हैं. But we are saying that there is a consumer, right? And the wealth of consumer is $10. Okay. And consumer is playing a gamble. Okay. Consumer एक gamble खेल रहा है. और 50% chance है, there is a 50% chance that he will go ahead and he will win the gamble. वो जीत जाएगा. So he will win $5. And there is a 50% chance that he will lose $5. तो बेटा 50% चांस है कि he will win $5. So if he wins $5, so $10 plus $5 will give him $15. And 50% chance है कि he will lose $5. So $10 minus $5 बच्चे, that will just give you 10 minus 5, $5. ठीक है. So there is a 50% chance that he will have $15 and 50% chance that he will have just $5, right? But if I ask you what is going to be the expected utility of the consumer, expected utility कैसे दिखते हैं? Probability of winning 50%, 50% माने half, into utility from $15, क्योंकि अगर वो जीतता है तो उसके पास he will have $15, plus probability of losing, that means again half, into utility from this amount. If he loses, he has only $5. So this will become his expected utility function, right? Let us try to go ahead and let us try to plot this expected utility function. हमें इसको plot करना है. In order to plot the expected utility function, but we need something which is known as the nature of the consumer. हमें क्या चाहिए? We need to know the nature of consumer. ठीक है बच्चे? इसी में the first kind of consumers that we have, that is called as risk averse individuals. उनको बोला जाता है risk averse individuals. Who are risk averse individuals? Those individuals who prefer a certain or a fixed amount over the same lottery amount or the expected amount. तो वो लोग जो फिक्स्ड अमाउंट प्रेफर करते हैं, who prefer fixed amount over the lottery amount, over the expected amount, they are called as risk averse individual. माने मैं आपको बोलूं कि देखो एक सिनेरियो है where you have $10 fixed and एक सिनेरियो है जहां पे 50% चांस है that you will have $15 और 50% चांस है that you will have $5. 50% चांस है कि 15 होंगे और 50% चांस है that it will become $5. तो बेटा इसका एक्सपेक्टेड वैल्यू भी 10 ही आएगा. The expected value from both are same, है ना? यहां पे लॉटरी अगर खेलोगे, if you play the lottery, sometimes you will win, तो 15 हो जाएगा, 10 की जगह 15 मिलेगा. Sometimes you will lose, so instead of 10 you will get 5. So on an average आपको यहाँ पे भी 10 ही मिलेगा, कभी 15, कभी 5, कभी 15, कभी 5. On an average you are getting 10 here. And if you don't play the lottery, then also you are getting 10 beta. So the amount is the same, but this individual, ये जो risk averse individual है, he prefers this scenario. उसे ये वाला सिनेरियो ज्यादा पसंद है जहां पे ये अनसर्टेनिटी ना हो. He prefers this scenario. So he gives more utility from certain 10 over. यहां से यूटिलिटी क्या निकलता है बेटा? Whenever you play lottery, we have expected utility. And expected utility को हमने पहले ही लिख लिया था. This is my expected utility function. Right? With probability half, I will get utility from 15. With probability half, I will get utility from 5. So those individuals who prefer the fixed amount over the expected amount, है ना? दोनों ही केस में ऑन एन एवरेज ही विल हैव $10 ओनली, but he is a डरपोक kind of individual. He's an individual who is very scared. He does not want to take risk. उसको नहीं रिस्क लेना, उसको नहीं लॉटरी खेलना, है ना? तो his utility from $10, but ये $10 सर्टेनिटी से आ रहे हैं, that is more than his expected utility. जब वो लॉटरी खेलता है तो उससे कितना यूटिलिटी मिलता है? Such kind of individuals, they are called as risk averse individuals. उनको हम risk averse individual बोल देते हैं. Now, for such kind of individuals, we can go ahead and make indifference curve, बच्चे. And the indifference curve looks like this. Not indifference curve, actually utility function. वो ऐसा दिखता है. So I can take wealth here. I can take utility here. ध्यान से देखना, हाँ. ये है $5. ये है $10. जब हम $10 को यूटिलिटी फंक्शन पे लेके जाते हैं तो यहां से हमें यूटिलिटी मिलता है $10 का. यहां से हमें यूटिलिटी मिलता है $10 का. ऐसे यहां से हमें यूटिलिटी मिलता है $5 का. सिमिलरली दिस इज $15. When I take 15 to the utility function, I get utility from $15. माने this. Utility from $15. अब राइट हैंड साइड देखो बच्चे, व्हाट इज राइट हैंड साइड? हाफ यूटिलिटी ऑफ 15 प्लस हाफ यूटिलिटी ऑफ 5. माने हमें इसको हाफ से मल्टीप्लाई करना है एंड इसको हाफ से, एंड वी नीड टू ऐड देम टुगेदर. ग्राफिकली अगर हमें इस चीज को दिखाना है, इट मींस वी आर गिविंग हाफ वेटेज टू दिस एंड हाफ वेटेज टू दिस. टू शो दिस व्हाट वी डू इज वी ड्रॉ अ लाइन फ्रॉम 5 to 15. But what will be average of 5 and 15? Half 5 plus half 15 माने 10. तो लॉटरी भी ऑन एन एवरेज 10 ही दे रहा है. और ये जो हमारा पॉइंट होगा ऑन द लाइन, है ना, दिस पॉइंट विल बी वेयर यू हैव एग्जैक्टली हाफ ऑफ 15 एंड हाफ यूटिलिटी ऑफ 5. ये पॉइंट कॉरेस्पॉन्डिंग टू यही. अब ध्यान से देखो व्हाट वी आर सेइंग, लिसन वेरी केयरफुली, दिस इज वेरी ट्रिकी एंड वेरी इंपॉर्टेंट. देखो विद एंड विदाउट लॉटरी दोनों में ही ऑन एन एवरेज यू हैव 10. यहां पे जब लॉटरी नहीं खेल रहे तो ₹10 के साथ स्टार्ट किया था. यू हैड स्टार्टेड विद $10, यू हैव दोस $10. So if you're not playing lottery, you started with $10 and you have $10 intact. But if you play lottery, sometimes you will have 5, sometimes you will have 15. आधे टाइम 15 मिलेंगे, आधे टाइम 5 मिलेंगे. But on average, you will have 10 here also. So 10 here and 10 here. तो बेटा both are 10. With or without lottery, on an average पैसा जो आ रहा है वो $10 है. But this ये वाला जो पॉइंट है जो यूटिलिटी फंक्शन पर है, यूटिलिटी ऑफ वेल्थ पर है, ये पॉइंट बेटा दिस इज रिप्रेजेंटिंग यूटिलिटी फ्रॉम $10. माने अगर $10 मेरे को सर्टेनिटी से मिले, माने मैं लॉटरी नहीं खेल रही हूं, आई एम नॉट प्लेइंग लॉटरी, दिस इज यूटिलिटी फ्रॉम $10 एंड दिस इज रिप्रेजेंटिंग एक्सपेक्टेड यूटिलिटी. माने आई एम प्लेइंग लॉटरी क्योंकि ये एक्सपेक्टेड है. Expected is always when uncertainty is involved, when lottery is involved. So in this case बच्चे, in this case क्या कह रहे हैं हम, what are we saying? That utility from certain 10, ये देखो ये ऊपर आ रहा है ना amount, it is more than half of utility from 15 plus half of utility from 5. माने utility from certain amount is greater than expected utility. Is this making sense? Is greater than expected utility. So बच्चे this is the nature of risk averse individual. इसी को हम रिस्क एवर्स इंडिविजुअल बोल देते हैं. दिस इज कॉल्ड एज रिस्क एवर्स इंडिविजुअल. इज दिस क्लियर? ओके, ठीक है. दिस इज द फर्स्ट काइंड ऑफ इंडिविजुअल. ठीक है. ओके बेटा, थैंक यू. Hi, good afternoon, everyone. Beta, in the last class, we had started talking about the risk aversion, the type of individual who is a risk averse individual. है ना? बेटा आज हम देखेंगे other two kind of individual. The first kind of individual is called as a risk lover individual. And the second kind of individual is called as a risk neutral individual. So risk averse individual was who? Risk averse individual was that kind of individual who was getting more utility from a certain amount than the expected utility. माने उसको risk नहीं लेना था. Just the opposite of this is my risk lover individual. A risk lover individual is that individual whose utility from the certain amount is less than his expected utility. Is less than his expected utility. माने क्या हो रहा है इस केस में बच्चे कि suppose without lottery one individual has $100 and with lottery 50% of the time he has $150 and 50% of the time he has $50. तो ऑन एन एवरेज यहां पे भी ही हैज $100. तो जो रिस्क लवर इंडिविजुअल होगा, द रिस्क लवर इंडिविजुअल, ही विल want to take risk. He wants to take risk. The risk lover individual, he wants to take risk. माने his utility from lottery, जब लॉटरी के साथ यूटिलिटी होता है तो उसको एक्सपेक्टेड यूटिलिटी बोलते हैं. His expected utility will be more than his utility from no lottery amount. That means the certain amount. From as compared to the no lottery amount, that means the certain amount. ठीक है बेटा. अच्छा, now in this case what happens is that if we talk about the utility function, अगर हम यहाँ पे यूटिलिटी फंक्शन को प्लॉट करें, इफ वी टॉक अबाउट प्लॉटिंग द यूटिलिटी फंक्शन, देन द यूटिलिटी फंक्शन लुक्स लाइक दिस बच्चे. Just the opposite of this. ठीक है. So what will happen? ये रहा $50, ये $50 से यूटिलिटी है, ये रहा $150. This is the utility from $150. हाँ बच्चे, this is $100. This is utility from $100. और expected utility के लिए what you will do? Join these two and take it to 100. क्योंकि amount तो यहाँ पे भी on an average it is 100 only, but it is average of, so with probability half utility from 50 मिलेगा and with probability half utility from 150. This is your expected utility. है ना? So that will come down to this amount बेटा. This is expected utility. And यहाँ पर जो हमारा expected utility है, देखो, it is more than utility from certain amount. Clear? ठीक है. Okay बेटा, third kind of individual, risk neutral individual. Risk neutral individual.
रिस्क न्यूट्रल इंडिविजुअल आर दोज काइंड ऑफ इंडिविजुअल जो दोनों के बीच में इंडिफरेंट है, माने वो लॉटरी खेले या ना खेले, वेदर दे प्ले और डोंट प्ले लॉटरी, दे आर इंडिफरेंट बिटवीन द टू. सो यूटिलिटी फ्रॉम लॉटरी एंड नो लॉटरी इज द सेम. माने एक्सपेक्टेड यूटिलिटी, जब लॉटरी खेलते हो तो हमेशा एक्सपेक्टेशन के टर्म्स में आता है, प्रोबेबिलिटी टर्म्स में, शुड बी इक्वल टू यूटिलिटी फ्रॉम सर्टेन अमाउंट. तो बेटा अगर मैं इफ आई टेक द सेम एग्जांपल, सपोज देयर इज विदाउट लॉटरी, ये इंडिविजुअल के पास $100 है, एंड विद लॉटरी, with probability half, individual has $150, and with probability half, individual has $50. Okay. So now what we are saying is that both should give the same value. Money, utility from this 100 and expected utility, both should be same. Utility from 100 and expected utility, both should be same. So when this happens, जब ये होगा, then you will have risk neutral individual. ठीक है? But for a risk neutral individual, the utility function looks like this. Straight line. ठीक है? This is 50. But a utility from 50. 100. Utility from 100. 150. Utility from 150. है ना? अच्छा, now what we are saying कि if we expected कैसे निकाल रहे थे, we were joining a line from these two and passing through 100, तो वो भी same ही आएगा if I join a line through these 2 points. So this is also my expected utility. यही point. So both of these are exactly the same. Both of these are exactly the same. Is this clear, बच्चे? So these are the 3 kind of individuals that we have: risk averse, risk lover, and risk neutral individual. Okay, beta. Hi, good evening, everyone. Beta, let us today talk about diversification. Diversification money, there is a very famous quote that you don't put all your eggs in one basket. मतलब आप एक ही जगह पे इन्वेस्ट नहीं करते हो. You don't put all your eggs in one basket. You diversify. माने suppose I give you 5,000 rupees. ठीक है? And I ask you, beta, I want you to invest this money. ठीक है? Put this money somewhere. Will you buy shares of only one stock? नहीं ना. What you will do? You will buy share of stock A, stock B, stock C. माने you will be buying shares of different stocks. That is called as diversification. ठीक है? तो जैसे अगर मैं आपको बोल दूं कि अगले साल चांसेस हैं कि either it will rain or it will be sunny, 50-50% चांस है, तो what will you do? Will you only buy raincoat? No. Will you only buy sunglasses? No. You will buy some money on sunglass and some money on raincoat. माने you will diversify. है ना? So diversification का मतलब क्या होता है? That you will not put all your money in one basket. You will go ahead and you will spread out your money. आप अपने पैसे को divide and conquer करोगे. Right? So take an example, बेटा. Suppose you have $100 with you. ठीक है?
there is 50% chance that it will be rainy. There is 50% chance that it will be sunny. है ना, 50-50% चांस है रेन होने का और सनी होने का, राइट? नाउ वी ऑल्सो नो दैट देर आर टू कंपनीज. ठीक है, कंपनी वन is the company which makes raincoats. Company 2 is the company which makes sunglasses. ठीक है, make raincoat, make sunglasses. Now, if it is rainy season, ठीक है, तो कंपनी 1 जो हमारा ये रेनकोट बना रहा है उसका एक शेयर है for $10, which in rainy season will become $20. In rainy season it will become $20. ठीक है, और in sunny season it will become $5. माने the company is selling its share for $10. अगर रेनी सीजन हुआ तो वो डबल हो जाएगा, अगर सनी सीजन हुआ तो इट विल बिकम हाफ. Similarly, the company that is making sunglasses, it is also selling its share for $10. In rainy season, its value will go to $5. And in sunny season, its value will go to $20. It will double. ठीक है बेटा? Now, the question is that what happens? What happens if you go ahead and you put all your money in company 1? You put all your money in company 1. माने ये कंपनी, ये जितना आपके पास ये $100 है आपने कंपनी 1 में इन्वेस्ट कर दिया. So with 50% chance it will be rainy. अगर रेनी हुआ तो मनी विल डबल. With 50% chance it will be sunny, money will half. तो माने with 50% chance it will become 200, and with 50% chance it will become 50. माने on an average you will have $125. But what happens if I will put all my money in company 2? Put all my money in company 2. तो अगर मैं सारा पैसा कंपनी 2 में लगाती हूँ, if I put all my money in company 2, फिर से either my money will half or double. So with 50% chance my money will double. With 50% chance it will become half. On an average मेरे पास $125 होगा. I will have $125 with me. ठीक. Now, what happens if I go ahead and I diversify? ठीक. If the person diversifies, माने वो पर्सन क्या कर रहा है ना, कि वो पर्सन के पास जो $100 है उसने $50 कंपनी 1 में लगा दिया और $50 कंपनी 2 में लगा दिया, है ना? $50 कंपनी 1 में लगा दिया एंड $50 कंपनी 2 में लगा दिया. नाउ व्हाट विल हैपन? बेटा ये $50 50% चांस होगा कि ये डबल हो जाएगा. अच्छा अब देखो, ऐसा करने की भी जरूरत नहीं है. नाउ व्हाट विल हैपन? बेटा इफ इट इज रेनी, अगर वो रेनी सीजन है तो कंपनी 1 वॉज मेकिंग रेनकोट, तो माने ये वाला जो $50 है ये तो डबल हो जाएगा. एंड कंपनी 2 वॉज मेकिंग सनग्लासेस, तो ये वाला इट विल बिकम हाफ. So he will have 125 in rainy season with certainty. With certainty. श्योर है कि ये 125 होगा ही होगा उसके पास। ही विल हैव 125 इन द रेनी सीजन विथ सर्टेनिटी, क्योंकि हमने बोल दिया कि रेनी सीजन में ये 50 डबल हो गया, ये 50 हाफ हो गया। ही विल हैव 125 विथ सर्टेनिटी इन द रेनी सीजन। बेटा और क्या हो सकता है कि सीजन सनी हो सकता है। इफ सीजन इज सनी तो दिस विल बिकम हाफ, दिस विल डबल, माने हियर यू विल हैव $125। तो अगर सनी सीजन भी है, he will have this $125 with certainty. Now you will ask me, मैम वो तो यहाँ पे भी आ रहा था, what's the difference? क्या difference है बेटा? Here this $125 it was expected, ये probabilistic था। माने अगर आपने अपना सारा पैसा कंपनी 1 में डाला तो 50% चांस है दैट इट विल डबल, 50% चांस है दैट इट विल हाफ। दोनों में से कोई एक चीज ही होती, वन ऑफ द टू थिंग्स वुड हैव हैपेंड। 50% ऑफ द टाइम्स आपको 200 मिलता एंड 50% ऑफ द टाइम्स आपको 50 मिलता। हाँ, ऑन एन एवरेज आपको 125 मिल रहा है, still you're getting 125 on an average, but not with certainty. There is uncertainty beta, 50% of the chance you will get 200 if it will be rainy, and 50% of the chance you will get 50 if it is sunny. तो here probability is involved, but यहां पे हमने कोई probability नहीं लगाया। हमने बोला देखो अगर रेनी होगा तो ये तो डबल हो गया, ये हाफ हो गया। देर इज नो प्रोबेबिलिटी इन्वॉल्व। और अगर सनी होगा तो दिस बिकम्स हाफ एंड दिस बिकम्स डबल। बट एवरी टाइम आई विल गेट 125 विथ सर्टेनिटी। यहां पे यही 125 सर्टेनिटी से आएगा। और यहां पे क्या होगा ना कि अगर हमने रेनकोट वाला कंपनी में, आई इन्वेस्टेड माई मनी इन रेनकोट कंपनी ऑल $100, तो या तो वो डबल हो जाएगा 50% ऑफ टाइम और इट विल हाफ, but there is probability that this will happen 50% of time and this will happen 50% of time. Here there is no probability, I am getting 125 with certainty, है ना? तो basically what has happened is, please write down the line, by diversifying we have managed to reduce overall risk of investment while keeping expected payoff to be the same. So यहाँ पे also I'm getting 125 and here also I'm getting 125. So my payoff is the same. But here this is expected payoff. This is expected payoff because this is probability into payoff. Probability into payoff. और यहाँ पे कोई probability into payoff नहीं है. This is my actual payoff. There is no presence of probability. ठीक है? अच्छा, when can diversification work? But when can diversification work? It can work if both assets are negatively correlated. डाइवर्सिफिकेशन तब काम करती है जब बढ़ रहा है तो दूसरा गिरे। Suppose I would have said you that if it is sunny then both share will increase, if it is rainy then both share will decrease, तो फिर फायदा ही नहीं है पैसा आधा आधा करने का, क्योंकि अगर नुकसान होगा तो दोनों पे होगा, फायदा होगा तो दोनों पे होगा। तो फिर डाइवर्सिफाई करके फायदा क्या? नुकसान यहाँ पे दोनों केस में हो रहा है, दोनों ही शेयर में नुकसान होगा अगर रेनी है तो। If I lose money on both of them if it is rainy. That is not something I want. Diversification can work only when the directions are opposite. माने here in sunny one share is increasing, other is decreasing, and in rainy one share is decreasing, other is increasing. They are moving in opposite direction. तब you can diversify. Then it is useful to diversify. ठीक है? Is it clear? So please write down.
there will be no profit from diversification if assets are perfectly, better this is asked in exam, positively correlated. माने अगर एसेट सेम डायरेक्शन में जा रहे हैं, if the assets are moving in the same direction, there is no benefit from diversification. Is this clear to everyone? Right? Okay, beta. Thank you. Hi, good evening, everyone. Beta, in today's lecture, we are going to go ahead and we are going to talk about risk spreading. Huh? Risk spreading means ways to spread the risk of an individual. And how can an individual spread risk? Example, take an insurance. By taking insurance. So when an individual takes insurance, the risk gets spread. Okay. Let's take one case, right? So consider an individual who had 35,000 and he faced 1% probability, 1% means 0.01% chance that he will lose $10,000. Means he will be left up with $25,000. And 99% probability, 99% chance that his money will be intact. उसके पैसे को कुछ नहीं होगा. Now let us go ahead and imagine that, suppose that there are 100 individuals. ऐसे 100 लोग हैं, है ना? तो बेटा, out of 100 suppose 1,000 people are there, not 100, 1,000 people are there. So बेटा, out of 1,000 people, किसी भी एक इंसान का लॉस होने का चांस सिर्फ 1% है ना? There is only 1% chance that the person will lose. So out of these 1,000 people, बेटा, on an average कितने people will lose? On an average, 1 by 100 into 1,000, there is a chance that 100 individuals, sorry, 10 individuals will lose. माने किसी भी साल में at in any 1 year, ठीक है, out of 1,000 individuals, 10 will have a loss and बाकी 990 individuals, उनको कोई लॉस नहीं होगा. They will not have any loss, right? अच्छा, suppose these 10 individuals lose बेटा, तो हर एक individual how much money will he lose? $10,000. So what is the total money lost? Total money lost. What is the total money lost बेटा? There are 10 individuals और हर individual को जो loss होगा that will be for $10,000. The total money lost will be $1 lakh. Total money lost will be $1 lakh, है ना? Total money lost will be $1 lakh. ये बात clear होती है? ठीक है? Okay. Now, we need to understand that what is the expected wealth of any individual. किसी भी individual का expected wealth कितना है? With probability 1, the person will have 25,000. And with probability 99%, the person will have 35,000. Okay. So if I solve this, I will get $34,900. $34,900. ठीक है. So on an average, अगर हम देखें, हम ये बोल रहे हैं कि किसी भी इंडिविजुअल के पास $34,900 हैं. बट ये बात भी समझनी पड़ेगी कि ये जो 1% के साथ लॉस हो रहा है, जो लॉस का अमाउंट है वो 10,000 का है, $100 का नहीं है. ऑल्दो हियर इधर देख के आप बोल सकते हो कि मैम इतना क्या बड़ी बात है, 35,000 की जगह 34,900 ही तो बच रहा है. Instead of 35,000, this individual has 34,900. So what's the big deal, मैम? इतना क्या बड़ी बात हो गई, है ना? Don't think like that. Think like that अगर एक इंडिविजुअल को लॉस होता है, if he is in this 1% of the individual, अगर वो उनमें से है जिनको लॉस हो रहा है, then he will lose $10,000. The amount that he will lose is not less. He will lose $10,000. ठीक है. तो sometimes the expected wealth, this does not give a true picture. ये तो बोल रहा है कि देखो ठीक है, ऑन एन एवरेज आपके पास 34,900 बचेगा 35 की जगह. तो आप बोलोगे अरे वाह मैम, दिस इज नॉट बैड, इट्स फाइन. बट यू हैव टू अंडरस्टैंड दैट ईच इंडिविजुअल हु इज लूजिंग, जो भी पैसा लूज कर रहा है, बेशक ही 1% चांस है लूज करने का, बट इफ यू लूज, यू आर नॉट लूजिंग ₹100, बट यू आर लूजिंग $10,000. हाँ, ये जरूर बात है दैट चांसेस ऑफ लॉस आर लेस. बट इफ यू लूज, अगर लूज करोगे तो 10,000 का नुकसान होगा. यू विल हैव अ लॉस ऑफ 10,000, विच इज लॉट, राइट? सो देयरफॉर एन इंडिविजुअल हैज टू डाइवर्सिफाई. द क्वेश्चन इज हाउ कैन द इंडिविजुअल स्प्रेड हिज रिस्क. वो कैसे डाइवर्सिफाई कर सकता है? ही कैन डाइवर्सिफाई बाय सेलिंग सम ऑफ द रिस्क टू other individuals. Some of the risk to other individuals. है? माने फॉर एग्जाम्पल यहां पे ये जो 1,000 इंडिविजुअल्स हैं हमारे पास, दे इंश्योर ईच अदर. इंडिविजुअल्स इंश्योर ईच अदर, है ना? इंडिविजुअल्स इंश्योर ईच अदर. तो इसमें वो क्या करेंगे? वो बोलेंगे कि देखो, हम में से ये हम 1,000 इंडिविजुअल्स हैं, एंड सो ऑन, जिसे भी लॉस होगा, हुएवर विल हैव लॉस. माने सपोज इस साल इंडिविजुअल 1 को ये 10,000 रुपए का लॉस हो गया. ही इज अमंग दिस 1% इंडिविजुअल जिसे लॉस हुआ. हमें पता है कि 1% ऑफ 1,000 इज ओनली 10 इंडिविजुअल्स. सो आउट ऑफ ऑल 1,000 इंडिविजुअल्स, जो भी यहाँ पे हमारे पास ये पूल ऑफ 1,000 इंडिविजुअल्स है, हमें पता है कि सिर्फ 10 इंडिविजुअल्स विल हैव लॉस. 10 individuals will have loss. We know that remaining 990 individuals will not have loss. No loss. 990 individual will not have loss. So what we are now going ahead and saying कि ये 990 individual decide करते हैं, they decide that anyone who is going to go ahead and have a loss, we will contribute money for that individual. We will contribute money for that individual. ठीक है. तो अब देखो क्या हुआ इसमें. जैसे फॉर एग्जाम्पल ये 990 इंडिविजुअल्स बोल देते हैं कि इफ यू हैव अ लॉस, वी विल गिव यू $10 ईच. तो उसको कितना मिल जाएगा बच्चे? 9900. ही विल गेट 9900. तो व्हाट विल बी हिज नेट लॉस? ओनली $100, क्योंकि उसको 9900 बाकियों से मिल गया। एंड हाउ मच मनी ईच ऑफ देम इज लूजिंग? ओनली $10। उन्होंने तो सिर्फ $10 कंट्रीब्यूट किया। सो नन ऑफ देम इज लूजिंग, बट एटलीस्ट दिस पर्सन ही इज सिक्योर्ड, इसको एक सेफ्टी मिल गई। आर यू अंडरस्टैंडिंग दिस थिंग? इज दिस मेकिंग सेंस? सिमिलरली दे कैन चेंज दिस प्लान ऑल्सो। वो बोल सकते हैं कि लॉस हो ना हो, everyone has to, जितने हजार के हजार इंडिविजुअल हैं, everyone has to contribute $10, and whatever money we will receive, we will give this money to the person who had loss. लॉस हो या ना हो, सारे हजार लोगों ने $10 दिए, वी कलेक्टेड 10,000, और जिसको भी ये 10,000 का नुकसान हुआ था, हमने उसको ये दे दिया, राइट? और फिर अगली बारी, नेक्स्ट टाइम समवन एल्स विल हैव अ लॉस, वी विल गिव टू देम। नेक्स्ट टाइम समवन एल्स विल हैव अ लॉस, वी विल गिव टू देम। सो दैट इज कॉल्ड एज रिस्क स्प्रेडिंग। इससे क्या हुआ कि एट एनी पॉइंट एनीवन इज ओनली स्पेंडिंग हाउ मच बेटा? एट एनी पॉइंट ऑफ टाइम एनी इंडिविजुअल इज ओनली लूजिंग $10। $10 से ऊपर तो कभी भी लॉस नहीं हो रहा। अगर आप लॉस वाले लोगों में नहीं हो, देन ऑल्सो यू आर कॉन्ट्रीब्यूटिंग $10। और अगर आप लॉस वाले में हो, देन ऑल्सो यू कॉन्ट्रीब्यूटेड $10 ओनली, क्योंकि बाकी 10,000 तो वापस आ गए। सो एट एनी पॉइंट ऑफ टाइम यू आर नॉट लूजिंग अ लॉट ऑफ मनी, सो योर रिस्क हैज बीन स्प्रेड, राइट? एंड हर इंडिविजुअल के साथ यही होगा, एवरीवन विल हैव अ सिमिलर थिंग। So in that ways, what has happened is that you have been able to spread out your risk. Your risk is now more spread out, right? And this is what is called as risk spreading. इसी को हम risk spreading बोलते हैं. So what is risk spreading? Risk spreading is when each consumer spreads his risk over all the other consumers and thereby reduces the amount of risk he bears. Reduces the amount of risk he bears. तो सबने अब क्या करा ना, अपना अपना रिस्क कम कर दिया. Is this making sense? Clear? Okay. Now let's talk about one last thing beta today, which is called as role of stock market. Role of stock market says that stock market is very similar to insurance market in risk spreading. Because in stock market, what you do is you can convert your non-risky situation to a risk or a risky situation to a non-risky situation. माने क्या कर सकते हो ना कि you will put your money in different shares. Right? And at any point of time, the different shares will be moving in different direction. जरूरी नहीं है ना कि एक ऑटोमोबाइल कंपनी का शेयर और एक फार्मास्यूटिकल कंपनी का शेयर एक साथ लॉस दे या एक साथ प्रॉफिट दे. They can move in different directions. So that's the first thing. Secondly, what happens is that जो हमारे ओरिजिनल ओनर्स होते हैं कंपनी के, ओरिजिनल ओनर्स ऑफ द कंपनी, they issue share to multiple shareholders. They issue share to large number of shareholders, and because there are a large number of shareholders, माने किसी भी एक shareholder के पास बहुत ज्यादा रिस्क तो नहीं है. हाँ, एक कंपनी होगी who will go ahead and have about 1,000 or 10,000 shares, and they will go ahead and give each share to allocate each share to different individual. हाँ, तो
अगर एक कंपनी के सपोज 10,000 शेयर्स फ्लोट कर रहे हैं मार्केट में और आपके पास सिर्फ 4 शेयर है, so even if those 4 shares they are in loss, you are not having a lot of loss because out of 10,000 shares you only had 4 shares, right? So your loss is lowered, right? So in stock market, one, you can lower the risk by putting your money in different shares, and secondly, there are multiple shareholders related to any particular company, right? बट दिस इज इट, इसको बहुत ज्यादा हमें एक्सप्लोर नहीं करना है स्टॉक मार्केट के टॉपिक को. दिस इज द एंड ऑफ द स्टॉक मार्केट टॉपिक. ठीक है, इतना ही है. ओके, सो दिस इज द एंड ऑफ आवर चैप्टर नंबर chapter 12 of Variant, which talks about uncertainty. Now, if you go towards the end of chapter beta, तो chapter के end में there are 2 appendix given to you. ठीक है, appendix दिया हुआ है और उसमें एक example दिया हुआ है, effect of taxation on investment risky assets. That appendix is important and it will be good if you can just look at that appendix also. Right? Okay, beta. Thank you. Hi, good evening, everyone. Beta, today we are going to start with an important chapter, which is called as buying and selling. ठीक है, थोड़ा सा समझते हैं what this chapter is about. I want to go ahead and I want to define 2 things today. Net and gross demand. Net and gross demand. ठीक है. To understand net and gross demand, we know that there is something which is called as an endowment bundle. Right, beta? What is the endowment bundle? What the consumer enters the market with. कंज्यूमर किस बंडल के साथ मार्केट में एंटर करता है, that is called as endowment bundle, and I am representing this endowment bundle with omega 1 and omega 2. With omega 1 and omega 2. ठीक है, it's like this. You can go ahead and think it like this कि let omega 1 represent number of carrots the farmer enters the market with. माने एक फार्मर है, उसने कुछ कैरेट्स उगाई हैं, वो कितनी कैरेट के साथ मार्केट में एंटर कर रहा है, that is omega 1, right? And similarly omega 2 can be number of potatoes farmer enters the market with. ठीक है, तो बेटा this is omega 1 and omega 2, right? Now after the farmer enters the market, तो फार्मर ना सोचना शुरू कर देता है कि अच्छा, now I have entered the market. He observes the price of carrot and potatoes. वो मार्केट में एंटर करके प्राइस देखना शुरू करता है कि कैरेट का क्या प्राइस है, पोटैटो का क्या प्राइस है. सो ही स्टार्ट्स टू अंडरस्टैंड व्हाट इज द प्राइस ऑफ दीज गुड्स. ठीक है, इट्स लाइक अब जैसे अगर आपके टुमारो योर ग्रैंडफादर और ग्रेट ग्रैंडफादर दे गिव यू अ लैंड, वो आपके लिए एक जमीन छोड़ के जाते हैं, व्हाट विल यू डू बेटा? यू विल गो एंड सी द प्राइस ऑफ दैट ना, कि अच्छा ठीक है, मार्केट में जाके देखे तो सही इसका कितना वैल्यूएशन है, how much does it value, isn't it? Won't you do that? The same thing this farmer has
produced two things, beta. Huh? This farmer has gone ahead and this farmer has produced carrot. The farmer has produced the other thing as potatoes. And वहां enter करके market, he is thinking कि okay, what's the price of good? He's observing the price, right? And after observing the price, he is deciding how much to buy and sell. So he is deciding कि अच्छा ये तो मेरे पास था ही, should I sell this or should I buy more? What should I do? What should be my final bundle in that I should be consuming? मेरा final consumption bundle क्या होना चाहिए? वो सोचता है. So now we define two things, beta. One is called as gross demand. And one is called as net demand. Gross demand is how much is the amount of good consumer ends up consuming. Amount of good consumer ends up consuming माने वो कितना फाइनली घर लेके जा रहा है, फाइनल बंडल उसका क्या है. सो फॉर एग्जाम्पल दिस इज अ फार्मर. बेटा जब वो मार्केट में एंटर किया ही हैड 4 कैरेट्स एंड 7 पोटेटोज. और जब उसने मार्केट से एग्जिट किया, व्हेन ही एग्जिटेड द मार्केट, ही हैड 2 कैरेट्स एंड 10 पोटेटोज. ठीक है. So what he is exiting the market with, it is represented with x1, x2. And this is called as gross demand. And what he entered the market with, कितने के साथ वो market enter किया, that is omega 1, omega 2. And this is called as endowment bundle. Endowment bundle. And the difference between the two, है ना बेटा, that is called as net demand. तो यहां पे नेट डिमांड हो गई x1 माइनस ओमेगा 1, x2 माइनस ओमेगा 2. इन दिस केस नेट डिमांड क्या है बेटा? 2 कैरेट माइनस 4 कैरेट, 10 पोटेटो माइनस 7 पोटेटो, है ना. दैट मीन्स माइनस 2 कैरेट एंड 3 पोटेटो. माने माइनस क्या शो कर रहा है कि वो एंड में ही इज टेकिंग लेस होम. ही स्टार्टेड विद 4 कैरेट्स and he has only 2 carrots. माने उसने ज्यादा बेच दिया, वो अपने लिए कम घर लेके जा रहा है. So negative means that he is consuming less than what he had. जितने के साथ उसने मार्केट में एंटर किया उससे कम वो घर लेके जा रहा है, right? So negative means that the consumer wants to consume less of good one than she had. So consumer has sold good one. Ultimately उसने सेल किया 2 यूनिट. He has sold good one. He is consuming less than what he entered the market with. जितने के साथ मार्केट में एंटर किया उससे कम फाइनल में कंजम्पशन है. He is only consuming 2 units. He entered the market with 4 units. माने 2 उसने सेल कर दी. He has sold off 2 units. यहाँ पे he entered with 7, he has 10, माने he has 3 extra units ना. So यहाँ पे consumer purchased additional units of good 2. He is consuming more than what he entered the market with. जितने के साथ he entered the market, he entered with 7 units. He has finally 10 units. माने उसने 3 extra खरीदे हैं. He has purchased 3 more, right? So he has 3 more units of potatoes. But when this consumer is selling 2 units of carrot, so this 2 unit of carrot, it
acts as net supply in the market. तो ये 2 यूनिट उसने मार्केट में बेच दिए ना, he has sold these 2 units now. So if he has sold these 2 units, it means that he has supplied those 2 units in the market, right? So we can say that negative net demand is equal to amount supplied. Negative net demand is the amount supplied. Similarly, positive net demand is amount demanded. Is the amount demanded. Is this clear, beta? So, abhi ke liye, there are 3 concepts that you have to understand in this. First, what is endowment? Second, what is gross demand? And third, what is net demand? Clear, beta? Okay. Okay, beta. Thank you. Hello everyone, welcome to the portal of ArthaPoint, which is courses.arthapoint.com learn. And here on this portal, beta, you can go ahead and have a look at various categories of courses, which is IIT JAM, CUET, MA Economics, DEPR, DU semester courses and whatnot. If you click on DU semester courses, you will be able to see the various courses on the portal which are available to you. A lot of these courses are an initiative of ArthaPoint, which means that we are not charging any fees, beta. This is only the portal fees, in which you have introductory mathematical methods for economics, introductory microeconomics, introductory statistics for economics. Then you have intermediate microeconomics, semester 3, intermediate microeconomics, macroeconomics. This is a paid course. Only this is for 5,000. So you can clearly see that in the paid course, if you click, you will also go ahead and get access to various assignments and you will get access to various other concepts also. So you see here, you also have additional lecture, you have notes, you have assignments, everything is part of the paid course. For all the subjects, you can see past year papers being solved. You can see past year papers being solved and important numericals being discussed in the paid course. So this is a paid course which is for macroeconomics. But if you go ahead and if you look into the other courses of DU economic semester, they are available for no fees. This is only the portal fees that we are charging. Similarly, if you go ahead and you look into the 5th semester, game theory is a paid course in which we are solving various problem sets also. But other than game theory, other courses like economic growth and business cycle, like introductory development economics, these are all the initiative, only portal fees is being charged. And if you go ahead and you look into this introductory development economics, you can see that I have gone ahead and I have covered a lot of the course, even though it is an initiative. You can see that unit 1 is completely covered. You can see that unit 2 is covered, and you can see that unit 4 is also completely covered. In unit 3 also we have covered 1 chapter. So this is the link to our portal. You can go ahead, you can have a look at the various courses. Similarly, if you go ahead and you have a look at the IIT JAM courses, here you will be able to see the different mock test series for IIT JAM that have been launched. At the same time, you will be able to also see the question bank for CUET, which has been now launched, and you will be able to see the different other courses also, right? These are only few of the courses, beta. We do provide more courses also. These are the courses which you can directly access. But if you want a full-fledged course on IIT JAM or a full-fledged course on MA Economics entrance or a full-fledged course on Indian Economic Service, you can always contact Rohit sir and he will go ahead and he will talk about the different courses that we have.
So I just wanted to quickly show you the portal of ArthaPoint, and all of you can go to this portal and you can have a look at different courses. Okay, beta, thank you. Hi, good afternoon, everyone. Let us go ahead and now let us talk about the budget constraint, which we will go ahead and use in case of buying and selling. Now, we have already introduced the concept of what is, what is basically endowment bundle, what is gross demand and what is net demand. We're going to go ahead and we're going to take it from there, and we're going to talk about the budget constraint now. So usually speaking, beta, budget constraint kya hota hai? What is budget constraint? The budget constraint that we have is this: P1 X1 plus P2 X2 equal to income of consumer. यही होता है budget constraint. But in this case, ये जो consumer था, he was like a farmer. The consumer was someone new. The consumer was like a farmer. And what was the consumer actually going ahead and doing? The consumer was going ahead and taking his product to the market. Consumer अपना product market में लेके जा रहा था. And by selling his product in the market, he will earn some income. And from that income, he will go ahead and he will purchase the commodity. So the consumer in this case will earn income by selling his endowment. जो भी उसने पहले अपना प्रोड्यूस किया है. So in this case, for example, the farmer had gone with the bundle 4C and 7P. है ना? So this was his endowment bundle. So वो पहले वो मार्केट में सेल करके he can earn income. So income will be P1 price value of endowment of good one, value of endowment of good one, plus beta P2 omega 2, value of endowment of good 2. So value of endowment of good 1 plus value of endowment of good 2 together gives you the income of the consumer. Together it gives you the income of the consumer. So we can rewrite the budget line. How, beta? We know P1 X1 plus P2 X2 equal to income. So P1 X1 plus P2 X2 will be equal to P1 omega 1 plus P2 omega 2. क्योंकि इनकम endowment bundle को सेल करके मिल रहा है. You're getting income by selling the endowment bundle. Now, beta, what we can do is we can take this on this side. We will get P1 X1 plus P2 X2 minus P1 omega 1 minus P2 omega 2 equal to 0. Okay. Now we can club beta. P1 X1 minus P1 omega 1 इसको club कर दो. So take P1 common. X1 minus omega 1. Similarly, P2 X2 and P2 omega 2 को club कर दो. So take P2 common. X2 minus omega 2 equal to 0. Equal to 0. ठीक है. बेटा लिसन टू मी वेरी केयरफुली. अब जो मैं लाइन बोलने लगी हूं वो बहुत बहुत इंपॉर्टेंट है. यू नीड टू लिसन टू मी वेरी वेरी केयरफुली. ठीक है. बहुत ध्यान से समझो कि इफ x1 इज मोर देन ओमेगा 1, माने आपने जो कंज्यूम किया वो उससे ज्यादा है जो आपने प्रोड्यूस किया था. इफ x1 इज मोर देन ओमेगा 1, it means x1 minus omega 1 will be positive. if it will be positive, it means you were a net buyer. आपने खरीदा है मार्केट से, और you were a net buyer, net demander. And beta, if x1 is less than omega 1, then beta x1 minus omega 1 will be less than 0. So it means that you will be net seller. आप मार्केट में सेल कर रहे हो, you're not buying, you are selling in the market. ठीक है. अब क्वेश्चन ये आता है which is very important, under what circumstances this equation can be satisfied. ये जो हमारा this equation that I have written here, when this be satisfied. तो एक केस तो ये हो गया बेटा कि if हमें राइट हैंड साइड 0 है, so which means हमारा लेफ्ट हैंड साइड भी 0 होना चाहिए. Our right hand side is 0, so left hand side भी 0 ही होगा, right? So one condition is if x1 is equal to omega 1, अगर हम इन दोनों को इक्वल कर देते हैं, so we will get x1 equal to omega 1. ठीक है. अगर मैं ये करती हूं, if I put x1 equal to omega 1, what will I get? p1 into 0 plus p2 x2 minus omega 2 equal to 0. So from here, beta, I will get x2 equal to omega 2. माने if I have x1 equal to omega 1, then I will get x2 equal to omega 2. उस केस में मेरा x2 और omega 2 equal आएगा. So what does this mean? It means that if in market 1 में consumption is exactly equal to endowment. आप जितना लेके आए मार्केट में वही खा रहे हो, उतना ही कंज्यूम कर रहे हो. If in market 1 consumption is exactly equal to endowment, then we get what condition beta? That in market 2 also consumption should be equal to endowment. तो फिर मार्केट 2 में भी कंजम्पशन एंडोमेंट के बराबर होगा. कंजम्पशन विल बी इक्वल टू एंडोमेंट. क्लियर? केस 2 बेटा. Suppose I tell you x1 is more than omega 1. तो बेटा if x1 is more than omega 1, माने यहां पे कोई एक पॉजिटिव नंबर आ रहा है. So what is the equation I have written? I have written p1 x1 minus omega 1 plus p2 x2 minus omega 2 equal to 0. If x1 is more than omega 1, माने x1 minus omega 1, it is positive. सपोज बेटा यहां पे कोई एक पॉजिटिव नंबर आ रहा है, प्राइस इज पॉजिटिव, सो इट मींस दैट दिस पार्ट विल बी पॉजिटिव. ये चीज एक पॉजिटिव चीज है बेटा. इफ दिस इज पॉजिटिव और मुझे दो चीजों का सम 0 करना है, इफ आई वांट टू मेक द सम 0, तो अगर एक पॉजिटिव है तो दूसरे को नेगेटिव होना जरूरी है. ओनली देन द सम कैन बी 0. सो इफ वन इज पॉजिटिव, अदर विल बी नेगेटिव, only then the sum can be 0. माने if the consumer is net demander in market 1, market 1 में consumer net demander है, he is demanding, net purchase कर रहा है, then बेटा यहां पे हमें नेगेटिव चाहिए, which means x2 should be less than omega 2. He should be, this is very important question in exam, net supplier in market 2. He should be net supplier in market 2. If he is net demander in market 1, अगर वो market 1 में net demand कर रहा है, he should be net supplier in market 2. Is this clear? Similarly, बेटा case 3, p1 x1 minus omega 1 plus p2 x2 minus omega 2 should be 0. If x1 minus omega 1 is less than 0, अगर ये नेगेटिव है तो बेटा दिस टर्म इज नेगेटिव. तो वी नो कि समथिंग विच इज नेगेटिव, उसमें हमें कुछ पॉजिटिव ऐड करना पड़ेगा टू गेट 0. सो इट मीन्स दैट वी विल गेट x2 minus omega 2 greater than 0. So x2 will be more than omega 2. x2 will be more than omega 2. बात क्लियर हो रही है? So if the individual is net supplier in market 1. ये negative है means net supplier. He is consuming less than what he has entered the market with. उसका consumption कम है. So if consumer is net supplier in market 1, he will be net demander in market 2. He will be net demander in market 2. ये तीनों points clear हो? ये बहुत important है from the point of view of exam. So what we have learned, if a consumer is net demander in market 1, he will be net supplier in market 2. If he is net supplier in market 1, he will be net demander in market 2. If he is demanding equal to his endowment, माने अगर उसका जो इक्विलिब्रियम बंडल है वो ऐसा है कि x1 इक्वल टू ओमेगा 1 ही हो रहा है, देन ही विल ऑल्सो डिमांड इक्वल टू एंडोमेंट इन मार्केट 2. बात क्लियर हो गई है? ठीक है. इफ दिस इज क्लियर टू यू बेटा, देन वी कैन गो अहेड एंड वी कैन लुक एट द बजट लाइन. टू लुक एट द बजट लाइन हम एक बार समझ लेते हैं व्हाट इज गोइंग टू बी द स्लोप ऑफ द बजट लाइन. The slope of budget line can be written, अगर हम यहीं से देखें तो स्लोप क्या था बेटा? रेशियो ऑफ द प्राइसेस, रेशियो ऑफ द प्राइस ऑफ द टू गुड्स. तो यहां पे भी प्राइस ऑफ टू गुड्स तो P1 P2 ही है ना. सो स्लोप ऑफ बजट लाइन विल रिमेन द सेम ओनली बेटा. सो स्लोप ऑफ दिस बजट लाइन विल बी P1 by P2. Slope will be P1 by P2. अच्छा, now what we can do is three things. बेटा ये हो गया x1, ये हो गया x2, ये मेरा बजट लाइन है, ये है स्लोप इस बजट लाइन का P1 by P2 with a negative sign. ठीक है. Each budget line has to pass through this bundle. बंडल नंबर 1. देखो जो भी इंसान मार्केट में आया है, सपोज मैं बोलूं कि मैं एक फार्मर हूं एंड आई हैव एंटर्ड द मार्केट विथ 4 एप्पल एंड 6 ऑरेंज. So at any point I can exit the market with 4 apple and 6 orange. भाई जो मैं प्रोड्यूस करके मार्केट में लेकर आई हूँ, whatever I have produced and got in the market, I can consume that bundle itself, isn't it? वो बंडल तो मेरे लिए हमेशा अफोर्डेबल रहेगा, वो तो मैं हमेशा कंज्यूम कर सकती हूँ. सो दिस इज व्हाट दिस इज सेइंग, that I am consuming exactly equal to my endowment. Whatever I entered the market with, I am consuming exactly equal to my endowment. So that is always possible. So this is a bundle beta that x1 can be equal to your endowment bundle and x2 your endowment bundle. ये बंडल ये रिप्रेजेंट करता है that x1 is equal to omega 1 and x2 is equal to omega 2. माने this consumer is consuming equal to his endowment bundle. ये तो हमेशा पॉसिबल होगा ना, that you can consume equal to your endowment bundle. This is always a possibility. So if this is always a possibility, it means that budget line can always pass through the endowment bundle. Budget line can always pass through the endowment bundle. बेटा take any bundle here. Suppose bundle B का बात करें, ये bundle A है. So in bundle B, what has happened? देखो मैं यहां पर हूं, x1 dash, x2 dash. So in bundle B, what has happened? Consumption of good 1 is more than endowment. माने I am a net buyer of good 1. और यहां क्या हो रहा है? That consumption of good 2 is less than endowment. That means I am a net supplier of good 2. यही तो ये केस था. This was this case. If you are a net buyer of good 1, and this is positive, this is more than endowment, so you will be net supplier of good 2. You will be net supplier of good 2. Clear? Beta case 3. Take a point here, point C. Point C पे क्या हो रहा है? What is happening at point C beta? Your bundle is x double dash and x2 double dash. At point C you are consuming less than endowment. गुड 1 का कंपेयर करो एंडोमेंट से तो आपका कंजम्पशन कम है, और गुड 2 का कंज्यूम करो तो एंडोमेंट से ज्यादा है. सो फॉर गुड 1 your consumption is less than endowment. It means you are a net supplier. And for good 2, your consumption is more than endowment. It means you are a net buyer. So, but these are the different points. Point A, B, and C. Clear? Is this budget line clear to everyone? Okay, beta. Thank you. Hi, good afternoon, everyone. Beta, let us now try to understand what happens when we go ahead and when we change the endowment bundle. Okay. Suppose your initial endowment bundle क्या था बेटा? What you enter the market with. ठीक है. So suppose your initial endowment bundle is omega 1, omega 2. ठीक है. And your new endowment bundle that is omega 1 dash ओमेगा 2 डैश. तो आपका जो एंडोमेंट बंडल है वो चेंज हो गया. जो आप मार्केट में एंटर कर रहे हो, जैसे पहले आप मार्केट में आपने एंटर किया 4 एप्पल 3 ऑरेंज के साथ, और अब आपने मार्केट में एंटर किया 5 एप्पल एंड 6 ऑरेंज के साथ. तो व्हाट यू आर एंटरिंग द मार्केट विथ दैट हैज चेंज्ड. ठीक है. ऑल्सो ऑल्सो सपोज नाउ यू आर एंटरिंग विथ मोर वैल्यू. माने पहले पहले आप जो अपना एंडोमेंट के साथ एंटर कर रहे थे, इफ यू वुड हैव सोल्ड दैट, सपोज आपको 100 रुपीज मिलते, और अब जो उसी एंडोमेंट बंडल जिसके साथ आप एंटर कर रहे हो, इफ यू सेल दैट, सपोज यू विल गेट 500. सो व्हेन यू विल बी सेलिंग योर एंडोमेंट बंडल, you will go ahead and you will be able to you will be able to get more value, right? Is that making sense? So now what has happened is your endowment bundle is worth more. So let us go ahead and let us try to write this down. How can we write this in terms of maths? We can go ahead and do something like this. So हमारा value of new endowment bundle क्या होगा बेटा? P1 omega 1 dash, P2 omega 2 dash. ये हो गया value of new endowment bundle. है ना? जब हम किसी को भी प्राइस से मल्टीप्लाई करते हैं, वी गेट वैल्यू. सो दिस इज द वैल्यू ऑफ न्यू एंडोमेंट बंडल, राइट? एंड हमारा वैल्यू ऑफ ओल्ड एंडोमेंट बंडल क्या है बेटा? वैल्यू ऑफ ओल्ड एंडोमेंट बंडल है P1 ओमेगा 1 प्लस P2 ओमेगा 2 प्लस P2 ओमेगा 2. बेटा देखो, ध्यान से समझो. इफ P1 omega 1 plus P2 omega 2 is greater than P1 omega 1 dash plus P2 omega 2 dash. इसका क्या मतलब है कि पहले जब हम अपने एंडोमेंट बंडल को सेल करते थे, when we were earlier selling the endowment bundle, we were going ahead and we were getting more value. And when we are now selling our endowment bundle, we are getting less value. Value of the new endowment bundle is less. ठीक है. तो इसका मतलब हो गया value of new endowment bundle is less. और बेटा अगर इसको रिवर्स कर दे, if P1 omega 1 plus P2 omega 2 is less than P1 omega 1 dash plus P2 omega 2 dash. इसका क्या मतलब है? This means value of new endowment bundle is more. जो जिसके साथ अब हम एंटर कर रहे हैं मार्केट में, व्हाट वी आर एंटरिंग विद एंटरिंग द मार्केट नाउ, जिसके साथ अब हम एंटर कर रहे हैं, वो हमें ज्यादा वैल्यू दे रहा है, ठीक है। तो बेटा दिस ट्राई टू थिंक अबाउट दिस, इफ द वैल्यू ऑफ एंडोमेंट बंडल इज मोर, जिसके साथ अब आप मार्केट में एंटर कर रहे हो, अगर उसका वैल्यू ज्यादा है, हाँ, इट मीन्स कि व्हाट यू विल सेल विल अर्न यू मोर, what you will sell, जो आप बेच रहे हो मार्केट में, whatever you are entering with, you will sell that. So what you are selling is worth more. So this represents बेटा increase in income of consumer. This is representing increase in income of consumer. और अगर जो नया endowment bundle है, जिसके साथ अब हम मार्केट में एंटर कर रहे हैं, if its value is less, so बेटा it represents decrease in income of consumer, है कि नहीं? Because consumer was earning income by selling the endowment bundle. Consumer के पास पैसा कहां से आ रहा था? Endowment bundle को बेच के, right? So this is the value of the endowment bundle. If new endowment bundle has less value, consumer will have less income. And if new endowment bundle it has more value, consumer will have more income. समझ रहे हो ये बात? Are you understanding this thing? So बेटा we know that एक चीज हमने एक प्रॉपर्टी पढ़ा था, that every budget line must pass through endowment bundle. एवरी बजट लाइन मस्ट पास थ्रू endowment bundle. तो ये बात भी हमें क्लियर है कि कोई भी अगर बजट लाइन होगा तो इट हैज टू पास थ्रू endowment bundle. तो बेटा इस केस में देखो, इफ द वैल्यू ऑफ न्यू endowment bundle इज लेस, तो इनकम हैज डिक्रीज्ड. तो हाउ कैन वी शो डिक्रीज इन इनकम? ये हमने पढ़ा हुआ है. डिक्रीज इन इनकम कैन बी शोन बाय बैकवर्ड शिफ्ट ऑफ बजट लाइन. अगर इनकम कम होती है तो वी शिफ्ट द बजट लाइन बैकवर्ड्स. सो व्हाट विल दैट मीन बेटा? बजट लाइन हैज शिफ्टेड बैकवर्ड्स. ठीक है. अच्छा एक बात और है, एवरी बजट लाइन पासेस थ्रू द एंडोमेंट बंडल. तो जो हमारा ओल्ड बजट लाइन है इट विल पास थ्रू ओल्ड एंडोमेंट बंडल, और जो हमारा न्यू बजट लाइन है इट विल पास थ्रू न्यू एंडोमेंट बंडल. बट सिंस वैल्यू ऑफ न्यू एंडोमेंट बंडल इज लेस, नए एंडोमेंट बंडल की वैल्यू ही कम है ना? सो व्हाट विल हैपन? लेस इनकम ऑफ कंज्यूमर, तो बजट लाइन विल शिफ्ट इनवर्ड्स. अब यहां देखो, वैल्यू ऑफ न्यू एंडोमेंट बंडल इज मोर, सो इनकम ऑफ कंज्यूमर हैज increased. So if income of consumer has increased, how can we show that beta? Rightward shift of budget line. Income बढ़ता है तो budget line parallelly rightward shift होता है. So we can show this by outward shift of the budget line. Outward shift of the budget line. Also every budget line passes through the endowment bundle. तो ये पुराना budget line पुराना endowment bundle से पास करेगा, W1 कॉमा W2, और न्यू बजट लाइन न्यू एंडोमेंट बंडल से पास करेगा. वेयर द न्यू एंडोमेंट बंडल इज डज नॉट मैटर. नया एंडोमेंट बंडल यहां पे भी हो सकता है, यहां पे भी, उससे फर्क नहीं, उसका वैल्यू ज्यादा है ना. सो इट इज ऑन अ हायर बजट लाइन, सो दिस विल बी W1 डैश W2 डैश. क्लियर? बेटा एक एग्जाम्पल ले लेते हैं. अर्लियर you had 2 orange 3 apple. now ये endowment है, हाँ, you have 1 orange 5 apples. 1 orange is for 10 rupees and 1 apple is for 5 rupees. तो बेटा अर्लियर आपका कितना वैल्यू था एंडोमेंट बंडल का?
2 ऑरेंज, ये ऑरेंज है, ओ है, हाँ, 2 into 10 rupees, 3 apple 3 into 5 rupees. अर्लियर आपका इनकम था 20 plus 15 35. बेटा व्हाट इज योर न्यू इनकम? 1 ऑरेंज 10 rupees, 5 एप्पल 20, 5 एप्पल, हर एप्पल 5 rupees का है, 10 plus 25 35. So both endowment bundle give you the same level of income. So both will be on same budget line. तो ये हमारा एक बजट लाइन है। बजट लाइन का स्लोप क्या होगा बेटा? प्राइस px by py, प्राइस ऑफ गुड x by प्राइस ऑफ गुड y, 10 divided by 5 2. तो स्लोप ऑफ बजट लाइन ऐसा कुछ है, ठीक है। दिस इज ऑरेंज, दिस इज एप्पल। अर्लियर एंडोमेंट बंडल क्या है बेटा? 2 ऑरेंज 3 एप्पल, 2 ऑरेंज 3 एप्पल, ठीक है। न्यू बजट लाइन बेटा 1 ऑरेंज 5, न्यू एंडोमेंट बंडल क्या है? 1 ऑरेंज 5 एप्पल, 1 ऑरेंज 5 एप्पल, और दोनों का वैल्यू सेम है, बोथ गिव यू द सेम वैल्यू। तो बेटा 1 ऑरेंज 5 एप्पल, 2 ऑरेंज 3 एप्पल, ये हो गया आपका ओल्ड एंडोमेंट बंडल, न्यू एंडोमेंट बंडल, दोनों both are on same budget line because they have same value. Same budget line because they have same value. Is this clear? ठीक है, ठीक है बेटा। होमवर्क क्वेश्चन, टेल मी व्हाट विल बी दिस पॉइंट। इस पॉइंट को आप क्या नंबर दे सकते हो? व्हाट विल बी दिस पॉइंट, ठीक है। एंड सेकेंड पार्ट बेटा, सपोज न्यू एंडोमेंट बंडल is 0 orange 6 apple, then plot old and new budget line. सपोज आपका ओल्ड एंडोमेंट बंडल 2 ऑरेंज 3 एप्पल है, प्राइस ऑफ 1 ऑरेंज इज 10 rupees, प्राइस ऑफ 1 एप्पल इज 5 rupees, and new endowment bundle is 0 orange and 6 apples. So you need to draw the two budget lines. Okay? ठीक है बेटा, thank you. Hi, good afternoon, everyone. Beta, in today's lecture, we will try to go ahead and see how the budget line changes when there are change in the price of the good. अगर good का price change हो जाएगा, तो budget line कैसे change होगी, हम उसको देखेंगे in the presence of the endowment bundle. बहुत simple है, it's not very difficult, हाँ. So, case 1 बेटा. एक एग्जाम्पल के लिए ले लेते हैं। सपोज इनिशियली आपका जो इंडोमेंट है दैट इज 4 यूनिट्स ऑफ गुड 1 एंड 6 यूनिट्स ऑफ गुड 2, राइट बेटा? बेटा गुड 1 का जो प्राइस है दैट इज 2 रुपी पर यूनिट, गुड 2 प्राइस that is 1 rupee per unit. Can you tell me what will be the income of the consumer? Beta, income is nothing but value of endowment bundle. So it will become P1 omega 1 plus P2 omega 2 माने 2 into 4 plus 1 into 6, 8 plus 6, 14. 8 plus 6, 14.
ठीक है बच्चे, ईच बजट लाइन passes through endowment bundle. बजट लाइन endowment bundle से तो पास होगी ही होगी. What will be the slope of this budget line? P1 by P2. What is P1 beta? P1 is 2. P2 is 1. So the slope of budget line will be 2. बजट लाइन का स्लोप क्या हो जाएगा? द स्लोप ऑफ बजट लाइन विल बिकम 2. ठीक है. नाउ लेट अस जस्ट ट्राई टू गो अहेड एंड राइट एवरीथिंग डाउन. अगर मुझे ये सब कुछ कहीं पे मेंशन करना है एक ग्राफ में तो मैं कैसे दिखा सकती हूँ? हाउ कैन आई शो दिस? बेटा गुड 1, गुड 2. ठीक है. एक्स एक्सिस इज व्हाट? m by p1. इनकम है 14, प्राइस ऑफ गुड 1 2 है, सो एक्स एक्सिस हो गया 7 यूनिट्स. y एक्सिस इज व्हाट? m by p2. इनकम हमने 14 निकाला, प्राइस ऑफ गुड 2 1 है, 14. ये हो गया y एक्सिस पॉइंट. सो हियर आई हैव 7, हियर आई हैव 14 एंड बेटा ये हो गया मेरा बजट लाइन. दिस इज माय बजट. बजट लाइन हैज टू पास थ्रू द पॉइंट ऑफ एंडोमेंट. तो एंडोमेंट बंडल क्या था? व्हाट्स द एंडोमेंट बंडल? एंडोमेंट बंडल इज 4,6, राइट? बेटा समवेयर हियर इज 4, this is 6, this is my endowment bundle. What is the slope of budget line? Slope is -2. Minus shows downward sloping and वैसे 2 है. ठीक. Suppose बेटा that your initial equilibrium is here. ये आपका equilibrium point है. Okay. How do we find equilibrium? Through tangency of indifference curve and budget line. जहां पे indifference curve of budget line tangent होते हैं वो हमारा equilibrium point होता है. नाउ लिसन टू मी वेरी केयरफुली. बहुत ध्यान से सुनिए मेरी बात, ये बहुत इंपॉर्टेंट है. व्हेन कंज्यूमर इक्विलिब्रियम पॉइंट इज पॉइंट ई, तो इक्विलिब्रियम पॉइंट का एक प्रॉपर्टी है. इक्विलिब्रियम पॉइंट हैज अ प्रॉपर्टी. व्हाट इज द प्रॉपर्टी ऑफ इक्विलिब्रियम पॉइंट बेटा? प्रॉपर्टी ये है दैट दिस पॉइंट is preferred or revealed preferred over all other affordable bundles. This point is revealed preferred over all other affordable bundle. माने अगर मैंने ये point choose किया है, if I have chosen this point, then all other points that are affordable. कौन कौन से points affordable हैं? Anything on or below budget line is affordable. So all these points बेटा ये affordable हैं. All these points they are affordable. All these points they are affordable. So as compared to all affordable points, मतलब any point which are my affordable bundles beta, all points on or below budget line. जो भी points budget line के ऊपर हैं या budget line के अंडर हैं, all points on or below budget line, above them I am choosing my equilibrium bundle. मैंने अपने equilibrium bundle को choose कर लिया. I am choosing my equilibrium bundle. Is this clear बेटा? ये clear हो गई इतना बात? Now case 1. Suppose price of good 1 decreases. Suppose बेटा मैं आपको बोल दूं कि price of good 1 is now 1 rupee. तो can you tell me what will be income of consumer? Income of consumer is value of endowment bundle. इनकम ऑफ कंज्यूमर इज वैल्यू ऑफ एंडोमेंट बंडल. तो हमारा एंडोमेंट बंडल क्या है बच्चे? व्हाट इज माय एंडोमेंट बंडल? माय एंडोमेंट बंडल इज 4,6. है ना। तो इसका वैल्यू निकाल लेते हैं, P1 ω1 प्लस P2 ω2, P1 चेंज हो गया, इट इज 1, P2 इज ऑल्सो 1, 4, 6। तो इनकम क्या आ जाएगा बेटा, 10 रुपीज। बेटा व्हाट विल बी एक्स एक्सिस पॉइंट, इट विल बी m by px, तो 10 by 1 10। बेटा व्हाट विल बी y एक्सिस पॉइंट, इसको आई विल राइट P1, हाँ, m by P2, इनकम है 10, ये भी 10, 10। बेटा व्हाट इज स्लोप ऑफ बजट लाइन नाउ, P1 by P2, 1 by 1 -1। बेटा हमें पता है, वी नो दिस थिंग, दैट ऑल बजट लाइन पास थ्रू endowment bundle. All budget line pass through the endowment bundle. Endowment bundle has not changed. Endowment bundle unchanged है. So new budget line will pass through this endowment bundle बेटा. और अब x axis का हमारा intercept क्या है, 10. Y axis intercept is what, 10. So new budget line will be this. New budget line will be this. है कि नहीं? तो बेटा this is my new budget line. ये हो गया हमारा न्यू बजट लाइन। क्वेश्चन नंबर 2 इसमें अब आता है, वेयर विल बी, ये क्वेश्चन 1 है, केस 1 नहीं, इसको क्वेश्चन 1 बोल देते हैं, कि प्लॉट न्यू बजट लाइन। बेटा क्वेश्चन 2, वेयर विल न्यू इक्विलिब्रियम पॉइंट लाई, मतलब अब नया इंडिफरेंस कर्व कहां होगा, वेयर विल यू सी न्यू टेंजेंसी बंडल, वेयर विल बी न्यू कंजम्पशन बंडल, नया कंजम्पशन बंडल कहां होगा। सो बेटा ट्राई टू सी समथिंग, जो भी मैंने ऑरेंज से मार्क किया है उसके ऊपर अर्लियर इक्विलिब्रियम बंडल वाज प्रेफर्ड, बिकॉज व्हेन यू कंज्यूम्ड दिस बंडल, जब हमने ये पॉइंट ई चूज किया, व्हेन वी चोज दिस पॉइंट ई, ऑल पॉइंट्स मार्क्ड विद ऑरेंज वर अफोर्डेबल, फिर भी हमने पॉइंट ई चूज किया। सो व्हेन वी वेंट अहेड एंड व्हेन वी चोज पॉइंट ई, जब हमने इस पॉइंट को चूज किया, ये जो हमारा ऑरेंज सेट है, दिस ऑरेंज सेट, ये सारा अफोर्डेबल था, ऑल दिस वाज अफोर्डेबल, ठीक है, ऑल दिस वाज अफोर्डेबल। सो व्हेन कंज्यूमर चोज बंडल ई, पूरा जो हमारा ऑरेंज सेट है, इट वाज अफोर्डेबल, बट ई वाज प्रेफर्ड, बट हमने ई को प्रेफरेंस दिया, वी प्रेफर्ड ई, when all other were affordable, we preferred E, ठीक है। सो इफ वी प्रेफर्ड E when other bundles were affordable, तो अब हम वो वर्स ऑफ बंडल पे तो नहीं जा सकते ना, कंज्यूमर शुड नॉट गो टुवर्ड्स वर्स ऑफ बंडल, सो कंज्यूमर कैन नॉट go towards worse of bundles। समझो ध्यान से, इफ द कंज्यूमर कम्स हियर, अगर कंज्यूमर अपने इंडिफरेंस कर्व को यहां ले आया, तो वो तो लोअर इंडिफरेंस कर्व पे हो गया ना, ही विल बी ऑन अ लोअर इंडिफरेंस कर्व, if he will be on a lower indifference curve, his utility will decrease, right? So he will become worse off, we don't want this, हमें ये नहीं चाहिए। तो कंज्यूमर अब कहां जा सकता है, he cannot go in the orange region, ऑरेंज रीजन से ऊपर वाला बंडल तो वो पहले ही प्रेफर कर रहा था, he was preferring this bundle, so he cannot go in the orange region, so where he can go beta, he can go here, his new equilibrium can be anywhere on this black part of the budget line, समझे। So he can only, his new equilibrium can lie only in this part of budget line. New equilibrium region. अगर वो, so green budget line is the new budget line, है ना? हमारा green budget line new budget line था. But in this new budget line, if I am in this region बेटा, तो I will become worse off. मैं worse off हो जाऊंगी, right? I will become worse off, है ना? I don't want to become worse off. So therefore मैं उस region में जाऊंगी जहां का preference से relation नहीं होगा. Anything in the orange part, उसके ऊपर तो मैं already I was consuming, so I will become worse off. So I want to go towards this part of the new budget line. So this will be my new equilibrium region. This will become my new equilibrium region. ठीक है? अब अगर मेरा नया equilibrium, suppose it is here, माने I am consuming more than endowment, और earlier I was consuming less than endowment. माने पहले, earlier, I was a seller, क्योंकि मैं endowment से कम कंज्यूम कर रही थी. I was selling, and now I am a buyer. So a consumer will convert from a net seller towards a net buyer. Consumer will convert towards from a net seller towards a net buyer. बात समझ में आई? This is very tricky and very useful for exam. ठीक है. So the new equilibrium, consumer will be net buyer of good one. Consumer will become net buyer of good one. नया equilibrium ऐसा होगा that consumer will become net buyer of good one. Okay? ठीक है बेटा. Homework question. Consider a situation when consumer is initially net buyer of good one. Price of good one increases. How will equilibrium change? Try to do this question for the next class. Okay. Hi, good afternoon, good evening, everyone. Better now we will go ahead and take this homework question first because this is very important question. देखो पढ़ो ध्यान से. Try to read the question. It says, consider a situation when consumer is initially net buyer. तो माने I have a budget line. ये good one है. This is good two. But it is passing through the endowment bundle. यहाँ कहीं पे हमारा endowment bundle है. Omega 1, omega 2. And initially consumer is net buyer. Net buyer माने initial equilibrium यहाँ कहीं पे. It is consuming more than endowment. So हमारा initially equilibrium point A है. Initial equilibrium point A. बेटा मतलब अगर if the consumer is preferring A, so he is preferring A over all possible affordable bundles. तो क्या क्या इस टाइम पे वो खरीद सकता था? Anything on the budget line or below the budget line. So A is preferred over shaded region. A is preferred over shaded region. अब देखो ध्यान से, try to read it out what it is saying. It is saying price of good one increases. तो बेटा ध्यान से समझो, if price of good one increases तो क्या हो जाएगा, P1 by P2 भी increase हो जाएगा. If P1 will increase, P1 by P2 will also increase. तो बेटा slope of budget line increase हो जाएगा. नेगेटिव साइन मत सोचो, जस्ट थिंक लाइक दिस. सपोज इफ आई टेल यू प्राइस ऑफ गुड वन 2 है, प्राइस ऑफ गुड टू भी 2 है, तो स्लोप अभी तक है 2 डिवाइडेड बाय 2 1. स्लोप क्या होता है, परपेंडिकुलर बाय बेस, तो परपेंडिकुलर भी 1 है और बेस भी 1 है. ये लाइन है बजट लाइन. नाउ प्राइस ऑफ गुड वन हैज इंक्रीज्ड, माने सपोज प्राइस ऑफ गुड वन 3 हो गया, सो व्हाट विल बी स्लोप, P1 by P2, 3 by 2, 1.5. तो अब परपेंडिकुलर 1.5 है और बेस 1 ही है, सो लाइन विल बिकम स्टीप. So whenever price of good one will increase because the slope is increasing, तो क्या होता है, budget line becomes steeper. Budget line becomes steeper. But budget line passes through the endowment bundle. Endowment bundle अभी भी affordable है, it is still affordable. So budget line will pass through the endowment bundle. Is this making sense? तो I have to draw a steep budget line passing through the endowment bundle. माने मेरा budget line ऐसा कुछ हो जाएगा, like this. You can take example also. कोई एक endowment bundle ले लो, W1, W2 is 1,1, है ना. तो अर्लियर आपका इनकम क्या आ जाएगा, व्हाट कुड बी योर अर्लियर इनकम बेटा, इट वुड बी 2 into 1 plus 2 into 1, it will be 4. And beta, what will be your new income? It will be 3 into 1 plus 2 into plus 2 into 1, which means it will be 5. है ना. So what will be your earlier intersection points? X-axis intersection will be income by price of good one, 4 by 2, 2. Y-axis intercept will be what beta? Income by price of good 2, 4 by 2. That means 2. What will be your new intercept point beta? X-axis intercept point will be income by price of good one, 5 divided by 3, 1.33. And y-axis intercept क्या हो जाएगा बेटा, income by price of good 2, 5 divided by 2, 2.5. तो y-axis intercept earlier it was 2, now it is 2.5. X-axis intercept earlier was 2, now it is 1.33. Is this clear? Is this clear? So budget line has become steeper. Budget line has become steeper. समझे? Now it is saying that which will be your new bundle? How will your equilibrium change? तो we cannot consume in the orange region. Orange region में तो हम नहीं consume कर सकते हैं, because over that bundle A was preferred. A को हमने पहले ही prefer कर दिया, तो हम इसमें नहीं, यहाँ नहीं consume कर सकते. We have already given preference to bundle A, so we cannot consume in this part of the budget line. No. So where can we consume beta? We can consume here, in this part of the budget line. नए बजट लाइन पे we cannot consume in this part. हम इस वाले रीजन में कंज्यूम नहीं कर सकते हैं, because this region will give me a lower indifference curve. It will make consumer worse off. So we can only consume in this region beta. So somewhere here can be your new equilibrium. And at new equilibrium अगर हम देखें तो consumption is less than endowment. So it means that consumer will now become net seller of good one. कंज्यूमर विल नाउ बिकम नेट सेलर ऑफ गुड वन. ये बहुत इंपॉर्टेंट है फ्रॉम एग्जाम पॉइंट ऑफ व्यू. इट्स वेरी वेरी इंपॉर्टेंट. कंज्यूमर विल नाउ बिकम नेट सेलर ऑफ गुड वन. इज दिस क्लियर नाउ? ठीक है बेटा. नाउ लेट्स टॉक अबाउट ऑफर कर्व एंड डिमांड कर्व. ऑफर कर्व एंड डिमांड कर्व. तो बेटा व्हाट इज प्राइस ऑफर कर्व? पीओसी क्या था? प्राइस ऑफर कर्व इज जॉइनिंग all equilibrium points when price of good changes. Joining all equilibrium point when price of good changes. है कि नहीं है? That was the price offer curve, right? And beta, what is the demand curve? When we draw price on one axis and demand on other axis, तो बेटा वो डिमांड कर्व हो जाता है. तो let us try to go ahead and let us try to see this now. इस पे आ जाते हैं. Let us try to go ahead and let us try to see what we have learned here, beta. So try to notice here, beta, initial equilibrium point क्या था? Point A. New equilibrium point, point B. Point B क्या reflect कर रहा है here? It is reflecting what happens when price of good one increases. यही तो हमने दिखाया that when price of good one increases, how demand of the good will change. है कि नहीं? So when we are talking about price offer curve, it will join all equilibrium points. माने if I join point B and point A, जो मुझे मिलेगा that will be my price offer curve. Joining all equilibrium points, अगर हम सारे equilibrium points को join कर देते हैं as price changes, when we join all equilibrium points, that is my price offer curve. बात समझ में आई? Similarly, if I go to one more diagram here, बेटा, ये जो हमने last class में किया था, one more diagram. So if you notice, here we were showing decrease in price of good one. Initial equilibrium point ये था बेटा, you remember? New equilibrium point ये था. If I join all equilibrium points, let me do it with a separate color. If I join all equilibrium points as price changes, जैसे जैसे price change हो रहा है, जो हमारे different equilibrium points आ रहे हैं, as I go ahead and I join all different equilibrium point as price changes, that is called as price offer curve. So this is my price offer curve. Clear हुई बात? So price offer curve is nothing but the different equilibrium points joined together. Locus of different equilibrium points. जब हमने अलग अलग equilibrium points को join किया as price changes, it is the price offer curve. Now let's talk about the demand curve. To plot the demand curve, we can take price on one axis and demand of good on other axis. So price of good one, demand of good one. ठीक है. बीच में मैंने I have just made one point here, beta. This is my endowment bundle. This is my endowment bundle. ठीक है. अच्छा, now tell me something. बेटा, पहले जो प्राइस था, इनिशियल प्राइस, उस पे हमारा डिमांड कितना था? A, है ना? इनिशियल इक्विलिब्रियम पॉइंट था A एंड डिमांड इतना था. न्यू इक्विलिब्रियम पॉइंट हुआ B डैश एंड डिमांड इतना हो गया.
So when my price increased, जब price of good one increase हुआ, when price of good one is increasing, demand of good one is decreasing. पहले हम endowment से ज्यादा डिमांड कर रहे थे, अब हम endowment से कम डिमांड कर रहे हैं. So when price of good one was suppose some P1, कुछ एक प्राइस था, we were demanding more than endowment. यहां पे हम endowment से ज्यादा डिमांड कर रहे थे. And when price increased, so we are demanding less than endowment. तो जब प्राइस इंक्रीज हो गया, we are demanding less than endowment. If I join these points, but I get the demand curve. When we join these points, we get the demand curve. So demand curve is showing relationship between price and demand of good X. What it is showing? Price and a relationship between price and demand of good X. समझे बात को? Is this making sense? Right? So this is how we can plot the demand curve. ठीक है. अच्छा, one last thing here I want to explain. Sometimes they ask, find net supply. तो बेटा net supply क्या होगा? When is there a supply? Supply कब होती है? You will be supplying if you consume less than endowment. अगर मेरा consumption endowment से कम है, only then I will be supplying the commodity. भाई, I came with 10 units. I am consuming 4 units. तभी तो मैं 6 units supply कर पा रही हूँ. Only then I am able to supply 6 units. So supply can be written as the difference between endowment and consumption. ये endowment, that minus 10 minus 4, ये ही तो supply है, this 6 units. So net supply will be endowment minus consumption, right? As long as it is positive. As long as it is positive. ठीक है. अच्छा, if बेटा endowment suppose 10 units था and consumption 12 units हो गया, तो am I supplying anything in the market? No, I am not supplying anything in the market. अब भाई, I came with 10 units, I am consuming 12 units, so there is zero amount supplied in the market. उल्टा मैंने मार्केट से 2 और यूनिट्स ले लिए. I purchased 2 more units from the market. So my supply curve will be 0 if it is not positive. अगर ये अमाउंट endowment minus consumption नेगेटिव आता है, जैसे यहाँ पे endowment 10 units था, consumption 12 हुआ, I am not supplying anything to the market. मैंने मार्केट को कुछ सप्लाई नहीं किया. I purchased from the market, so supply is 0. This is the equation of supply curve. इसको बोल देते हैं equation of the supply curve. Right? ठीक है बेटा. Again, let me go ahead and give you one homework question. So, price of good 1, 2 rupees. Price of good 2, 3 rupees. Endowment bundle 5,6. New price of good 1, 1 rupee. Find offer curve and demand curve of good 1. Find offer curve and demand curve for good 1. ठीक है? Just try to do this on your own. ओके बेटा, थैंक यू। हेलो बेटा, गुड आफ्टरनून एवरीवन। तो बेटा, गिव मी अ मिनट। Okay, hi, good afternoon, everyone. Beta, today we will go ahead and we will talk about the application of buying and selling in endowment. ठीक है। अब इस केस में फर्स्ट ऑफ ऑल वी वांट टू गो ahead and we want to examine what happens when the price of the good changes. तो अब देखो ध्यान से, see in this particular case when price of good will change, when price of good will change, तो बेटा इससे क्या हो जाएगा? when price of good changes, it is going to go ahead and it is going to change value of endowment. It will change value of endowment. जैसे ही price of good change होगा, it will go ahead and it will change the value of endowment. और अगर value of endowment change हो गया, so it will change income of consumer. तो ये एक एडिशनल, दिस इज एन एडिशनल इफेक्ट, है ना? दिस इज एन एडिशनल इफेक्ट। अभी तक क्या होता था, व्हाट वाज हैपनिंग टिल नाउ, दैट ओके योर बजट लाइन वाज P1X1 प्लस P2X2 equal to income of consumer, and when price of good one, if it was changing to P1 dash, तो budget line was changing to P1 dash X1 plus P2 X2 equal to income of consumer. माने प्राइस के चेंज होने पर the budget line was changing, right? But there was no impact on income of consumer. Income of consumer was constant, right? अभी तक income पे कोई change नहीं था. The income of consumer was constant. But बेटा, in the presence of endowment bundle, जैसे ही हमारे पास endowment bundle आया, in the presence of endowment bundle, what is income of consumer? Value of endowment bundle. जो endowment bundle का value है, whatever is the value of the endowment bundle, that will become the income of the consumer, है कि नहीं? And when this endowment bundle value will change, whenever price or endowment changes. But what is the value of endowment bundle? P1 omega 1, P2 omega 2. तो माने जब भी प्राइस चेंज होगा, तो जो बंडल हम मार्केट में लेकर आ रहे हैं, वॉट एवर बंडल वी आर एंटरिंग द मार्केट विद, दैट विल ऑल्सो चेंज. एंड व्हेन दैट विल चेंज, सपोज प्राइस डिक्रीजेस, तो बेटा वैल्यू ऑफ एंडोमेंट बंडल विल डिक्रीज. है कि नहीं? अगर किसी चीज का प्राइस गिरेगा, सपोज आई ब्रिंग वन ऑरेंज एंड टू एप्पल्स, वन ऑरेंज प्राइस वॉज 10 rupees. Now the same orange is for 5 rupees. So price of orange has decreased. So when price of orange will decrease, तो मेरा जो इस बंडल का वैल्यू है, it will also decrease.
When the value of endowment bundle will decrease, it will decrease the income of consumer. है कि नहीं है? It will decrease the income of the consumer. But this is called as the endowment effect. This is called as the endowment effect. Is this clear? So what is endowment effect? What is the endowment effect? Endowment effect is understanding कि जब आपका प्राइस चेंज होगा, the value of endowment will change. When this will change, तो आपका जो इनकम है वो चेंज होगा, और जब वो चेंज होगा तो आप जो गुड डिमांड कर रहे हो वो भी चेंज हो जाएगा. डिमांड ऑफ गुड विल चेंज. Whatever good you are demanding, that will change. When we try to find this effect, that is called as the endowment effect. उसी को हम endowment effect बोलते हैं. Right? Is this clear? ठीक है. अब ध्यान से एक बारी let's try to understand this a bit more. थोड़ा सा और समझने की कोशिश करते हैं. So till now, whenever we were writing our Slutsky equation, we had two kind of effects. हम लिख रहे थे टोटल और प्राइस इफेक्ट इज इक्वल टू इनकम इफेक्ट प्लस सब्स्टिट्यूशन इफेक्ट. ये लिख रहे थे. सो वी वर सेइंग दैट व्हेन प्राइस ऑफ गुड डिक्रीजेस, तो फर्स्ट relatively गुड becomes cheaper. वो गुड सस्ता हो जाता है जब उसका प्राइस गिरता है. सो यू इंक्रीज द डिमांड ऑफ दैट गुड. This is called as substitution effect. Whenever price of the good decreases, relatively the good becomes cheaper. वो गुड दूसरे के मुकाबले सस्ता हो गया तो आप उसका डिमांड इंक्रीज कर दोगे. This is called as substitution effect. But the other thing that we studied is income effect, which says that when price of good decreases, real income increases. जब भी एक गुड का प्राइस डिक्रीज होगा तो रियल इनकम इंक्रीज हो जाएगी. And when real income will increase, then for normal goods, demand will increase. For normal goods, demand of the good will increase. Clear है? But now we have an additional effect. एक तीसरा effect आ गया, which is the endowment effect. ये हो गया additional effect, which is the endowment effect. जो क्या कह रहा है? That when price of good decreases, then value of endowment bundle will also decrease. जो बंडल मैं मार्केट में लेकर आ रही हूं उसका वैल्यू डिक्रीज हो जाएगा. सो दिस विल डिक्रीज द इनकम ऑफ द कंज्यूमर. एंड बिकॉज इनकम कम हो गई, दिस विल चेंज द डिमांड ऑफ गुड. राइट बेटा? तो बेटा दिस इफेक्ट दैट वी आर स्टडिंग हियर, ये हो गया आपका endowment effect. This is your third effect and this is called as your endowment effect. So there are three effects. One is called as substitution effect. Other one is called as income effect. Other one is called as endowment effect. तीन effects हो गए, right? Now if we go ahead and if we look at our Slutsky equation, so what was the equation beta? Change in demand due to change in price. इसका दो components थे.
substitution effect प्लस इनकम इफेक्ट. यही डिराइव किया था हमने, substitution effect plus income effect, right? So we were saying that there are two impacts. इसको बोल रहे हैं हम substitution effect and this is called as income effect. Now we are saying that we are rewriting this equation. इसी Slutsky equation को, this Slutsky equation, I am rewriting this equation और इसी में हम एक नया effect include कर रहे हैं and that effect is called as endowment effect. That effect is called as endowment effect. So there is a third effect in Slutsky equation, beta. This is your new Slutsky equation in which हमारे पास एक additional effect आ जाता है, which is the effect of the endowment effect. We have an additional effect, right? And what is my endowment effect? Endowment effect is basically nothing but change in demand due to change in income into change in income due to change in price. इसको थोड़ा सा समझ लेते हैं. Let's try to understand this thing. तो बेटा क्या हुआ? When suppose price of good one decreases, तो वैल्यू ऑफ एंडोमेंट डिक्रीज हो जाएगा, P1 ओमेगा 1 प्लस P2 ओमेगा 2. व्हेन प्राइस ऑफ गुड वन विल डिक्रीज, तो ये वाला जो वैल्यू है, दिस वैल्यू विल डिक्रीज, है कि नहीं है? वैल्यू ऑफ द एंडोमेंट बंडल विल डिक्रीज. बेटा इफ वैल्यू ऑफ एंडोमेंट बंडल विल डिक्रीज, तो आपका इनकम विल डिक्रीज. सो प्राइस के चेंज होने से इनकम इफेक्ट हो गया. This is this change in income due to change in price. And when income will decrease, so demand of goods should change. तो ये वाला हो गया change in demand due to change in income. ठीक है. So this is my endowment effect. This is my endowment effect. समझे? Is this clear? Okay. Now, बेटा we know कि income of consumer इस केस में is value of endowment. What is the value of endowment? P1 omega 1 plus P2 omega 2. Let us bring change throughout. हर जगह change लिख दो. So change in income, P1, change in P1, omega 1 एक constant मेरे पास बंडल है जो मैं मार्केट में लेकर आई हूं, राइट? So that is constant, plus change in P2 into omega 2. But currently I am only evaluating change in price of good one. हम सिर्फ एक गुड का प्राइस चेंज कर रहे हैं. We are only changing one good price. So change in P2 को हम 0 assume करेंगे, right? So I will get change in income is equal to omega 1 change in P1. So change in income by change in P1 will be omega. Clear हुआ? So this is this part. How income changes when price changes. देखो, how income changes when price changes. This is omega 1. Clear? ठीक है. तो what can be written as endowment effect बेटा? ध्यान से देखो, what is endowment effect? How demand changes when income changes. How X changes when income changes. Into how income changes when price changes, जिसका वैल्यू हमने निकाल लिया है omega 1. So into omega 1. This will be your endowment effect. So this endowment effect, अगर मैं इसी इक्वेशन पे वापस आ जाऊं, I can rewrite this equation as this. है ना? अच्छा, from this can I take this common बेटा?
So I can rewrite this equation as this. I can rewrite this equation as this. Is this clear? So this is my Slutsky equation. ये मेरा Slutsky equation हो गया. Okay? Okay, beta.